What's up YouTube? This is Dennis Panuta for tutorials.eu. In this video you are going to learn the fundamentals of Python. It's an 8-hour long course. It's the basics of this wonderful programming language that is called Python, and it is hot because it is used in many different areas. For example, in machine learning, in data science, and in many other areas. And it's super duper important right now. That's why I highly advise you to check it out. And you are going to learn how to create applications with Python by learning the basics, by having exercises in this video, by having additional challenges and a bunch of projects which will help you to understand what you've actually learned. All right, so this is just the beginning of your journey. You can afterwards, of course, go ahead and learn more about Python or learn more about machine learning. And by the way, if you like this video and if you hit the subscribe button and the notification bell, it's very likely that there will be a machine learning course similar in length to this one in the coming weeks. So make sure to smash that like button, because that also signals to me that you are interested in Python content and my audience is interested in Python content and that I should create more of it. All right. And by the way, if you want to learn even more about Python and you think that the teaching style that I have is great and the content is good and so forth, then you can of course check out the link in the description. You can find a link to my full masterclass, which is a 30+ hour long Python course in which you are going to learn a lot more about Python. You're going to learn how to build user interfaces with Qt. You're going to build a web crawler. You're going to see how to create websites with Python, using HTML of course. Then you will also learn the basics of data science. We are going to look into image processing and many more applications of Python. So I give you a peek into different areas where Python is used, and this will help you to become a better Python developer and really ensures that you understand very well what you've learned in the fundamentals section. All right, so if you want to learn more about it, of course, check out the link in the description. You can get a huge discount by using the link. All right, so now let's go ahead and dive right into the content. I hope you enjoyed and wish you all the best on your journey to becoming a Python developer.
Hello and welcome to the introduction of the Python course. In this introduction video, I would like to show you what you can expect from this course and what you are going to learn throughout the course. So, first of all, thank you for letting me teach you Python. I'm super happy that I can do this. And teaching has been my passion for years, and I'm super happy that there are thousands of people who learn coding in general from me. So thanks a lot that you specifically chose me to teach you Python. Thanks a lot. Then the next one is, it's super important that you have fun with the course. So before you feel pressured that you have to understand everything and that you have to get through it very quickly or achieve your goals super quickly, there is one thing that is very important, and that is that you have fun with the course. So really just keep a pace that is fun for you, then also go through the exercises and try to make them your own and really just enjoy the course. So let's have a look at what you can expect. I've developed this course to give you a comprehensive overview of the programming language Python. And that means that you are not going to only learn the Python basics, but a lot more, especially because Python is a programming language which is used throughout many different areas. And that's really why it's so powerful and interesting, because you can use it, for example, to write desktop applications, to write web applications, to write ethical hacking tools, to write crawlers, and also to use your Raspberry Pi or develop for the Raspberry Pi or even Arduino and those kind of things. So it's pretty powerful and very cool to use. You will learn Python including various application scenarios. And that's exactly what I was talking about. There are so many areas in which Python is used, and that's why you will simply go through multiple of them to see those areas and to see which kind of areas you prefer. So which type of Python programming you prefer, or which application of it you prefer most. Then this course was particularly complex in development. There are many quizzes, exercises, and fact sheets. And of course, you're going to have sample solutions. So this course contains a comprehensive sample solution for almost every exercise and quiz. So if you answered the quiz or exercise correctly, you can simply skip those sample solutions. because I just realized that it really makes sense to make sure that my students really understood what the reasoning behind code, for example, is, or the reasoning behind choosing one or the other solution in different cases. And that's why you will find a video after every exercise or quiz. And the sample solutions, they're just one solution. As usually in programming, there are multiple ways of handling something and multiple ways of finding a solution. So the sample solution is just an example of how things can be done. How is this course structured? Well, we start with the basic Python functions, where you will learn the very basics of Python. Then you will see how to open files, how to draw graphics. You will learn about lists and dictionaries, where you can pretty much store multiple pieces of data in one variable. Then you will see object-oriented programming, so how object orientation works in Python and how you can model data. Then we are going to create a little web crawler, including an example. So you will see how to generally crawl through a website and get the data that you want and display it somewhere. Then you will learn about data structures. You will see how you can create websites with Flask, including an example where we will pretty much create a website in which a user can enter two currencies and the exchange rate, and the website will then display a table with multiple different values and the counter values in the different currencies. We will check out Jupyter and Jupyter widgets, in which you can pretty much create buttons and text fields and other kinds of graphical user interface elements in your browser. Then we're going to build multiple desktop applications with Qt. But before we start, we need to install the tools you need right now. So we are going to use Anaconda for that, which is pretty much a bundled package, which includes pretty much everything we need. We will download this in the next lesson and install it together with you. So in case you have questions, then you first of all should search the internet. And when you search the internet, you will very often find the website Stack Overflow, where you can pretty much ask your questions and find a solution very quickly, or the question that you have is already there multiple times and experienced programmers have already answered those questions. So you can most of the time find a solution to your problem without having to ask even. And if you don't find anything there, then of course you can go ahead and write your question in the discussion forum. Describe your mistake first, then tell me about your operating system, the Python version you're using, and everything else that you think makes sense for me to understand how to solve your problem or how to help you with your problem. And then let me know what you have already tried so that I can help you in the best way possible and as quickly as possible. All right, thanks a lot for listening and have fun with the course. See you in the next video. Hello and welcome back. In this video, we are going to prepare Jupyter or install Jupyter, which allows us to create Python code and run it. And that's a great thing because that's exactly what this course is for, right? So let's go ahead and install Anaconda for that, because as you can see here, we need Jupyter, well, we can use Anaconda in order to install Jupyter. There are other ways with pip and so forth, but we're going to use the simple one, which is the Anaconda version. Therefore, we can either press the Anaconda button here, so the download button, or you can go to www.anaconda.com and /downloads. And there you will find this screen here where you can simply go ahead and install the Python version 3.6, because that's the one that we're going to work with. And here, as you can see, it's available on the three main operating systems: Windows, Mac OS, and Linux. And as I'm running this video on a Mac OS or this browser, I'm going to download the Mac OS version. So just press this download button and it usually should download the graphical installer for you, which is much easier to use and handle than the command line installer, especially if you're a beginner with this. And after you press the download button, this PKG file comes up, this Anaconda 3 version 5.2 in my case. In your case, it might be a different version depending on when you open up this video. And I'm just gonna start this PKG file, and on Windows it will be an exe file, an executable file. And in my case it says we'll run a program to determine if the software can be installed. That's a great thing. Let's continue. And then we can simply press continue multiple times. We can read through all the important information here. That's always good. Then just continue. Then you should read through the end user license agreement and press continue once you read it and you agree with it. It's important to read the license in order to understand what you're agreeing with, right? So once you're done, let's press the agree button. And as you can see, it will take up 2.17 gigabyte in my case. Maybe it's a little more or less depending on the version you're installing. You can change the install location if you want to use a different directory, but I'm just gonna leave the standard one and I'm gonna install. And that will take a little while as well. So I'm gonna cut the video to the point when it's done. All right, once that is done, it's asking us whether we would like to install Microsoft Visual Studio Code, and I'm just gonna not install it. So I'm just gonna click continue here. All right, once that is done, you can go ahead and share your notebooks and packages on Anaconda Cloud if you sign up there, and we might do that later on, but for now we're just gonna close the installer. And we can even move the installer file to trash. So let's just do that. All right, now the installation is done. So we can open up Anaconda and you can simply enter Anaconda 3 with command space in Mac, or you can use the Windows key in order to search for Anaconda 3. And in my case, it's under the Anaconda folder or Anaconda 3, and there you'll find the Anaconda Navigator app. So once I click on that, it opens up. And I can see this interface here, which is the Anaconda Navigator. And there you can use either Jupyter Lab in order to develop with Python, or you can use Jupyter Notebook. And that's the one that we are gonna use. You can of course check all of them out here. There are multiple tools that you can use in order to use Python. And the one that we will use mainly is going to be this Jupyter Notebook. So I'm just gonna launch that. And that will open up a browser tab. And that depends on the browser that you use, preferably. In my case, it's Chrome. So it opens up this tab under localhost. And here you can see all the files on my PC. So I just press the desktop here. And you can just select the folder where you have downloaded your course material to. And it's important that you unzip it. So you need to open up the zip file, and it will open up this folder called course material, where you will find all of these folders. And these are the folders of the different chapters. So for chapter 2 and 3, we have the Python basics, then 4 and 5 are control flows and so forth. And in those folders, you will find all the different files, which we will use in this course. So let's go ahead and create a new file. And therefore you can simply press new here on the top right side. And I'm just gonna create a Python 3 notebook. As you can see, notebook, Python 3, that's what I want. And that opens up a new tab in which I can now see my IDE, which is an integrated development environment, which allows me to run code and execute it quite easily. So what we have here is, first of all, a bunch of settings and options to choose from, then plenty of buttons, which we are going to use step by step. And then we have these cells. So in this case, we have only one cell, and I can enter my code in here. So I can enter Python code in here and execute that. So let's start with a very basic, simple hello world example. Therefore, I enter print, then brackets, and in quotation marks, I enter the code that I would like to display, or the text that I would like to display. And in my case, that's just going to be hello world. So I'm just going to display hello world onto my console. And that means that as soon as I execute the code, so as soon as I run the code, I'm going to get this hello world printed onto my console. And that's why Jupyter Notebook is such a great tool, because you can enter your code in a cell, and just below the cell, you see the output of that code. So in our case, it's just this little text which says hello world. So now we created our very first Python code, which simply prints a specific text onto the console. And of course, we're going to use much more complex examples in the future, and we're going to create much more complex code. But that's a great starting point, and I'm very happy that I am the one to teach you Python. Thank you very much for that. And I hope you enjoyed the course, and I wish you all the best for your journey on the Python road. So see you in the next video. Welcome back. In this chapter, we are going to start with the Python basics and the very basics. And therefore, it's important to look at numbers and variables. in general, when you work with programming, then you need to handle numbers. And that's very important because pretty much everything is somehow based on numbers. And if you get a task where you have to do something, it's very often connected with numbers. So we're going to cover numbers quite a bit. And of course, we also have to look at variables, which allow us to store data. For example, they allow us to store the result of a calculation. They allow us to store information about a user and so forth. And that's why they are super important, and they're the very basic of any programming language. As soon as we have that, we will look into lists, and lists allow us to store multiple data at one point. So multiple sets of data. And that's generally going to be useful in multiple cases. You will see as soon as we get there. Then there is something to apply the knowledge. So we're going to apply the knowledge straight away by using graphics. So we're going to display graphics, and we're just going to use this approach because it's easier to remember or easier to understand what's going on if you see a graphic that explains what's going on, right? Because people are usually visual, and that's why it's really good to use it that way. It's not that we need to use it that way, but it's going to help you to understand what's going on. And then we're also going to convert data types. So we're going to see how we can take one type of data and convert it to another type of data. And that is important for our program to run correctly, because if we use the data in a type of a string, so it's just a text, and we want to use that as a number, let's say we have a string which contains a number, then the program won't understand that. So we will need to convert that data into another type. So we need to convert it into a type that the computer will understand, or the programming language Python will understand. And that's why we're going to look into converting data types as well. All right, I hope you're ready. And these are really just the basics. You will see multiple examples and you will code along. So I hope you enjoyed this chapter, and see you in the next video.
All right, thank you very much that you're still with me. You've been around for a couple of minutes already, and I hope you enjoyed so far. And by the way, if you want to get the full course, check out the link in the description. You will not only get additional projects, additional Python knowledge, many different applications, but you will also get quizzes, a 5-star customer support, and a bunch more great features that will help you to become a real Python developer. So check out the link in the description, get a huge discount, and join the community.
Welcome back. In this video, we are going to look into numbers, and we're going to use numbers a lot in this course, and we're going to use most of the time simple numbers, so not too complicated, right? All right, so one thing that I wanted to show you before we go to numbers is that you can change the name of your file by clicking on the title here, and currently it's called untitled. So this file that I have here is auto-saved, and it has a title which is untitled, and you can rename that notebook anytime by just pressing on it. Just click on it and then you can rename it, and I'm gonna rename that to Hello World because that was the Hello World example. Super simple, just setting out print Hello World. And if you want to create a new file, you can go to File, New Notebook, and then select Python 3, and that will open up a new tab. And that's what we're gonna do now. So now we're gonna work with numbers, and I'm gonna call this notebook numbers straight away. So now in my files, it will be available as numbers, and you can simply select the file numbers from the materials, from the course materials, if you want to compare the code with your code. All right, so let's go ahead and print our first number onto the screen. And as you have seen with Hello World, you can also just print numbers onto the screen. For example, we can go ahead and print 5. Now, in order to execute the code, we can either press run here, or we can press shift enter. And with shift enter, you have to hold shift while pressing enter. It will display the 5 onto our console. So that's a very simple example. We can also print multiple lines or use multiple lines within one cell. So I can say print 5 and print 6. So please print those two numbers. And again, shift enter in order to execute the code. And as you can see here, we are in line 1 here, and this is our second line where it starts. But then the next time I'm entering something here, it's gonna go to the next line again. So If I print, for example, 5 plus 4, that will print the result of 5 plus 4. So that will give me the result of the summation. Then you can also use print 5 minus 4. That will give me the result of the subtraction. So that will be 1. As you can see, 5 minus 4 is 1. Then the multiplication, print 5 multiplied. And in order to multiply, you use the star. So 5 multiplied with 4 will be 20. And then print 5 slash 4 is going to be the division. So 5 divided by 4, and that will be 1.25. So in order to execute that, Shift Enter. As you can see, now we have this result. Now you can go ahead and use things like this. So you can use more complex calculations here. So let's say I want to calculate 5 plus 4 multiplied with 3. And if we do that, we get 9 multiplied with 3, which is going to be 27. And there we are, the result is 27. You cannot only use whole numbers, you can of course also use decimal numbers. So let's say I want to use, or want to print 1.25 plus 2. That will give me 3.25. And now there's something to consider, which is important if you have programmed with other programming languages. There's one thing that distinguishes Python from other programming languages. So in other programming languages, you have to be super careful whether you use a decimal number or a whole number. And in Python, that's not very important. So the Python handles it either way. So it doesn't care whether it's a decimal number or a whole number, and you can use them as you like. And of course, on a hardware level or on a processing level, it will use it accordingly. So it will store a decimal number in a different way than it will store a whole number. For example, 1.25 will be stored in a different way than the 2 will be stored. But for us on a programming level, it doesn't really matter. So we can use them as we like, and you will see multiple examples of that. So that's quite different to, for example, Java or C# or other programming languages. All right, so that was a little starting point into numbers. In the next video, we're going to look into variables. So see you there. Welcome back. In this video, we're going to look at variables, a very, very important concept of any programming language. But before we do that, I would like to show you some minor things about Jupyter notebooks so that you can understand things a little better. So I'm going to create a new notebook for that, a new Python 3 notebook. And if ever I want to change the name, we know already how to do that. We can change the name of the notebook here. So I'm going to call that variables, and I'm going to press the rename button. Now there are multiple options of what we can enter within one of those cells. It doesn't always have to be code. For example, print something is a code example, right? Now there are other options. We can choose them from here. So there's a drop down box here or list. If you press on it, it opens up and you can select the different versions. And what is important for us now is the heading, and the markdown. The code we used already, but let's have a look at the heading. If you press on heading, here it says Jupyter no longer uses special heading cells. Instead, write your headings in markdown cells using the hash characters. So here, hash or double hash is a or level 2 heading. So let's have a look at that. We use a hash, which is a level 1 heading. So this is going to be my heading 1. I press Shift Enter in order to display it. Now I'm going to do the same here. So I'm going to use a heading, or this time a markdown. And I use double hash and heading 2. And then Shift Enter. And as you can see, this is a heading 1 and this is a heading 2. So heading 1 is bigger than a heading 2. But that's generally how you can use markdowns in order to use headings. But you can also simply write text in here. Something like, this is how you create a heading. And in my case, it thinks it's code. That's why we have this is in a green color. But if I change that to markdown, suddenly it's not anymore. And as you can see on the left hand side, we don't have this LN, which stands for line, We don't have that anymore. So this is how you create a heading, hash, and heading name, something like that. And now I use Enter Shift in order to display it. And now as you can see, this is simple text that you can see displayed in here. And why do I show you that? Well, if you check out the notebooks, the Jupyter notebooks that I provide with this course, you will find that there are plenty of comments and headings involved in there. So you can find that or read through that, of course, and check out whenever you like. So you don't have to rewatch the whole video. You simply can open up the notebook if you want to check out a chapter once again or a specific lecture once again. You can simply read through it if you just want to refresh what you have learned. All right, so let's have a look at variables then, because I wanted to talk to you about variables in this video. So let's get rid of some of the cells. And for example, we can simply use this cut button, and that will cut the whole line. So it will cut it away. You can also copy lines and you can paste lines. So that's totally possible. So here I just paste whatever I had in the clipboard. All right, so let me get rid of that as well. Now let's go ahead and use variables, and I'm gonna give it a heading here, which is gonna be, well, it's displaying it again, variables, and hash enter, and this is going to be displayed here. So what is a variable? Well, variables are a generally essential concept of programming languages. So let's have a look at what a variable looks like. So far we have stored the number 5 nowhere. So let's say we printed something onto the screen, it just said print 5. So we didn't store this 5. But what if we wanted to store it somewhere and reuse it later on? Then we use variables. And in order to create a variable, it's very simple in Python. You just enter a name for that variable, for example, just the letter A, and you give this variable a value. So let's say I want to assign 5 to that variable. So I simply do it like that. If I now want to print that, I can simply print A on the console. And as you can see, it prints 5. That's because 5 is stored within that variable called A. Now we can go ahead and even use A in order to store a calculation in there. So store the result of a calculation. So let's say we want to add 6 to 5, then we just enter that and we can now print the result of that. Let's say we print A, and as you can see, now we get the result, which is 11. Also, what we can do now is multiply it with each other. So print A multiplied with A. So I want to change that, A times A, and shift enter, and as you can see, 11 times 11 is 121. Now what if I want to have another variable in here? So I'm gonna just create a variable called B, and that's going to contain the value 5 as well. Very basic, but now as you can see, A doesn't actually contain the value 5. It was at the beginning, so it had it at the beginning, but then it was overridden by the value 11, and that's why it printed 11 here. So the variable always is the latest entry that was given to it. So the last time that it was given a value, and in this case it was given the value of 11. All right, so now we have this B equals 5, and what if we want to print something like 5 times 5 times 5? Then we can just say B times B times B. Now you say, okay, I could have also just entered 5 times 5 times 5 and I wouldn't need this additional line. That's fine. Let's have a look at the result. You see it's 125. But what if I now decide that it's not that it's not 5 for B, but it's, let's say, 3? Then I don't have to change the value 3 times, but only once here at the declaration. So this line here of this variable called B. Now if I execute that code once again, as you can see, I get a result of 27. Now that by itself is already great. It saves us time whenever we want to make a change and stuff, but it's even better when we, for example, want to calculate the average of two values or multiple values. Let's say we have an age, somebody's 21 years old, and we want to have the average age of our group, whatever that group is. Is it my fellow students? Is it my classmates? Is it my people at work? Or is it the football team? and I want to have the average of all of the players. Well, then you can go ahead and create a variable called age and another one called age2. Of course, you could call them something like age John, age Michael, age whatever you think of, whichever people you have in a group, and you enter those names or in there, and you enter their ages into the variables. So let's say the first age is 21, the second age is 18. Now if I print that onto the console, let's say I want to have the average of those two, I'm just gonna say age plus age2 divided by 2. Why by 2? Well, because we have two values. If you want to have the average, you simply add the values to each other, and then you divide by the amount of values you had. And in this case, we had two values. That's why we divide by 2. And that will give us the end result, which is the average of the two ages. So let me display that on the screen. And as you can see, it's 19.5. Now, what if I wanted to store that average age in order to use it somewhere else? Maybe I want to display it on multiple different spots in my application, or I want to print it on multiple spots. Then I can simply go ahead and create a new variable called average underscore age. And I'm gonna assign age plus age2 in brackets divided by 2. And that will store the average age. So what we had before printed onto the screen, it will store it within that variable. Now if we print that onto the console once again, so now we print the average age onto the console, what we will see is we get this 19.5. So the value that we calculated earlier on was stored. And how did we get this value? Well, we got it by using two other variables. So you can calculate around with variables. And that's just a simple example of what you can do with variables. Variables are super powerful and very important, and you could store so many different information in there. And that's why we will look into variables a lot, and we will use them plentiful. And yeah, that's pretty much it about variables for now. So why don't you play around with values that you think of yourself, create a little average calculator for your family maybe, where you take the age of all your family members and then you calculate the average of your family ages. And well, in general, just play around with values and variables. That will help you to get a better feeling for it and will make it easier for you to move along in the course. All right, so thanks a lot for following this video, and see you in the next one. Now that you've seen what variables are, we will have to check out strings because they are the next important topic on the list. So let's go ahead and create a new file for that, or at least I'm going to do that. You don't need to do that if you just want to keep on using the same file. That's totally fine. All right, and I'm gonna rename it. I'm gonna call it strings straight away. And there is something about strings that you should know. First of all, we had this print hello world. And now hello world, what is inside of the quotation marks, that is called a string. So let me execute that, and we get hello world printed onto the console. So that's nothing new. The only thing that is new is that this is called a string, and we haven't touched on that yet. Now you can go ahead, of course, and create a variable that contains a string. So let's say somebody is called Max. So you could simply create a variable which contains the name of a person or of multiple people and so forth. So if we execute that, and well, if we just say something like, hi, I'm Max, or I'm not Max, but I'm plus name, then we will see it says, hi, I'm Max, even though we said name here. So we used the name variable in order to add something to a string. So as you can see, we use this plus here to use concatenation. And concatenation is called this approach here, where we add one string to another, and that's what we do. And it's different to what we had here, where we just said 5 plus 4 or something like that. That's not concatenation, that's just summation, where we just add one value to another. But what if we want to combine that? What if we want to say show the age, for example, of a person? So let's say we have age is 22, and then we print something like print I am and plus age and something like years old. So if we do that, we get an error. We get a type error, which says here type error must be str, not int. What that means is must be a string, not an integer. So now this age variable contains a value of 22, which is an integer. And what we say here, add a integer to a string and then add another string to it. So that's what this print statement says here. And if we instead would have said something like 22 and we execute that code with Shift Enter, we see I'm 22 years old. Maybe we should add an empty space in here. That works, right? Because we have 3 strings next to another. We could, of course, also skip the plus sign here. We won't need that. Well, we don't need that in this example. But if we want to use age here, then we need to use a different approach. So let's say I am 15 years old. And now what we use is the correct approach, where we print I'm plus str age plus years old. And here I also add an empty space so it reads better. So I'm 22 years old. As you can see, it takes over the variable from here towards the bottom to the next cell here that we are running it in. And what we do here is we use the string method. What this does, it says, okay, I take this variable here and I try to create a string out of it. In this case, it's easily possible because the age is a integer or an integer. So it says it has a value of 22. So I'm fine converting a value of 22 as an integer into a string. So that's our first function that we use here. This little function allows us to do something which we don't have to program. That's a cool thing because it just says, okay, I'm taking this value and I'm making a string out of it. All right, to sum it up again, a string is a data type and there are multiple different types. For example, integer is also a data type and we've seen that. It's just containing numbers. A string contains text and you create a string by using the quotation marks here. So whatever was within 2 quotation marks, that is a string. All right, and we created this hello world string and we just handed it over to this print statement, which gave us this hello world text onto the console. We can also store strings within variables and we can use those variables in order to concatenate them with other strings. So this is a string and we say, okay, just put this other string next to it. Then of course we have to be careful if we use a different data type, for example, the data type of integers, of whole numbers. That's what we have here. And we cannot simply add an integer to our text. That doesn't work. So Python doesn't understand what you want to do with that. If you still want to do it, you need to use this string function, which simply makes an integer into a string. So it transforms it into a string. It simply converts it pretty much. All right. So I'd say we are done with this very short first chapter and we're going to look into lists and other topics in the next chapter. But first of all, following comes a quiz. If you manage to finish that, then you can skip the exercise which comes afterwards, or you can check out the exercise. So see you in the next video. Welcome to the solution of the quiz number or string, and you can skip this if you have easily solved the quiz, because the idea behind this is that sometimes it's not that easy to understand what is requested in those quizzes and what exactly is meant by some examples. And if you're not sure whether you understood everything perfectly, then please follow along with this video, but otherwise just skip this video. And that counts for all of the solutions that we have for the quizzes. So each time that you answer the quiz easily and there were no questions afterwards for you, then, or if you really simply understood everything easily, then just go ahead to the next video and skip the result one or the sample solution one. So I'm just going to go through the 4 questions of this quiz real quick, and I'm going to explain what is going on and why a specific answer is the correct one and the other one is incorrect. So let's dive right into it. The first question was, V was hello world, and we printed V. What type of variable is V? Is it a string or is it a number? Well, as this hello world is text and it has quotations around it, quotation marks, that means that it is of a type string. So this variable here, this V, is a string variable. So the correct answer is A. All right, then the second question, V was 14 and we printed V. So now what type of variable is V? Well, in this case, it's a number. In particular, it's an integer number, so it does not have those quotation marks surrounding it. That's why it is a number. So the answer is B, number. Now the third question, and that one is a little more tricky than the first ones. And in this case, V, string, and within the brackets, we have the number 14. Even though this 14 is a number, what we're doing is we're casting it into a string. So that means that V contains a string, which then responds to this question with A. V is a string. So the variable V contains a string. So the correct answer is A. Now the last question was the trickiest one, question 4. Which of the following is a working and correct Python program that does not create any errors when executing? So we have A, B, C, and D for potential answers. So the first one is incorrect because we are using this and sign here instead of the plus sign. And the plus sign is required for concatenation. Otherwise, this line here would have been fine if we just replaced those 2 and signs with a plus sign. Then we have the second one, B. You have only empty space plus str10 plus dollars in your account. And that one is the correct one. Why is that? That's because this str10, it makes a string out of this 10. So that means that we have a string added with another string, added with another string, or concatenated with another string. So that's why we have B as the correct answer. C is incorrect because we're trying to add 50 to this string here. And we cannot do that. We cannot use concatenation with integers, as this one here, this 50,000, is in fact an integer. That's why this line of code is incorrect and would create a type exception, so an error. And then finally, we have this print string you have debt. That's incorrect as well. It was just an idea to create a fourth example of what, or a fourth answer of what could be potentially right. If you think about it, yeah, it could be that there is a function which does that, but in Python there is none. So D is incorrect as well. So here the correct answer is B. So B, there it was a string, so it was A. Here it was the number, so it's B, and here it's A. All right, I hope you understood it now if you didn't before, and if you didn't, that's totally fine. And then you can simply go ahead with the next videos, because things will get clearer as soon as we move along. And if there's still something that is not clear, then please let me know in the discussions. All right, see you in the next video. Welcome back. In this video, we are going to look into lists, and lists allow us to create a variable which contains multiple variables or values within itself. And that is a very important and handy tool that we're going to use quite a lot throughout the course and in general when programming. And imagine you work at the university and now your job is to create a program which contains all the students. Then you could go ahead and do something like that. Student 1 is going to be Max, then student 2 is going to be Monica, then you have student 3, which is Eric, and student 4, which is Franziska. And all of those are German writings of names. And yeah, you can of course go ahead and do that. But as you can see, there was plenty of typing, and that's not a very efficient way. There is a more efficient way, and that is to create a list. So you can go ahead and create a list called students, and in there you can use square brackets in order to create the entries. So I can create Max in there, then after the comma I have Monica again in quotation marks because they are strings. So we have Max as a string, Monica as a string, Eric as a string, and so forth. So now I do the same here, Eric and Francisca. And as you can see, what I had done within 4 lines before, I can now do within 1 line. Now you might wonder, how do I access those people? So how do I access somebody within that list? Well, first of all, let's just print out that student. So let's print out students. And for now, we're just printing out all of them. As you can see, we get this statement here. It's telling us, okay, this is a list. Why do we know that? Well, we know that because we have these square brackets, starting and ending bracket. And within we have strings. And how do we know that? Well, with this apostrophe. So the apostrophe is telling us that these are strings within our list. Now we can of course go ahead and create lists of numbers as well. So we can go ahead and, let's say, create a list with marks where we have the marks of our students 4, 3, 2, 1. Or we could also say these are the general marks that are available within our grading system or something like that. So now you might wonder, how do I access Max? How do I access Monica, and so forth? Because before that was easy. I could just say print student 1 and that would be Max. But now what if I want to have Max within the list of students? Well, then there is a different approach. You simply go ahead and state something like students, and then you use square brackets and the index of the value that you want to have. So in our case, I want to have Max, and Max is at the first position. And as programming languages start counting with 0, Max is at the 0th position. So we need to enter 0 here in order to get Max. So let me show you that that's true. And there you are, students 0 is Max. Now go ahead and try to get Eric on your screen to be printed out. All right, I hope you tried it. You could just say something like students, square brackets, and 2. Why 2? Because Eric is at the 3rd position, but from a programming point of view, that's the 2nd or the 2th position. So we enter 2 in here. So that's why we get Eric here. And the same goes from Francisca. She's going to be 3rd or the 3rd index, or 3 index pretty much. So that's something that you have to be very careful about, because lists always start counting with 0. In general, programming languages do so. All right, so now what if I want to write something like Max and Francisca? Then I can go ahead and do that. Students at the position 0 or at index 0, and or plus and this and is going to be within quotation marks because we're working with a string here, right? The student at the 0th position is Max, or index 0 is Max, and Francisca is also a string. So Max and Francisca are strings in here. That's why I need to use strings. And then I use concatenation in order to print them out in one bigger string. So this whole statement here is a string now, so saying something like Max and Francisca. So now let's print it out, and there we are, Max and Francisca. If you want to know the length of the string or the list that you have, if you want to know how many entries are within the list, you can use the len method or function. So we can go ahead and say something like len. As we had with str, creating a string out of a value, this len gives me the length of a list. So I can just say students, and what we get here is 4, as we have 4 entries within our students list. Now you might say, all right, that's great and all, but how do I add something to my students? I don't want to always go back and add something at the declaration here in this line. I want to be able to add an entry at any point in my program. Well, that's quite easy. You can go ahead and use the append function. The append function allows us to append or to add somebody to or something to a list. And in this case, we're talking about strings, so it makes sense to add a string in here as well. So let's say we have Moritz, it's also a German name again, and we can add him to the list. Now let's check it out. We have added Moritz to the screen or to our program. Now let's go ahead and run this method again, this students len method or function again. And there we are. Now we have 5 people in there. So if we want to know who is in that students list, we can simply print it out. So print students, and we see we have Max, Monica, Eric, Franziska, and Moritz. Now let's go back to numbers quickly, because we had this marks list which contained 4, 3, 2, and 1, and let's say these are the marks of our group. And now let's add a number or a mark to our Moritz. So let's just assume that the first entry here, this index 0, which contains the value 4, is associated with Max, the 3 is associated with Monica, 2 with Eric, and 1 with Franziska. Then our Moritz will get a 2, let's say. So let's append that. Now let's say we would like to get the average marks of our students. Then we can go ahead and do the following. We can just say print marks, and here I need another bracket. Marks at position 0 plus marks at position 1 plus marks at position 2 marks at position 3. And you might already say, oh man, that's boring, entering all of that all the time manually and stuff like that. No worries, we're going to learn approaches which make this code here a lot shorter and a lot easier to type. That's gonna happen as soon as we get to one of the next chapters. So now I would like to divide that, because I want to have the average, and I need to divide it by the amount of values that I have here. I could of course say, all right, I'm going to divide it by 5 because that's the amount of values I have. But I can also say I'm going to divide it by the amount of marks that we have within our list. And now you can try it yourself. What would you need to enter here? All right, I hope you figured it out. It's len, it's the len function. So I'm going to say len marks. What that's going to give me is 5, because within my marks I have 5 entries. And in order to make sure that that is true, I can go ahead and, well, I executed that. I can add another cell in here. So I'm going to press the plus button, and I'm going to say something like len, or actually print len marks. And there you are, it's 5. So now you see we divided 5 values by 5, and that gave us the value of 2.4. So the average mark is 2.4. All right, so I'd say that's a great start into lists, and in the next video, or actually in the next lecture, there's a little quiz waiting for you. And if you figured it out and managed to go through the quiz easily, then you can skip the following lecture and go to the pop function straight away. And otherwise, of course, check out the solution. All right, so see you in the next video. Welcome back. In this video, we are going to look through the quiz that we just had. And if you manage to answer all the questions correctly with confidence, then you can simply skip this video and go to the next one. Otherwise, just follow along. All right, so let's go ahead with the first question. How can you define a list in Python? And as you can see, there are 4 different answers. The first one uses curly brackets. The second one uses square brackets. The third one uses square brackets as well, but the difference here is that it separates the values with a semicolon. And the fourth answer here, or possibility, is using rounded brackets. Now, you might know that B is the correct answer, because if you want to create a list in Python, you need to use the square brackets, and you need to separate the values with a comma. That's exactly what this B answer does. So the correct answer here is B. Now the second question, how do you access the third element? And as you can see, we have a list here, which is called first names. and there are 4 first names in here: Ivanka, Donald, Ivana, and Baron. And you can see here that we have the 0 index, the 1 index, index 2, and index 3. And now we want to access the third element. So first Ivanka, second Donald, and third will be Ivana. And how do we get Ivana? Well, we get her by getting the first names at index 2, because index starts with 0. Ivanka is index 0, Donald index 1, and Ivana is index 2. That's why C is the correct answer. Now let's check out the third question. How do you extend the list wars with a third element? And I hope we never do that in real life, but we have this little list of wars. So there was the first war, then the second war, and you could say World War, or you could even think of other wars. And then we have 3 answers here. Wars add, then wars at index 3 is going to be 3, wars apply 3, and then wars append 3. So which of those is the correct answer? And actually here should be no question mark, like that. Which of those is the correct answer? And the correct answer is append, because in order to add an element to our list, we use the append function, as you can see here. So the correct answer will be D. All right. I hope you could follow along and understand everything that's going on, because we're going to work with lists quite a lot. And in the next video, we're going to check out how to use the pop function in order to get rid of an element in our list, and specifically the last element of the list. So see you in the next video. Welcome back. In this video, we are going to look into the pop function, which allows us to remove the last item in a list. Therefore, I have this list prepared here called planets, and in there you have the 9 planets that are within our solar system. And Pluto is in there as well, as I think it was decided that Pluto is a planet in the end. So they weren't sure for quite a while, so they said it was not, but in the end it is a planet. At least that's the latest decision. So now if I want to get rid of the last element, there is something called pop, and let's just use this pop function. And I'm gonna just say planets.pop. And what that will do is it will delete Pluto from this list. So let's just try it out. Let's run the code, and as you can see, Pluto is not in the list anymore. So Mercury, Venus, Earth, and so forth are all there, but Pluto is not there. So where did Pluto go? Well, it got deleted from the list, but at the same time, it is the output of this approach here. So this function or this code, it gives us an output. How do we test that? Well, let me show you real quick. So we create a new cell where we have all of this code again. And now, instead of just calling this pop function in this line, I'm going to create a variable that will store the result of that. So the result of this, or the output or the return of this approach here, list name dot pop, is going to be Pluto. And how do we check that? Well, let's just do that. Let's add a line here, which is going to print P. So print P, and let's run the code again. And as you can see, now it says Pluto. And that is because P contains Pluto now. It contains the thing that was popped from the list. So let's say we create another line and we call that P2 is going to be planets.pop once again. And we print P2 onto the screen, and there you see Pluto and Neptune. So the list is going to get smaller, and at the same time we store the output of that pop. And you could use that in plenty of approaches or situations where you have, for example, the last in first out approach, where you append something to the list, but then you take it out again because Mercury is way too far within our solar system or too close to the sun, and we always only take the last one from the list. So we could just use pop in order to do that, and we could clean up the planets one by one. And of course, plenty of other approaches as well, and we will use that quite a bit as well. All right. So in the next lecture, you will find a little sheet containing some information about lists in Python. And afterwards, we're going to check how to convert data in Python. So see you there. In this video, we are going to look into data conversion. And that's an important thing to understand because sometimes you get data in a specific version or in a specific type, and you need it in a different type to go on with your program. And that will make a lot more sense as soon as we get to more complex programs. But here it already is quite easy to understand because we're going to look into converting a string into an integer, which is a whole number, a string into a floating point number, which is going to be a float, and then how to convert from an integer to a number, which we already have seen, but just for completion, I'm also going to cover that. So let's go ahead and create a variable called a, and that will contain the value of 5, and b will contain the value of 6. Let's say we get that as a input from a user, because if a user types something with his keyboard, for example, then that will be a string usually. User input is usually stored as a string, and then if you want to use that as a number in order to calculate correctly, you will need to convert that. So let's have a look at printing that out first. So let's print a plus b first. So I'm gonna run that, and as you can see, it's 56. So 5 plus 6 is 56. Very easy math, right? But that's not correct. It's just putting those two strings next to each other. So we have the two strings, and if we add them next or concatenate them, we get this 56. So if you want to change that, if you want to actually get 5 plus 6 as in numbers added to each other, then you need to convert that. And in order to convert a string into an integer, so into a whole number, you need to go ahead and use the int function. So there's this function called int or int, which converts a string into an integer. So now let's check it out again, and we get the result of 11. So what happened here is that both of our values, which were strings before, of our a and b variables, they were strings before, but now we treat them as integers. So we convert them into integers, and that's why adding them to each other will simply apply the mathematical approach of just summation, which gives us this result of 11. Now, if we want to do the same thing with floating point numbers, because for example, if we enter 5.5 and 6.5 in here and try to run that, then we get this error. It says invalid literal for int with base 10, 5.5. So it doesn't understand what this 5.5 is supposed to mean in this context. So it doesn't know how to convert that, because it can't convert it into an integer, because integers only understand whole numbers. So if you want to use that, then you need to use a different approach. So let's say we have those 5.5 and b is going to be 6.5, but again as strings, so within the quotation marks. As you can see, now they are strings. If we print that and we want to have them as float, then we have to use the float function. So I'm going to say float a plus float b, and what that will do is it will add them to each other in a mathematical approach. If we wouldn't have used that, if we just said a plus b, then we get 5.5, 6.5, because it just concatenates the two strings to each other. But then the other approach was with the floats, and that's the one. And if you use that, then you use the correct mathematical calculation here. Now, if you want to go ahead and use an integer, but as a string, so this is actually a string, integer to a string, then you can go ahead and do the following. So let's say the age is 30, and we want to print something like 8 plus age plus years old, something like that. If we run that, we can't do that. It says must be str, not int. So must be a string, not an integer. We had that before, right? And you probably know how to solve that. And that is by using the str or string function, which converts the integer age into a string. Now if we run that again, we see I am 30 years old. So now you have seen how to use it with very basic types, and I can solve that error there. But there is also something to consider when using lists. So we cannot just convert them in the same way that we did here. We have to use a different approach, and that's what we're gonna look into in the next video. So see you there. Welcome back. In this video, we're going to look into data conversion with lists. So far we have seen how to do that with strings and floats and strings together, but this time we're going to use lists to convert them into strings and strings to convert them into lists. So let's say we have this students list here, which is going to contain Max again, Max, then Monica, we have Eric, and finally Francisca. So now we have this list of students, right? And what I want to do is I want to have them as a string. So I don't want to have them separately in 4 strings, because these are 4 different strings now within my list of students. But I can also go ahead and do the following. I can just say, okay, separate them and join them, or separate them with a hash, but join them together to one string. And what do I want to join? Students. So there is this function which you can use on strings. So this is a string, and by using the dot separator and then using the join word keyword, I'm calling the join function. This allows me to run certain code. There is certain code in the background which we don't have to develop ourselves, but it's just available. This is a functionality in Python, and that will join the list elements together and will add a hash in between every single of these elements. So let's say I want to have a string which looks like this one here. So student string is going to be Max, Monica, then Eric, and Francisca. So that's my goal. That's what I would like to have, like the students string. And now as you can see, this join method already did quite a good job, but we have this hash in between, this hashtag. But I would prefer to have a comma and a empty space, or an empty space just behind that. And that is easily achieved by getting rid of this hashtag, using the comma and then the empty space. And now as you can see, we get the string that I wanted to have. So it simply went ahead and said, okay, I'm going to join every single element within the list of students. And what do I put in between? Well, a comma and a empty space. So that's how you can make a string out of a list. You can of course also go ahead and use the following approach. So you can store that. So I'm gonna students as string, put it together, and I'm gonna just say comma empty space dot join students, and that will create this student string. So it's going to be a variable, and I can just go ahead and print out that students as string. And as you can see, I get Monica, Eric, Francisca, and so forth. So that's exactly what we had here, but now we stored it within a string. And we could even say something like, at our uni study those people. And then we have students as string, and as you can see, at our uni study those people, Max, Monica, Eric, and Francisca. All right, so that's the approach to create a string out of a list. So now let's go ahead and check out how we can create a list out of a string. So I'm gonna create a string. I'm gonna call it I, and it's gonna contain Max, Monica, Eric, and Francisca. And now what I would like to do is to create a list out of that. So out of every single name, I would like to create a list. And that's easily possible. As you can see, we could just go ahead and type that, and it was the same here. So we could have just typed that string as we did, and that's totally fine as soon as we only have, or as long as we only have 4 names in there. But imagine you have a student base of multiple thousand people in there. Would you still like to type every single person out? I guess not. You would like to have them in a list, and then if you want to really put them in a string, then you can just go ahead and use this programmatic approach. Now, the same goes for converting a string into a list. So in order to do that, we can use a method called split, or a function called split. So I'm gonna apply this split function onto my string called I. And how do I split them up? So here I have to say which pattern they have to have in order to be split. So now I'm gonna split them at the point where there is a comma and an empty space. So what that will do is it will create a list for me. So I'm just gonna print that out, and as you can see, it created this list with Max, Monica, Eric, and Francisca. So that's how you can create a list out of a string. Now you can use this approach to do something else as well. You can create a sentence. I'm just gonna call it A, and I am a sentence with many words. So that's going to be the sentence. And now I want to split them at the empty space. So I'm just gonna say print s dot, or this is called a dot split. So this, I want to split this string here, this a string. And where do I want to split it? At the empty space. So each time there is an empty space, I want to split them and put them into a list. That by itself is going to create a list of these words. So the first element of the list is I, the second one is am, and so forth. But now if I want to know the length of the sentence, I just can use this len function. So this len function is gonna split, or it's gonna give me the length of this split list. So we have two things happening at the same time, or actually even three things. So going from the inside out, this is going to create a list out of the string that we have, out of this a string. Then this here is going to give us the length of that list, and the print statement is simply going to print that onto the console. So let's run it again, and we can see we get the value of 7 because there are 7 words in there. I am a 3, 4, 5, 6, 7. So 7 words in there. All right, so that's it with the list for now, but we're gonna check out lists or use lists throughout the course, of course. And in the next video, we are going to look into comments. So see you there. In this lecture, you will learn how to use comments in Python. And that's something that I haven't covered yet, but is super useful and helpful when programming. So comments are something that is not executed by our compiler. So it's not going to influence the speed of our code, but it helps us as a programmer and other programmers to read code or to understand what's going on. And also we can comment things out where we are not sure whether we are going to use them later on or not. So in this case, let's say we have this little piece of code where we simply say hi to every single planet in our solar system. So let's say at one point somebody decides, hey, Pluto is not a planet anymore, which was already done in the past. So instead of deleting the code, which we of course can do, let me just delete it or copy or cut it out pretty much. And let's run the code again. As you can see, Pluto is not there anymore. But there is another approach as well. You can go ahead and use a hash in front of it or just before it. What that will do is it will ignore the whole line of code. So it will not execute that line of code. But it's perfect for us to see whatever we want to write there. So let's say we want to have a little information about what is going on in our code. So we can just go ahead and use a hash and say this code says hi to all the planets in our solar system. In this case, it's super obvious, right? And I'm going to execute that. And as you can see, this code or this line here does not influence our execution or our output at all. And that is because we're using a comment. So it's easy here, right? Because we have only these simple lines of code. But what if your code is super complex and you have thousands of lines of code and all your code does different things and so forth, and somebody else comes in and needs to understand your code super quickly? So you have to imagine you work on a project, and then let's say you are ill or you stop working for that company or whatever, and somebody else has to read your code and has to understand what's going on. That he doesn't have weeks in order to understand your code. He needs to start with it and check it out and understand directly which part of your code does what. And that's why comments are super useful and important to use. Of course, you can make the code very readable by design in order to, well, by creating them based on specific guidelines and approaches, of course, by naming them correctly, for example, by naming your functions correctly and so forth. But of course, you can also use code in order to make it more readable. So that's just a little insight for you. Go ahead and use code whenever you see use for it. Welcome back. I hope you managed to go through the quiz for comments and easily answer the questions correctly. Then you of course can skip this video. Otherwise, let's have a look at the questions. So first of all, we have this question: which characters to start a comment in Python, which should not be executed as code? And if we check that out, we can see A is a hash, then B is double star, C is a percentage sign, and D is a dollar sign. And the correct answer here is A. So let me enter that. So if you want to create a line of code which is commented out, then you can simply use the hash sign or hash key. Now, question number 2, which numbers are output when the following program executes? So print 1, print 2, but with a hash at the beginning, print 3, and print 4 with a hash at the beginning. So what that does is does it print out A, B, C, or D? Well, A is 1, 2, 3, 4, so all of them would be printed out. B is none, so none of the 4 would be printed out. C is 2 and 4, so this line and that line, so 2 and 4 would be executed. Or D, where only 1 and 3 would be printed onto the console. And you can of course test it anytime if you really want to make sure you understood it. But here it's very basic. We are just saying, okay, this line of code is executed because there is no hash. This line of code is not going to be executed because there is a hash at the start of the line, and this line neither. So print 1 and print 3 will be executed, so we only get 1 and 3 onto the console. And that's why D is the correct answer. Welcome back. In this video, we are going to look at the completion of Python basics file, and we're going to answer the questions here, or we're going to write the code that is requested. And in this case, we have this little situation where a mathematician, so a magician who likes math, is asking us to automate one of her tricks with a small program. The trick starts as follows. Think of a number, variable number, multiply it by 2, add 10 to the result, and divide the result by 2. So we have this variable number here. This is think of a number. So we had this variable number as 6, and now we need to write the code into the following line. So let's go ahead and do that. We need to write, instead of result is 0, we need to write the code that does what we have here. So multiply it by 2. All right, let's do that. Let's multiply number by 2. Now the next thing is add 10 to the result. So what is the result of that? It's whatever is done within the brackets. So now let's add 10 to it. And now divide this result by 2. Of course, you could have done that in multiple lines, but I'm going to do it in one line. And I'm going to use brackets again and divide now by 2. So now I have followed this instruction here. Think of a number, well, we have that, it's number 6, for example, multiply it by 2, we've done that here. Then add 10 to the result, and that's this one here, and then finally divide that by 2, and that's it. So now let's run the code, and we can see we get 11.0 as a result. So now there's a little suggestion. This is really about the Python code. It's not that much about the story, right? But the story is a little something to follow along. It's a cool thing. But what is really important is that you understand the code that's behind that and the approach that we are using. All right. So then we have this result. Correct output is 11.0. That's exactly what we have here. When she sees the mathematician turns up her nose. The result is still displayed as a decimal number. Now we need to convert the result to an integer before we print it. So let's go ahead and display the result of the calculation here as an integer. So let's go ahead. I'm just gonna add a line here, print int result. So what we do here is we simply print the result as an integer. So let's do that, and we see we get this result. Of course, in order to easily understand what the result is, we can add this line in here as well. So now it's easier to follow along what the result in the end should be. All right, the correct output is 11, and here it says no need to be colored. What that means is, actually this is incorrect here, no need to be colored. This means that here we see it as a green 11, but it should be black or whatever the color comes up. So the color doesn't matter. Now the next step is the mathematician points out that the magic tricks also depend on the presentation. Now give an answer sentence of the form you chose 6, the magical result is 11, where the variable number is to be used for number 6 and the result, variable result, for the number 11. So we should say something like, you chose number, the magical result is result. So let's just do that. Let's add a line in here which just does that. Print you chose, and then plus str number plus empty space, the magical result is plus str result, as we need to use it as a result. And here it's important that we have the closing bracket for that print statement from here. And also we have this exclamation mark, so let's add that in there as well. 11 exclamation mark. All right, now let's check it out. And as we can see, you chose 6, the magical result is 11, and now it needs to be as in 11. So we need to also use an integer here. So we need to make it an integer. So how do we do that? Well, we use the int function here. So we say, make an integer out of this result and then make a string out of the result of this approach here. So if we run that again, we can see you chose 6, the magical result is 11. All right, so now the mathematician is happy with the result here, but then she has a different problem. So mathematician is very happy with your work and asks you for help with her online shop. She only knows the email addresses of her customers, and you should create a simplified directory with their names based on the email addresses. So draw a name from an email address or an email address in the form name@service.com. If the email address is, for example, maxmasterman@gmail.com, you should output max minus masterman. If the email address is Klarnamen, then it should be, or at uniberlin.de, then it should be Klarnamen. So be sure to check the split method again. This allows you to saw or split an email address at the @ symbol, for example. So we have this email address, willywizard@magicschool.com, and the correct output should be willywizard. So how do we do that? Well, we can simply go ahead and print that. Let's print. But what do we want to do? Well, we want to split the email as follows with the split function. And here we use @ as the split character. And then we want to have the first entry. This is a list, so we split it up, but now we want the first entry from it. And I know this one was tricky, but if you figure this out, then that's great. So now let's check it out, and we see willy.wizard. That's going to be the name of the guy now. All right, so now draw a name from an email address in the form info@name.com. Sometimes the names of an email address are only after the @ sign. Also print the names for such cases. Remove the ending .com or .de. You may assume that there is no period within the name. If the email address is, for example, info@max-masterman.com, you should output max-masterman or max-masterman. And then note it's okay if you need several split functions for the calculation, or if you want to cache a result. You're also welcome to use the code from the A subtask here. All right, so let's go ahead and do that for this email address that we have here. So there's a lady called Helena Witch, and we want to get her name from that email address. So let's go ahead and print that. So we use the print method again, or print function, and we say mail.split at the @ sign. But then we want to have not the first entry, but the second entry. So we use 1. And that we want to split again. So we want to split it at the dot. And we do so by using the split method or function once again, where I just say split and dot. And here off we want to have the first entry. So what does this do? So what happens in here? It's actually, this should be outside. So here you have to be super careful, right? Because if you have have anything at the wrong point, then it's going to be pretty difficult. So let me execute that. And as you can see, we get Helena Witch. So why is that? So first of all, we split at the @ sign. So we split at the @ and we have 2 entries in our list, because this creates a list. So we have a list with 2 entries. At 0, index 0, we have info. At index 1, we have helena-witch.com. And that's exactly what we get with this piece here. So we get this helena-witch.com. And now we split that piece again, because this here is a string again, because we're only getting 1 entry. So we get the string. And now we can apply the split function once again onto that string, and this time we split at the dot. So we split this piece of text here at this dot here, so at the dot, and we take the first entry of this whole thing here, for this whole list, and that will be Helena Witch. So now in order to do that with 2 lines, we can also approach it like that. We can just say mail.split at the @ sign, like this. And we want to, well, let's just do that. As you can see, we have this approach here with this list here, which is info and helena-witch.com. Now, if we want to print mail.split at the @ sign once again, but this time we want to get the entry at 1, and I have 1 separator on the wrong side. So now we're good. As you can see, now we get this Helena at or -witch.com. That's what happens here. And what we could do is, of course, store that. So we could go ahead and store that within a variable, and that will be name underscore and ending, or a domain, maybe that's better, and high level domain, because that's what this does. Now this is this helena-witch.com. That's what this gives us. And now we can split this one here, so this name and high level domain, and we can split that again. So let's split it at the dot, and let's print that as well. So let's print the result of that, and let's actually store that in a list. So I'm going to call it list is going to be, or actually list 1 is going to be that, and let's print out list 1. So print list 1. As you can see, we have this list which says helena-witch, and then we have com. And now from that list, we only take the first entry. So we say print list 1 at position 0. And now let's run it again, and as you can see, we can get this Helena witch. So what we've done here in multiple lines is what I've done here in one line. Okay, good. So let's go to the next point. Calculate how many customers are there in the online shop. So we have currently all the customers, mail 1, mail 2, and mail 3, present as a separate variable, or here each of them is separated, and we want to have them within this client's list. So let's put them in there. Well, how do we do that? We simply use the append function. Append mail 1, then clients dot append mail 2, and clients dot append mail 3. And here, of course, you have to be super careful that the names are correct. So this is clients, exactly the name as we had it here. So now let's print it out, or let's run it. And as you can see, we have Zara, .magic, Berg, and so forth. Uwe Evil, at Darknet, all those kind of guys. And now we want to know the number of people in the list. So let's go ahead and do that. Print len clients. So what that does is it simply gives us the length of this list clients. And this, by the way, we just added an element or a string to our list, which is called clients. And that's done by the append function. Now, finally, assemble an email address from strings. So now we have the approach that is vice versa. We have StageMagic and magic.com, and now we would like to have something like StageMagic at magic.com. So let's do that, and therefore we need to use the join function. So let's print at dot join magician or magician, this one here. And if you want to make sure, you can copy and paste it. So now let's print it out, and as you can see, StageMagic at magic.com. So if you want to combine two elements from, or multiple elements from a list, you can use the join function. If you want to separate them, you use the split function. And if you want to add an element to a list, you use the append function. All right. So if you managed all of it, that's awesome. If you managed some of that, it's still good. If you didn't manage any of them, then you might want to rewatch or reread some of the handouts that you have within this chapter. All right, so I hope you enjoyed this chapter. In the next chapter, we're going to look at the next basic aspects, which are super important in programming, and that will be control flows. So see you there.
All right, so now you have been around for hours, and I hope you enjoyed this course. So now I would really recommend you to check out the link in the description to get the full masterclass, which is a 30-hour course. So it's pretty much what you see here, plus another 20 plus hours. So it's really worth its money, and it's really going to be an amazing investment into your future in becoming a great Python developer to do whatever you want with it. You can use it for machine learning, you can use it for data science, you can use it even to create games or backends or crawlers or basic PC applications, whatever you can think of. All right, so check it out. I hope to see you there.
Welcome back. In this and the next chapter, we are going to check out control structures, and they allow you to do some great stuff, which is a lot more advanced than what we've done so far. For example, you're going to learn how to use if and else, which allows you to run specific code based on a condition. And if that condition is not met, then you can run some other code, or you cannot just run no code at all. For example, if somebody is younger than 16, then he may not have a driver's license for a car in the US. In other countries, it's a different age, but in the US, it's, for example, 16. And you can just print something out like, if the person is below 16, then just tell him to wait. And if he's 16 or older, then you can just tell him, okay, go ahead and do your driver's license. Then we'll check out relational operators, which are super important, not just for if and else conditions. Then we'll check out whether an element is within a list. As you have seen, lists contain multiple elements, and we can simply check through a list whether an element is in there. You will see different cases where you can use that. And then you'll see ELIF. And ELIF is an extension to if and else, which is a shortcut for else if. So you have a condition, an if condition, which checks one thing. Then you have an else if condition, which checks the next thing, and so forth. So let's say somebody is lower than or younger than 16, then you could just write something, you're not allowed to drive. Then if somebody's between 16 and 21, then you can write something like, you're allowed to drive, but you may not drink alcohol. And then if somebody is neither of those cases, so all the other cases, which means 21 and older, then you can just write something like, you may drive and you may drink, but not at the same time, or something like that. And that's just a very, very simple example. You will see multiple examples where it makes a lot of sense to have this kind of structure in order to execute code based on conditions. Then we'll look at the while loop, which allows you to execute code multiple times in a row. That's the same for the for loop. So pretty much as long as a condition is met, the loop will run, and they are very good for counters. So if you want to run a specific code, let's say 10 times in a row, then they are great. You will also see when to use which of those two loop types. So when to use the while loop, when to use the for loop. And you will see how to break and continue, which means how to manipulate your loops so that they get out of the loop as a specific condition, or they continue the loop, but they skip the current iteration of the loop. That will make a lot more sense as soon as we get into practice. And finally, we will draw some graphics. So see you in the next video. Welcome back. In this video, we are going to check out if conditions, and they are super useful and a very important basic concept of any programming language. So let's go ahead and start with it. I'm going to create a variable that I'm going to set to 15, and then I'm going to use an if statement. And in order to create an if statement, you can go ahead and use the if term, and then afterwards you can write the condition. So in my case, I'm going to check if n is lower than 18. And if it's lower than 18, then I want to execute some code. So you see, I'm using a colon and I'm writing something now. So I'm going to write the code in here that I want to execute if this condition here is met. So if n is lower than 18, then please print something. And it's important that this print statement is indented by a tab, because if it is not, then Python will not understand what's going on. So whenever you use or you want to run some code within an if statement, if the condition is met, you need to indent it. All right, so in this case, I'm going to say something like, you may not vote, because if somebody is younger than 18, he's not allowed to vote. So let's execute that code. And as you can see, this statement is written onto the console. So this condition here is met because n is just 15. That's why the statement is executed here. So if somebody, let's say, is 19 years old, now let's execute the code again. And as you can see, nothing is printed onto the console. And that is because n is higher than 18. And that's why this condition is not met. So this code is never executed. Now let's add another code in here, another line. I am not indented. So as you can see, I'm not indented is printed onto the console. Why is that? Well, because this line of code is not indented. That's why it's not considered part of this if statement. So it's not considered as the body of this if statement, which means that it's not it's executed in this case because, well, this condition is not met, right? So if I do it like that, I can execute it. As you can see, it's still executed. But if I indent that print statement and execute it now, it's not printed onto the console because it thinks, or in this case, it is part of that if statement. So I'm gonna get the indentation lost, or I'm gonna delete the indentation. So I'm gonna indent only this print statement here, you may not vote. All right, so what if I want to have a statement for all the other cases. So if somebody doesn't meet this condition, then I want to write some other code. And that's why you have this if else. So if and else. If is the first request, and if that's not met, you can simply execute the code which comes after else. So let's check out how this looks. I'm going to create another variable. I'm just going to set that to 10. And then I'm going to check if m is lower than 5. Then print, very simple, m is lower than 5. But then on the other hand, else, just print something like m is higher than 5. Or you could even write something like if condition is not met. So let's run that code. And as you can see, I get this statement here, if condition is not met. And that's because m is 10. So m lower 5 is not true. So this condition here that we have is not true. That means it just skips this line of code and directly jumps to the else part of this if else statement. So it executes the code within the else statement. If we add a line here to our if n below 18, you may not vote. If you want to extend that, we simply add else colon, and then in the next line indented, we write whatever we want to write. Please go and vote. So now let's execute that code again. And as you can see, it says, please go and vote here on my console. And that is pretty much if and else. So we will use if and else statements quite a lot. And you will also see how to use ELIF, which can cover multiple other cases in between, but that's something for later. For now, we're good to go for the next video where we'll check out comparison operators. And this is a comparison operator right here, this sign here. So lower than is a comparison operator, and we need to check out all the comparison operators in order to understand if statements even better and use it accordingly in the future. So see you in the next video. Welcome back. In this video, you are going to learn about comparison operators. Therefore, let's go ahead and use one so you can see what a comparison operator is. Let's say 6 is less than 5. And if that's the case, then just print yes onto the console. So let's execute that code. And as you can see, nothing happens. So it doesn't execute it. And why is that? That is because 6 is not less than 5. 6 is in fact greater than 5. So if we check that out once again with a print statement where we just say 6 less than 5, if we execute that, we get false here, which means that this statement is false. And as you already know from the last video, the if statement needs to have a condition that is true, otherwise it won't execute its code. That's why this print statement here with the yes statement is never going to be printed, because this condition here is not true. So let's check it out with a different one. Let's check it out with 5 lower or less than 6. Let's print that. And as you can see, this statement here now is true. So now if we would use that statement at the top here, then we get this printed yes onto our console. So that's a good thing. Now we can also use variables in order to store a Boolean with them. So let's say we have b equals false. So we have this variable and we set its value to false. And here it's important that we use the capital F. As you can see now it's green, which indicates that Python understands that this is a Boolean in this case. And now let's print b onto the console just to check. And as you can see, well, b is simply false. Now, what we also can do is we can store an actual comparison in our variable. So this result variable is going to be the result of 5 lower 6 or less than 6. Now, if we check result now and we print something on the console, something like 5 is less than 6. Let's do that. as you can see, we get this printed onto the console. So let's check a different thing. Let's check result here. Let's just see what result is. So let's execute that again. And as you can see, result is true. So result now is a Boolean variable, which contains a Boolean. And a Boolean only has two values. It can either be true or it can be false. So this result here is true because 5 is less than 6. That's why this if statement is printing out that code here onto the console. So there you can see the text. Now, less than and greater than are not the only ones that there are. There are equal comparisons as well. So let's check it out. Let's print out 5 double equal 5. Now you might wonder, why do we need double equal? That is because a simple equal, one single equal, is setting a value, and two equal signs, they compare values. So when you see double equal, that is always a comparison. And as you can see, 5 equal 5 is true. Why is that? Well, because 5 is 5. But if we do something like print 5 equal 4, then we get false, because this statement here is incorrect. 5 is not 4. It's as simple as that. Now you can do this also with strings. So let's create a word, which is just going to be hello, very basic word. And we are going to print word equal hello. Now let's see what happens. As you can see, we get the statement true. That's because word in fact has the value of hello. That's why this statement here is true. Then we can also check out if word is equal word. Let's see if that's true. And as you can see, that's false. Even if we would use word with a small or uncapitalized letter, as you can see, it's false. That's why it's not comparing the name of the word variable, it's comparing its contents. So we're comparing the content, which is hello, to this word content, which is not true. That's why we get this false statement here. Now we can also do something which is an unequal comparison, which means, so let's use word again, which is going to be hello once again. Actually, we didn't need to create that, but I'm just going to create it in a different row in here or a different cell. So what I'm going to do now is I'm going to print word unequal hello. And this statement here is going to be false. Why is that? Because we are comparing the content of word and we are asking, is it not equal hello? So an exclamation mark plus the equal sign will result in a not equal. So this means not equal. And therefore we get false. Let's check it out. And we see false. Now let's do the same with this word example that we had. So I'm going to copy and paste that real quick. And I'm going to use an exclamation mark here as well and execute that. And as you can see, this statement now is true because we are saying word is not equal the word word. And that's why the statement is true. Now, of course, you can do the same thing with numbers. But how we're going to look at it is greater equal or less than equal. So let's print 5 less than 5 onto the console, and that will give us false. But if we do something like print 5 less than equal 5, we get true. Why is that? Because we're checking, is 5 lower or less than or equal 5? It is not less than, but it is equal 5. That's why this statement here is true, so that's why we get printed true onto the console. Now we can do the same thing with greater than. So print 5 greater 5, that will of course be false. But then if we say print 5 greater equal 5, that will be true. So that's really important, not just for if statements, but also for loops, which we're going to cover later on. That's why I wanted to really put an emphasis on comparison operators. Now that you know if statements and comparison operators, it's important to look at Booleans a little closer, because there is one important thing about Booleans and also and or logic, which we will cover in this video. So let's go ahead and create a variable called age, and let's just set that to 35. And then if we check here, age greater than equal 30. So greater or equal than 30, and age lower equal 39. So we have this if statement which contains of two checks or two comparisons. So we have one condition, the age has to be greater than or equal 30, and at the same time it has to be less than or equal 39. So only if that is the case, we want to print something onto the console, which is going to be this person is in its 30s. Something like that. So let's print that, or let's execute that, and as you can see, this person is in its 30s is printed onto the console. And that is because the person is 35, or the age of the person is 35. And that's why this condition is true. So 35 is greater than equal 30, and it is lower than equal 39. So if we enter something like 40 in here, as you can see, it's not executed. All right, so let me set that back to 35, and it's executed again, or it is executed anyways, but this code is not executed if the condition here is not met, or those two conditions are not met. And that's this and word. So and means both have to be true, or not just both, but all conditions if they are connected with an and each time. All right, so now let's check out or. Let's set age to 45. And then if age is lower than 30 or less than 30, or the age is greater equal 40. Only then we want to print something onto the console saying this person is not in its 30s. And I think here that's correct. Now let's run it again. This person is not in its 30s is printed because now it's 45. So we have this other thing where we use or, which means either or has to be true. Only then this statement will be executed. So which means that it doesn't have to be both of them. So this condition is false, as you can see. Only that condition is true, but one of the two is true. That's why the statement here is printed. So we can simply check that like this: print age less than 30 and print age greater equal 40. If we print that, we see it's false and true, but as long as one of them is true, this will be executed. What we also can do is we can store whether a statement is true or not inside of a variable. And we've seen that before, but now let's check it out in a different version. So above, below 30 or underscore 30 is going to be the name of my variable. And in there, I want to store age greater equal 30. Now I can print that out. Let's print above 30 onto our console, and as you can see it says true here. And why is that? Well, that's because this statement here returns true, and the return is stored within this variable. That's why we get this true here. And why is it true? Well, because age is 45, as you have seen here. So if we set age in the line be above age to 25 and we execute the code, as you can see it's stated as false. Now we can of course go ahead and create another variable or assign 25 to age, even though we did that here, but I'm gonna just do it in this cell as well. And I'm going to say something like above 20. It's going to be the name of the variable, and it's gonna state something like age greater equal 20. And we're gonna print above 20 onto the console, and as you can see it states true. Now you could of course argue if somebody's just 20, then he's not going to be above 20, but well, it depends on the point of view here, I'd say. So if this condition is true, so if age is greater equal 20, I just want to print something on a console, if statement was executed. So as you can see, we can still use the same approach as before. So we can simply check something, greater equal 20, and then print something. Now, why do I show you that? Because we have seen that quite a lot already, right? Well, there is something about if statements that you can do, and that is to just tell them whether they are true or false straight away. So if true, print hi there. As simple as that. As you can see, hi there is printed. So you don't even have to have a comparison here. You can even say straight away it's true or it's false. So if false, and it's not printed. Of course, that doesn't make that much sense, but in some cases you might want to use this approach. So let's look at that a little closer. So I'm just gonna add some more lines so that I can write in the center of the screen. So I'm gonna use print and just use true and true. So guess what it's gonna execute? Well, it's gonna say true. Why is that? Because both of them are true. So the left-hand side is true and the right-hand side is true. Okay, what if I have the situation where I have true and false? Let's check that out. As you can see, I get false. Now, print false and true. What will that execute? Well, it will execute false once again. And then the last one, print false and false, and that one will give me false as well. So whenever you use AND, there is only one combination where it actually is returning true, and that is if both left and right of the AND is true. So both conditions, left and right, and in this case we're just using the true keyword. All right, so that's with the AND. Now let's check it out for the OR. So I just use print true or true. That will return true, of course, because either or is true, and if both are true then it's double true, but still it's only returning one true, of course. And then in the next line, print true or false. What will that return? Well, it will return true as well. And print false or true. That will return true as well. So you can see there is only one combination where it actually returns false, and that is if false is the case for both sides. So left and right of the OR. So let's check that out. As you can see, now we get false. So that's very important logic that you need to understand if you use or AND. Now, let's look at an example again. Let's say we have a variable called country, and it's just gonna have the country code like US, United States of America, and a variable called age. And now we check something like country equal US. If that's the true, that's the case, and the age is greater equal 21. Or if the country is not US and the age is greater equal 18. Because in most countries you may do stuff that is only allowed at 21 in the US. For example, this person may drink alcohol. So in the US, you're only allowed to drink alcohol at the age of 21 and higher. And in other countries, I'm not gonna say in all countries, but in most countries, you're allowed to drink alcohol at the age of 18, or in some countries, the not that hard alcohol like beer and wine and stuff like that is allowed to drink at, or you're allowed to drink at 16. So in Germany, for example, you're allowed to drink beer and wine at the age of 16. And yeah, you may not drink and drive, of course, and you also may not drive at the age of 16, which is the case in the US. So it's pretty interesting how different countries handle those rules differently. The same with weapons. So you may have a weapon before you may drink in the US, and in Germany it's super difficult to even get a weapon but it's super easy to get alcohol even if you're just 16. So that's very interesting, and that's just an example. Let's just print that out on the console, and I have an error somewhere. It says counter is not defined, and it should be count 3. All right, so I wrote counter here. Now let's check it out again. Let's execute that code, and as you can see, it doesn't execute it. Now let's add an else here, and let's print something. Actually, we need the colon. Print this person may not drink alcohol. Let's execute that, and as you see, this person may not drink alcohol is executed. That's because the person is from the US, so let's say the person is 25 now, and as you can see, the person may drink alcohol. Now let's say the person is from GB, from Great Britain, and is 18, and as you can see, this person may drink alcohol just because it's from Great Britain and equal or older than 18. All right, so that was Booleans and OR, and we will use those quite a lot. So make sure that you have understood it quite well. And of course, there will be exercises where you can prove that and prove that to yourself. Great, so let's check out the sheet in the next video, and afterwards you'll see a quiz and of course the solution to that. And afterwards we're going to look at the in operator. So see you in the next videos. Welcome to the answers for the quiz, if statements and booleans. And let's go ahead to the first question straight away. We have this question: is hello world printed? And that's the source code. So if true and false, then print will be executed. So as you can see, we have this condition which says true and false. And as and needs to have true on both hand sides in order to be true in total, this statement is going to be false. So this statement here is going to be incorrect, or is going to be false. So the statement will not print this code here or execute this line here. So the answer to this question is no. So the correct answer will be B. All right, now let's check out the second one. Is hello world printed? In this case, if true or false, then print hello world. So in this case, we have true or false. And whenever we have or as a connector, only one of the sides has to be true. So either the left-hand side has to be true or the right-hand side has to be true in order for the whole statement to return true. And as we have one true in here, the whole statement is going to be true, which means that this code will be executed, which means that the answer is A. All right, now let's check out question number 3. In order to sign contracts, a person must usually be of legal age. In most countries, that's 18 years old. How would you formulate this condition with Python? Note the difference between less than and less or equal than, or greater than and greater or equal than. Also check the incident where a person is 18 years old manually in your head, even though this might be difficult to put your hands in your head. All right, so let's just check out the potential answers. So we have A, where age is greater 18. What that means that age is 19 and any higher number than that. So this statement is incorrect because a person must be 18 years old or older. Now let's check out B. Age is lower or less than 18, and that's of course incorrect because only if the person is older than 18 or he can sign contracts. Then we have C. Age is greater or equal 18. And this statement here is the correct answer. Why is that? Because here we include every higher number than 18 and 18 itself as well. So we have 18 and higher, which is exactly what we wanted. So a person has to be 18 years old or older. And then we have this age less than equal 18. While it's correct for the 18 itself, it's incorrect for less than. Now you could of course argue this statement here: in order to sign contracts, a person must usually be of legal age 18 years old. That is already pretty tricky because this here would just say out that a person has to be exactly 18 years old. So none of the answers here would be correct. But a person has to be at least 18 years old. So the correct answer is going to be C. I hope you could answer those questions easily, and if not, I hope you understood what I just explained. And then in the next video, we're going to check out the in operator. So see you there. You've seen multiple operators already, and the one that we're going to look at now is the membership operator, and it's called in. In Python's membership operators test for membership in a sequence such as a string, a list, or a tuple. And there are two membership operators. One is the in and the other one is not in. And we're going to look at the two operators in this and the next video. So let's go ahead and start with the in operator. Therefore, I'm going to create a list of students, and I'm going to use my standard list with Max, Monica, then Eric, and finally Francisca. All right, so this is my list, and I want to print whether a specific name, so let's say Monica, is within the list, and I'm just gonna say in students. So let's execute that, and as you can see, we get the statement true. Why is that? Because Monica, as a string exactly written as I have it here, is within my list students, and that's a pretty cool feature. So let's check out another line where we check the same thing for another name. Let's say Mo in students, and let's execute that. And as you can see, we get the false returned because Mo is not part of that list. Now, this of course is a very basic and not that useful functionality in this way, in this version, but we can use it in a very useful way. For example, in an if statement. So we can just say, okay, is Monica in my list students? And if that is true, then please print something like, yes, Monica studies here. So let's execute that. And as you can see, we get this statement, yes, Monica studies here. Now let's check the same thing with Moritz. So I'm gonna copy and paste that code. So I'm just gonna say Mo in students, and then it would just say something like Mo studies here. Now execute that, and as you can see, this statement here is not true, so Mo is not within students, and that's why this whole thing doesn't work. All right, now let's check out else here as well, because we can use else of course as well, and print something like no, Monica doesn't study here. Now let's run that. For Monica, there's nothing happening, but let's check it out for Mo, and it's gonna say Mo doesn't study here. Now let's print it, and as you can see, no, Mo doesn't study here. So this else statement here is actually executed because this statement is not true. So Mo is not within the students. And that it by itself is already pretty cool, but there is something even cooler. And that is that this also works for strings. So let's check out an example with strings. Let's write a little sentence. I'm just gonna say, yes, Monica, I'm just gonna copy the code from here. Yes, Monica studies here. Let's do that. And let's add an exclamation mark at the end. So now I have this very basic sentence, and I can now check if a particular string is in sentence. So I'm checking, is this sign within the sentence? And if that is true, then I'm just gonna print yes, and actually as a string, yes, like that. Now let's execute that, and as you can see, print yes is executed. Let's check out else, print no. And now let's use a different sign. Let's use a something like is a B in there. So let's execute that, and as you can see, there is no B in this whole sentence. Or we can even go as far as no. Is no in the sentence, and it says no, no is not in the sentence. So you can use that for strings, and that is super, super useful because now you can simply check if a specific character or a specific term is within your string. And you could use that, for example, to search for documents, because documents in the end are also just strings. And it goes for websites as well. Websites are usually just documents, right? Or at least the basic concept of websites, the HTML code, are just documents which you can read, and then you can check if a specific term is in there and execute something if you find that term. And that will be super powerful. All right, so that's the in membership operator. And we're going to check out the not in membership operator in the next video. So see you there. Welcome back. In this video, we're going to check out the not operator, and we will see multiple versions of it. So let's create a not age greater equal 30. So you can go ahead and do it like that. You can just say, okay, executed, and just run it. And as you can see, it's executed because the age is not greater equal 30. But of course, this is not very efficient because first Python checks this code here, and then it negates it, and then it checks whether that whole statement is true. So you could, of course, do it a lot faster by just saying if age lower 30 or less than 30, and then just print the same thing here, executed. As you can see, both are executed. So this if statement would be a lot more efficient than that one, not just in terms of typing, but also in terms of processing power and speed. So you can use the not operator. It just negates the whole thing, and in this case it really doesn't make that much sense, but I still wanted to show you that it's possible. Then there are cases where it actually makes a lot more sense, and that's if we, let's say, have a little list with Max and Nadine, and now I want to check if Moritz, or let's say Mo, is not in names. So what I'm checking now is Mo not part of the names list. And if that's true, then let's just say something like Mo is not in the list. So let's print that, and as you can see, or execute that, you can see Mo is not in the list. Now, we can of course do the same thing in a different approach, where we can just say if not Mo in names, and we can print that again. Same thing, Mo is not in the list, and as you can see, it's executed as well. So both versions are fine, but not in this version here is nicer, or is prettier to look at, and also easier to guess what's going on, or to understand what's going on, because here we see this not, and then we see this in later. So here we see both in one line, and it's easier to read. Is Mo not in the list names? And if that is true, then please print that statement. And here we say if not Mo is in names, so everyone else but Mo is in names pretty much, then print the statement as well. It's the same thing as this one here, but it's, as I said, not that easy to read and not that well written, I'd say. So highly preferred is this version here. So the only thing that you really need this not operator for is really to just quickly negate whatever you're checking. So of course you could have gone ahead and done something like if Mo in names, then print something, Mo is in names, Mo is there, and else print Mo is not in the list. Of course you could have gone ahead like this, but if you just want to check if somebody is not in there, to just check the negated version first, then this if statement is going to be better. And by the way, that's something that I haven't covered yet, and I will look into even closer when we go to the ELIF. But whenever you have this if statement, and the if statement is true, the whole else statement will never be checked. So it won't even be thought about. So the code will just go, or the cursor will go here. If Mo in names, if that statement is true, then it will go here, and then it will straight away jump to the line here. So to this line where I'm at with my cursor right now with my mouse. So we'll just skip the whole thing, all right? And that will make a lot more sense as soon as we get to ELIF. So see you in the next video where we have a little quiz, or actually a little sheet followed by a quiz, and of course the answers to the quiz. So have fun doing that and see you there. Welcome back. In this video we are going to check out the answers for the quiz, the not operator. And it's just some basic questions about using the not operator correctly. So let's start with the first question, and as usual, if you manage to get the questions correctly or the answers correct easily, then you can just skip this video. All right, let's start with the first question. Is hello world printed? And we have the source code here stating age is 25. If not age greater 30, print hello world. So we have this statement, age is greater 30. So let's first look at this. Is the age greater than 30? And 25 is in fact not greater than 30. So this statement here is going to be false. But then we turn it around with this not here. So we say not false, and not false is true. So the statement hello world will be printed. So the answer is yes, which means the answer is A. All right, now let's check out question 2. When is hello world printed? A, B are true / false values. Okay, so let's check out. Play through the given answer options in the head and consider whether the whole expression is fulfilled or not. So let's go ahead. If A and not B, print hello world. So we have this if statement where we say if has to be A has to be true, and at the same time not B has to be true, which means that B has to be false. And that's why we need to have A true, B false. And if we check the answers here, we can go through them step by step. I'm going to do that, but we can already say that B is going to be the correct answer. But let's go through them step by step. So A equals true, okay, true, and B equals true. So true and not true means false is going to return false as a whole. Now let's check out B. A is true and B is false, and in this case we say not B, so not false, which means true. So we have a whole statement of true and true, which in total returns true. Now let's check out C. A is false and B is false. We will have false and not false, which would be true. So we have false and true, and that will return false as well. And finally we have this D statement here, false and B true, which will return false, and that will in total be false as well. All right, so the correct answer here is going to be B. Now let's check out question number 3, and that's a little longer here. A small and or can make a big difference, and that's a bit weird to read, but that's how it is, right? For example, the following printout checks whether a call has been made during office hours. So from 9 o'clock till 15:59. And I know this is for Americans, this is probably not the perfect way to type it or to write it, but in Europe, that's usually, or in Germany, that's how we have the time. So that's PM, that's 3:59 PM. So the hour will be greater equal 9 and hour less than 16. Now there's been a mistake. The following expression is inadvertently in our program. The hour greater equal 9 or hour is less than 16. So instead of using and, we have used or. For which values is the second expression fulfilled? So A, all times from 9 o'clock during the day. So from 9 to 25 o'clock. So that's, or 24 o'clock. So that's going to be the question here. Is that true? Let's check it out. So we say hour is greater equal 9. So everything higher than 9, or is less than 16. So that means that it's before 4 p.m. or it's after 9 or equal 9. Okay, so this statement here is already incorrect, because if we look at it, all times, so B is the correct answer. All times are true in this case, because any time past 9 o'clock will be fine. as we have this OR statement, which doesn't restrict it at all. So even if we didn't look at this one here, it doesn't matter what we have on that side. It's just important that we have an OR. We just see, okay, this is going to be any time past 9 o'clock, and that would mean that this statement would be true. But if we look at the other piece as well, it says before 16 o'clock, which pretty much means that from 0 to 16. So we have from 0 to 16 and from 9 to 24 together. That means from 0 to 24. So B is the correct answer. Of course, then C and D will not be correct answers anymore. And that is a very tiny mistake. So instead of using AND, we used OR, and that already makes a huge difference. So let's assume we have developed a software for an answering machine, which will simply, or for a phone in general, and which will simply go to the answering machine during not office hours. And we have made this mistake. Then the employees of the company who have bought our software will be super unhappy because they will be called all the time. And that's because we made this tiny little mistake. So whenever you program, you have to be very careful, and you should always test your software. Always try to debug it and always check it out whether it really does what you were intending to get as a result. And therefore, there is a concept which is called test-driven programming, and that will test what you write a little software which checks your software on the other side. So generally be careful when writing your code and always test your application. Welcome back. In this video, we are going to check out ELIF, and ELIF is the short form for else if. And if you know any other programming languages, you already know what else if does and what ELIF does. But if not, then be very careful because we're going to use a different approach in using if statements. So let's go ahead and check out this example. So we have this example where we have the currency, which is, for example, euros. And then I want to check if the currency is double equal, I'm comparing, is equal to dollar, then I would like to print something like US dollar. So for now, if I execute that, as you can see, nothing happens. But what if I want to check other currencies as well? Not just the euro one, not just the dollar one. I want to check out others. So I'm gonna have an else here. So if the currency is not a dollar, then I can go ahead and have an else. And in here, I'm going to check again. If currency is going to be yen, and I have yen prepared here. I don't know what the combination on the keyboard would be to get yen, but I have it prepared here. So if currency is yen, then please write something like Japanese yen. Then I need to check another else if I want to check another currency. So let's say I want to check if the currency is, for example, euros. Then please go ahead and write something like print euro. But then there could be another currency that I want to check. So let's say I want to check if the currency is a Thai baht. And again, I'm gonna use a prepared sign here, the baht, and then I'm gonna print something like Thai baht. And as you can see, if I execute that, it executes euro. But there is something to consider here. As you can see, the more I get, or the more currencies I'm checking, or in general, the more things I want to check, the more indentions I need and the more weird, I'd say, my code looks. So in this case, I have an if statement, then in the else, I check the next if. In the else, I check the next if. And while that is valid code and it totally works and it's totally fine, and there might be people who prefer this style, it's usually not the best way to do it. The better way is to use ELIF. And what ELIF does is it checks if an additional condition is true. And let's just see this particular example in an ELIF example. So instead of using else, I'm checking ELIF. So ELIF currency is yuan, then please go ahead and do that. The same here, else if or ELIF currency is going to be euro, then please print euro. And the same here. So let me get rid of the not required characters, and I'm gonna go back. So that would be the ELIF version. So it's exactly the same result that we get, but it looks a lot cleaner and it's a lot easier to read. So we have this if statement checking out currency is equal to $, and if that's the case, print $. Else if, or ELIF, so if this is not the case, then please go ahead and check that. And if it's true, then execute this code. If it's not true, then check the next one and execute the code if it's true, or if the next one is true, and so forth. But there is one thing to consider. It's really important, because if this statement here is true, then that statement will never be executed, neither that nor that. So if one of them is true, the following ones within the same statement, so within the same connection, will not be executed at all. So in our case, let's say I have dollar or euro here, and I have another one in between. So let me run it like that. And I'm gonna say euro 2 here. And if I execute that, euro 2 will not be printed out, even though this statement is as true as that one. And that is because it's getting out of the whole if statement as soon as one of the statements is true. And that is a very, very important concept, because if I do things like this later on, so I'm gonna check for currency here within the if statement and I execute that, as you can see, that works easily. Even if I do it like that now, that works perfectly right, because this is a completely new if statement. But this one here is completely connected. And as you can see, you simply use this keyword ELIF, and it stands for else if, and that's a general approach for else if. So once again, what's the advantage of using this approach over that one here? It's mainly the readability, and secondly, it's the correct style. Welcome to the 5th chapter. In this chapter, we are going to look at control structures, and it's going to be part 2, where we are going to look at loops and other great stuff. So let's go ahead and start with a while loop. What does a while loop do? Well, so far we had code that only was executed once. So we had this code and it was executed line by line. Now we can use something called a loop, which will rerun a specific piece of code multiple times based on certain conditions. So let's have a look at that. Let's create a counter variable. Let's set it to 0 and then create a while loop. And in order to create a while loop, you need to use this keyword called while. And then you need your condition, which has to be true for the while loop to run. And at one point, this condition has to find an ending so that we don't get an infinite loop. So a good example for such a condition would be counter less than 10. And then we need a colon after that condition, or after this counter less than 10 in this example. So now indentedly, we need to go ahead and add our code block that we want to execute as long as this while loop is running. So let's say I want to print the counter value onto my console. If I would do that, if I would execute this code here, I'd get an infinite loop and my program would crash. So I need to add a line of code which takes care of this statement here, which is currently true because 0 is less than 10, to at one point not be true anymore. And how we can do that is, for example, we can say counter is equal to counter plus 1. What that will do is it will increase the value of counter each time that this line of code is executed. Let's just execute this code and see what's going on. There we are. It's printed onto our screen and we have 0 to 9 printed on it. Why 0 to 9? Well, we are checking in the first time that we run this first iteration. We are checking, is counter less than 10? And as 0 is less than 10, this is true. What it does, it executes the whole code that is part of the while loop body. And in this case, the while loop body is everything that is indented within the while loop. So here, this line here is indented and that line here is indented as well. So let's see an example where a line would not be indented. So this one would be hello world as example. Let's run that. As you can see, it's not indented. That's why this line of code is only executed after the while loop is done. If I, for example, indent that code and run it, you can see hello world is printed every single time. So this statement here is taken as part of the while loop. So you have to be very careful with your indentation or with your indenting. All right, so we had the first execution, right? First iteration of the code. Then it's printed on the console, we see 0. And then the counter is increased by 1. So the variable counter is 1 at the next iteration. So we check again, is 1 less than 10? If that is true, then go ahead and run my code. And in fact, 1 is less than 10, so let's go ahead and run the code. So the next time it's 2 and 3 and 4 and so forth. Then at one point it's 9, so we check, is 9 less than 10? Yes, that is true. All right, so please execute the code. So print counter and then increase counter by 1. So now counter will be 10. In the next iteration counter will be 10. So we check, is 10 less than 10? And that statement is false, which means that this while loop finds an end. So it stops executing and we go to the next line of code. And in this case, it's the print statement here. All right, so that's a while loop, just one example. And as I said, this has to be a statement that can be true or has to be true at one point and has to be false at another point if we want to execute the while loop. And we will see multiple examples using while loops, not just with counters, but other ones as well. And we are also going to check out other loops. And in the next video, we're going to check out the for loop. So see you in the next video. Welcome back. Now that you've seen how to use the while loop, let's have a look at the for loop. And we are going to create a for loop by using the for keyword. Afterwards, you have a counter variable as well. And in this case, I'm going to use I, and that's generally the letter that you use for the for loop. And then you say that you want to go through a specific range. So in this case, I'm going to go through a range of 0 to 10, which does not include the 10. And then afterwards, I can simply run my code that I want to execute the amount of entries that I have within the range. So in this case, the range will be from 0 to 10, not including 10. And if we execute that, we can see that. So 0 to 9 is what I'm getting. So that's very similar to what we have seen in the while loop. Now, this range here is in fact a list. So when I'm creating a range, it just goes through the list. So instead of using a range, I could just go ahead and use a list for the for loop. So let's create a list. I'm going to call it list 1, and I'm going to add values in there. So for example, 5, 8, and 10. And now I can use a for loop in order to iterate through this list. So I'm going to go through list 1 and I'm just going to print I. And what will I be now? Well, let's have a look. As you can see, I is not 0, 1, 2, as we would have expected from here, but it is 5, 8, and 10, as I is simply the value within the list that is currently iterating through. So we have this iteration through this list of 3 values. That's why we get 5, 8, and 10 as the output. Similarly to what you have seen in the while loop, you can of course add other code that has to be executed within this loop. So I could simply also go ahead and write something like hello world in here, and that will be executed each time that this for loop runs. So whatever is indented within the for loop or is part of the for loop code block or the body will be executed in each iteration. Now, this is a very basic example where we say hello world, but there will be plenty of great examples in the future where you will see the advantage of using loops. It's not just to create counters which show us a certain value, but it can be super useful. And that will make a lot more sense once we get into practice mode. So for now, just remember how to create a for loop, or memorize how to create a for loop. You simply use the for keyword, then you have the counter variable, which in most cases should be I, within, or then you use the in keyword, and then the list that you want to run it through. And if you want to create a list out of values between a specific value and another value, so in this case between 0 and 10, you can use the range function. So this will create a list with the values that you enter here. You can of course go ahead and not just print I, but you could multiply it by 2, for example. As you can see now, we get this 2, 0, 2, 4, and so forth, and so forth. So let's say I want to go through the range of 5 to 15. I can do that as well, and I'm multiplying it by 2, so we get 10, 12, 14, and so forth. So now you have seen range and you've seen for loops, and in the next video we will check out when to use for loops and when to use while loops. So see you there. Welcome back. Now you have seen how to use while and for loop, and there is a question when to use which loop. And in this case, I'm going to check out the while loop first. In the while loop, you usually would use that when you know how often you want to iterate through something. So in this case, I know, okay, I want to iterate through it 10 times. So I'm just going to use this very simple counter. Or when you want to loop through something until a specific condition is not met anymore. And that's when the while loop makes most sense. But then on the other hand, the for loop, it makes sense if you want to go through a range, a list, through a collection of any type. So for example, a string could even be a collection. Then a range is a list pretty much, which you can go through, and so forth. So whenever you want to go through a list, a set, a tuple, a map, or even a string. And we haven't seen what maps, tuples, or sets are, but we will later on. So the for loop is great in order to loop through something, and the while loop is great in order to run code until a condition is not met anymore. So as example here, we have this for loop, which simply runs through a list that we have created, which contains several strings, and it's just going to print out the name of every single element within the list. So here it's Mike, Pike, and Reich, and that's generally what you would use a for loop for. That's not something that you would usually use a while loop for. As you can see, you cannot run through lists with while loops, at least not in an easy way, and that's the pretty much biggest difference. And we will see multiple situations where we use while loops and for loops, and you will see what sets, maps, and tuples are. So see you in the next video, where we are going to check out, well, there will be a quiz first, and afterwards we're gonna check out break and continue. So see you there. Welcome back. In this video, we are going to check out the answers for the last quiz. And first of all, task 1, how do you check if the hit element is included in the following list? So we have this list 1, which has fail, fail, hit, fail, direct hit as its text in here, and I have a sign too much in here. So we have 4 different answers possible: hit in list 1, then bullseye in list 1 included hit, and list 1 in results. And the correct answer here is hit in list 1. So we simply use this in operator to check if there is a string in there which is called hit, or which has the content hit. So the correct answer is A. The other ones, well, bullseye is incorrect because that's not actually what we're searching for. Then this included function is not available, so that's a fake function. And then we have this list 1 in results, which is also incorrect because we're not checking the string results, but we're checking the list 1, which contains the hit, or should contain the hit. So this whole D answer is completely incorrect. So what is the short form of else if in Python? And then you have else if, ELIF, and ELSIF. And the correct answer is ELIF, and that is the C answer. Now, finally, task 3, or not the final one, but second last one. How often is the following for loop run? So we have for I in range
1 to 10. And here you have to consider that we're not starting at 0, but we're starting at 1, and we're not ending at 10, but we're actually ending at 9. So we have the values from 1 to 9. So guess what? How many times do we run this code, or is the for loop run? Well, A is 10 times, that's incorrect. B is 11 times, that's also incorrect. C is 8 times, which is incorrect either. And then we have this 9 times, which is the correct answer. So the correct answer will be D. Why is that? Well, if you count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you see that's 9 numbers. So this code will be run 9 times. And of course, you can check the code if you want to make sure that the correct answer is D. Then finally, task 4, what do you have to pay attention to when using a while loop? Well, to put the loop condition in brackets, that's not really the case, right? So A is incorrect. B, that the loop terminates. That is, it does not form an endless loop. That seems to be very important. So B, yes, B is correct. Let's check out the other answers as well. C, to end the loop with the signal word stop. In particular, there must always be a semicolon after stop. Well, that's incorrect. And to put the code block in curly brackets, that's also incorrect. So that might be the case for other programming languages, but that's not the case for Python. Then we don't have this stop, or at least we didn't use the stop signal word yet, but the correct answer is B. The loop has to terminate at one point. Otherwise we have an endless loop or an infinite loop, and that's really not what we want to have. So B is the correct answer. Welcome back. In this video, I would like to talk about continue and break, and those will be two very important words when working with loops, and they're keywords which indicate in Python that Python knows what they're doing. So we will check them out. Let's go ahead and create a little loop for that. For example, a simple for loop, and where I'm going to use in range 0 to 10. And what do I want to do? Well, I want to simply print I. So as you can see, we're just printing 0 to 9. Now let's have a look at continue. Let's see what continue does. So in my for loop body, or in my for loop code that I want to execute each time it's iterating, I'm going to check something. I'm going to check if I is equal to 3. And if that is the case, I'm just going to say continue. And what will that do? It will simply say, okay, I'm done with this iteration. I don't want to do anything else within this iteration. I just want to jump out. And that's what this continue will do. So let's execute that. And as you can see, 3 is missing. So let me print some code in there as well. Print I skip on 3. So let's check that. As you can see, 3 is being skipped. So 3 is not being printed out, even though I at that point is 3 and this print statement is there. But, well, it's not printed. And that is because this continue just says, okay, please go ahead and jump to the next iteration of that for loop. So it's 2, then it turns 3, it executes this code, and then it says continue. Okay, now it knows already, okay, I need to jump to the next iteration. So it's going to skip anything that comes afterwards. So let me show you another text in here. Print after the if statement. So let me see. Okay, after the if statement. So after 2 it says after the if statement, and then I skip on 3 doesn't say after the if statement. So there you are. That's what continue does. So it simply goes to the next iteration, so the next run of the for loop. Now that's the continue statement. Now let's check out the break statement. So let's go to the next line, and I'm gonna create a list for that. Or actually, let's do it with this print statement as well. Let's keep it simple at first. Okay, so I'm just gonna, instead of using continue, I'm gonna break. And I'm gonna write something like I break on 3. So break in the sense of breaking your brake in the car, so stopping, making the thing stop. So that's what this break keyword does. So let's run it, and we see 0, 1, 2, and then I break on 3. So now it's 3, and it simply breaks out of this whole for loop, even though it should have gone on until 9.
Now it doesn't, because we break out of it. All right, so that's the power of this break. Now, this is a very basic example, and you might say, okay, why would I use that? I can also simply create a for loop with 2 iterations, and I can print it out in a different way and so forth. Well, that's true, but let's imagine we have a list of the weight of people. So list with weight, and it's gonna be something like 55, 35, or 36. I'm just gonna enter some values in here, okay? 59, something like that. So the values are not that important. What is important though is the following. So I'm going to create a variable that I'm gonna set to 0. And this is going to be, let's say, total underscore weight. So we have a total weight. And now I'm gonna create a for loop where I'm just gonna say element in list with weight. So I'm just gonna copy that in there. And what I want to do is for every single element that is within my list with weight, I want to add that to the total weight. So the values in here. So I'm just gonna say something like total weight is equal to total underscore weight plus element. Okay, so what that will do is it will add 55 to 0, then it will add 36 to 55, then it will add 59 to 91, so the sum of those two, and so forth. And now I want to print the total underscore weight. So now I'm just going to use it without the break statement, right? So we see here, first the weight is 55, then it's 91, then 150, 279, and 338. So now let's assume we are an elevator, or we have to program an elevator, and it needs to check the weight of every single person on it, then it needs to check the total weight. And if the total weight is too high, then it's just gonna say break. And it's gonna say, okay, last person or people afterwards may not enter the elevator because it's already full or something like that. So let's just do that. Let's say, okay, if total underscore weight is higher than, let's say, 200. So we can only take 200 kilograms or pounds or whatever weight scale you want to take. I would take kilograms here. So we have 200 kilograms as a maximum weight, and we have a very small elevator here, right? So usually only 2, maximum 3 people may enter. So if that's the case, then please do the following. Please break. And maybe write something like print elevator is full. And now let's print that or run it. And as you can see, we have 297, and afterwards the elevator states that it is full. So what we can say, instead of saying elevator is full, we could also say elevator is full, last person who entered should get out. That's it. So let's run it again. And as you can see, elevator is full, last person who entered should get out. So we had the situation where the weight was 150, and that was fine. So 3 people were in the elevator, and then a very heavy man came in, and we just said, okay, please get out. Otherwise we can't start elevating. And that's pretty much it. So we have created this little program which will check for the weight and which we can use for an elevator. And that's generally how you can use break as an example. Of course, there are plenty other examples, but that's just a real life example. And that's it. So let's check out the next video where we are going to look at how to solve problems. So how to handle problems. So see you there. Welcome back. In this video, I would like to talk about how you handle problems, or how you handle the situation of having problems. So I'm just gonna create this very basic piece of code. I'm just gonna create this very basic piece of code where I'm just printing hello and plus a number. So if I run that, I'm getting an error. And that's something that can happen quite a lot. So getting errors is very normal. But let's just assume that you have created an error that doesn't appear for you, but it appears for other people. And then somebody tells you, hey, you have this error, there's something not working, my button is not working or whatever. So for you, it doesn't make sense because it works on your machine. So the first thing you need to understand is, where does the person come from, or where is the problem coming from? And that can be many different things. So it could be the version that you're running. So for example, the person is running something on Python 2 and it doesn't work, or it's running it on a different browser. So the person is running it on, let's say, not Chrome, but the Internet Explorer or Edge or Opera or whatever. And things look different there, and some features are not installed or not working on that version or on that operating system or on that browser. So depending on where the person comes from and what the surroundings generally are, you can have different kinds of problems. And that is the first thing you need to always understand. So what is the potential problem? So where is the person coming from? And then you can go ahead and debug. So in this case, it's very easy. So we have the situation where we have a type error. So we can simply go ahead and copy that code or mark that code and Google for it. So we can just say search Google for type error must be str not int. So let's just do that. Or we could just enter that piece of text here into Google in general. And what we get here is multiple answers or multiple results. We can of course go to Stack Overflow, and Stack Overflow is a great website where you have so many different people answering questions and so many people helping out other people. And as debugging is a very important, generally a very, very important aspect of programming or of the job of a programmer, you will find many people, even very experienced people, posting problems and issues on Stack Overflow, and other people who had the problem already or who just like to help out will post some of their ideas how to solve this problem. So in this case, it says Python type error must be str not int. In this case, it's a duplicate, so there is a different thread where this was answered already, but there's somebody who posts this problem and he worked with stuff, and as you can see here, he's using temperature. And in here he's using temperature as well. And temperature is a string, or is not a string, as you can see, it's an integer. So it's a total or a whole number. And that's why this line seems to be the issue. At least that's what I would expect straight away. So that's the error that the person gets. And then below that, he sees 3 answers, or in this case, it's 3 answers, and people can upvote or downvote the answer that was given. And he just says, okay, please make a string out of your temperature, and then your code should be fine. So cast it to a string using the str function. So that's great. And as you can see, there's a check mark, which means that the poster of this problem accepted this answer. So whenever you run into a similar error, or in general into an error, just search for it. Another thing that might help is that you add whatever version you are running it with. So as you can see, you can just press and enter here and you can see what people were searching for. So Python, Pandas, Python 3, and so forth. So you can just go ahead and say, okay, I'm having this problem in Python 3, and then you might get different answers. As well as here on Reddit, somebody also posted it and had a problem here. So that's generally how you can go ahead and search for issues. And don't be disappointed about this. It's a very normal thing to happen. There are plenty of pros who still have plenty of issues or plenty of errors coming up, because sometimes you just don't see a little error that can come up, and sometimes you just don't know what's going on. Or if you're not very experienced, then you will have very many basic errors, but sometimes you will have complex errors, and sometimes it's just enough to restart your computer and your error disappears, or restart your browser or stuff like that. So I had this issue with some of my other courses where people said, hey, it doesn't work, I cannot create a project with Android Studio, I still get this grel error and this R error and so forth. And then I can just tell them, please restart your machine, and then people come back, hey dude, that helped out. So sometimes it's really just restarting your PC, sometimes it's something like you see here, sometimes an error doesn't show up but still stuff doesn't work the way it should. So if you ever have this situation, It really makes sense to search for the behavior that you are searching for or that you would like to achieve, or searching for the behavior that you are getting, or both at the same time. So if you search for that on Google, then you will most of the time find a solution either on Stack Overflow or on other forums which have plenty of experienced developers who will help out. And sometimes the error is really just one little sign, and sometimes it's a lot more complex. And yeah, it's a very normal thing. Even sitting there and trying to solve an error for multiple days and debug an error for multiple days is not uncommon. Of course, when you're starting to learn and that happens, that can be a real bummer, but in usual cases, you'll find a solution real quickly. And of course, you can always ask in the course discussions and we'll help out. All right, so I hope that helped you whenever you run into errors, and you will think of this lecture and you will think of the approaches that I've displayed. And in the next video, we are going to look at a pretty cool project, which is going to be Trump Twitter bot, which simply posts stuff like Trump does it, and it can be pretty funny. So let's just go there and see you there. Welcome back. I hope you're ready to build a Twitter bot, and specifically a Trump Twitter bot. Because as you might know, Trump likes to tweet stuff, and it's not always useful what he does tweet. And we're going to build a little tweet bot which sends randomly generated tweets out, and that will feel pretty much the same as most of Trump's tweets, at least from my point of view. So first of all, a little excursus, because we will need to know how to create random numbers, and therefore we will check out import random. So we need to import the random module, which allows us to use the random class. So as you can see here, I'm using random, this random class, and then there are certain methods or functions which I can use. And the one that I want to use is this randint. Randint allows me to get a random integer between a specific range, or within a specific range. So this will give me a random integer between 0 and 4. And specifically, let's just execute that. As you can see, now I'm getting an error because it says random is not defined. We need to import random first. So I'm gonna run that code first, and then I can execute that. And as you can see, now I'm getting the 1. Let me execute it again. I'm getting a 0, a 4 once again, a 0. As you can see, it always gives me a random number. So we haven't had the 3 yet, but it just randomly creates one of those numbers. So that's how you generally can create a random number. And how do we use that in order to create this Twitter bot? Well, let's go ahead and create a list. Well, I have a list here. You can, of course, just check out the document and get the list from there. Here, you can just copy some common terms from the tweets that he has made. And there are 4 parts. Part 1 is the name, or a name. So Putin, Hillary, Obama, fake news, Mexico, Arnold Schwarzenegger, the Democrats. Part 2 is no talent, on the way down, really poor numbers, nasty one, looking like a fool, bad bombs, or a bad hombre, not bomb, sorry, and got destroyed by my ratings, rigged the election, had a much smaller crowd, will pay for the wall. And so sad, apologize, so true, media won't report, big trouble, fantastic job, stay tuned. So these are the 4 parts, and we're going to create a sentence which just takes a random number of each part. And what we can do is we can create a list from another list, or generally create lists from other lists. And I've created this list here, which is called best words, which is simply a list that contains list 1, list 2, 3, and 4, which are parts, right? Part 1, part 2, part 3, part 4. So these are parts of a sentence. Now let's just print that out, and we get this little error here. Therefore, of course, we need to first of all execute the part code, and afterwards we can. So we have this list. As you can see, it starts with a square bracket, and then within there is a list. So it starts with a square bracket again. separated by a comma, then the next list within the list comes up until here. Then we have another comma separating the list elements and so forth. So we have these 4 list elements which contain a different amount of list elements. So why is it a different amount? Well, that makes it a little more difficult because in this case, in the first case, it's 7, and in the last case, I think it's not 7, or at least here in part 3, 1, 2, 3, 4, there are only 4 strings within part 3. So this list only contains of 4 elements. The other lists contain 7 elements or so forth, or another amount. So why is this important? Well, let's go ahead and check it out. We will see in a second. So I'm gonna create a little piece of code here for part in best words. So I'm checking all of the words, and I'm going to check a specific part within those best words. And as you know, best words is a list containing lists. So I want to check one particular list within the lists and print stuff about that list out, and then go to the next list within those lists. So you have pretty much this part being a list now. And what can we do with lists? Well, we can do stuff like checking out its length. So let's just print the length of that part. So as you can see, the first part has 7 words, second 6, the third has 4 words, and the 7 has 7, or not words, but elements within that list. So in this case, it's always strings, right? So we have a different amount of values. Why is that important? Because if we want to get a random value out of each part, we need to know what the range is. Because as you know here, we had the range from 0 to 4. Now, if we know that there are 7 elements in there, what we can do is we can get a random part from 0 to 6. The 7 not included, of course, because we will already have 7 different elements. And as you know, calculators or computers, they start with 0. So Putin is 0, Hillary is 1 or index 1, Obama is index 2, fake news is index 3, and so forth. Now, what we can do is we can go ahead and create a variable which will contain the random element. And we will just say something like random dot randint. So we are calling this randint function. And here we start with 0. And the range will be len.part. And here it's important, -1. Why is that? Well, as I said, if the length of the part, so the length of the list is 7, then we only may enter 6 in here. Otherwise, we get an exception, we get an error. Let's check it out. If we execute that now, as you can see, we still get an error. Random is not defined, so we need to import random from the top there. Now let's run it again. As you can see, now it's fine. And R is working as well. So let's print that part out for now. Let's just check that. As you can see, the first element is Putin, blah, blah, blah. So that's the first part. Then the second part and so forth. So we get them here. That's fine. And now let's check out what R is. Let's get the random value as well. So let's print R. And we see R is 1. Now it would be 5. Here it would be 0 and 2. Okay, so we get this random value already. So what that would do in this case, the sentence, if we now construct the sentence out of the values that we've just gotten, we would have 1 saying Hillary, then it's 5 being 0, 1, 2, 3, 4, 5. This is the last one, right? Hillary, bad hombre. Then it's the 0 here. Got destroyed by my ratings. Well, not that bad so far. And then the last one is this 2, which will be so true. So the sentence would be Hillary, bad hombre, got destroyed by my ratings. So true. And I'm really bad at impersonating Trump, but I guess you can make it up in your mind yourself how it would sound in Trump's voice. All right, so now let's use that in a correct format. So instead of printing R, I'm just going to print the element itself. So what I just did manually by, well, counting, I can do programmatically. So I'm just gonna say, okay, give me R from the part. So let's execute that again. And as you can see, we get Arnold Schwarzenegger on the way down, rigged the election, media won't report. So that's going to be the sentence, and we won't need that statement here anymore. So now we have the next sentence, which is Obama, no talent, will pay for the wall, so true. And now you can just go ahead and execute that once again and again. But what you have here is it being separate lines. So what we want now is it to be one sentence, so one line, which can be printed onto the console and not 4 different lines. So fake news, nasty tone, had a much smaller crowd, so true. All right, so now let's go to the next step, which is first to create a new list. So I'm going to call that sentence, which will be a list, and I indicate that by using square brackets. And now this is just an empty list. So sentence is an empty list. And then I want to print sentence in here, sentence, and it will just print an empty list for now. Now let's fill that list up. And how do we fill it up? Well, I want to fill it up with the part R, so with the word that we get. So with Obama, no talent, got destroyed, and so forth. Because as you know, we can make a string out of a list with the join function. And we can add an element to a list by using the append function. So let's do that. Let's add a sentence or a line in here where we just use sentence dot append. So add something to the sentence. And what should we add to the sentence? Well, we should add part at the position or at the index of R. So now let's print the sentence. And as you can see, this is going to be the sentence as a list. But now I would like to make it a string. So how do we do that? Well, first of all, we won't need that print statement here anymore. That was just printing that here out. But we will need the following. So we're going to use the join function, where we just say, okay, empty space dot join sentence. So let's run that. And as you can see, now we get this sentence. Mexico, no talent, had a much smaller crowd, apologize. So let's run it again. Obama, really poor numbers, got destroyed by my ratings, so sad. Actually, that's a good sentence. That could be something that Trump actually posted out. Some things don't make that much sense, but well, which post does that, right? All right, so now we don't need to print the sentence out here anymore as we did, but we can just leave the code as that and maybe add an exclamation mark to the end. So let's just do that. And as you can see, Hillary, no talent, will pay for the wall, apologize. And there we are. So you can now play around with it. And of course, you can anytime extend that. So that's the cool thing here. You can just say, okay, I'm going to extend it. I'm going to add another part to my little program, to my bot. And you can, the only thing you would have to do is actually add a part in best words here. So you could just say, okay, part 5 and several words. And then you just add comma part 5 in here in this best words list. And the program would still work. So it's an extendable program, which is very easy to maintain, even though it's really just those actually 5 lines of code if we check it out. So it's just 5 lines of code and the rest is just the preparation pretty much, right? Great. So this is your first little tweet generator. Now you can of course go ahead and try to expand that tweet generator. And in the next lecture, you will find a sheet again with some information, a handout pretty much, and a challenge following that. So go ahead and execute the challenge, have fun and good luck with it. And then afterwards you'll see the solution and then the next chapter. So I hope you enjoyed this little tweet generator. If you went ahead and extended that, please share it with us. I would really like to see what you came up with, or maybe you even take real statement from Trump or anyone else and make a little part 5 of it or multiple parts, then please share them with us as well. It's always a good laugh. Great, so see you in the next lecture. All right, I hope you managed to go through the final challenge and answer most of the question or even all of the questions correctly or tasks correctly. And in this video, I'm just gonna go through them step by step in a more extended way. So if you feel like you need to see how I'm doing it, then please go ahead. Otherwise, you can just skip this video. Okay, so the first task was output all continents from the continents list one after the other. So we have this list of continents containing Africa, Antarctica, and so forth. And now our task is to print them onto the screen, as you can see here. And how do we do that? Well, we have learned something called for loops. So let's just do that. Let's create a for loop which goes through this list of continents. And it just prints out every single one of them. And that's done with this for loop, as you can see here. So I'm just saying, okay, for I in my continents, print I. What does that do? Well, it says, okay, for the current element that you're looking at, go ahead and print it out. And which elements are you looking at? Add all the elements within the list of the continents. So continents is a list, and I is in the first iteration Africa, in the second iteration it's Antarctica, and so forth. So if I now execute that code, as you can see, I get the result that was desired. All right, so that's the first task. Let's have a look at B. Output only the inhabited continents from the continent list. And here it states Antarctica is uninhabited, so you can skip the content at that output. All right, how do we skip something? And I hope you remember the lecture about continue and break. If you don't, then you can quickly go back and check that out and try yourself if you didn't solve this one here. So I'm just going to enter the code now. For continent in continents. So that's another way how you can call it. So in here we just called it I in continents, but you can of course give it a more descriptive name. So for one single continent in the list of continents, please do the following. Check if the continent is called Antarctica. And actually here you have to be super careful, so I'm just going to copy that name from there. Antarctica. Then continue, which means just go to the next step within the list. And otherwise, print continue. Actually continent, like that. All right, so let's execute that. And as you can see, we have Africa, Asia, Australia and Oceania, Europe, North America, and South America. So that's how we skipped Antarctica, as it is uninhabited. At least that's the statement here. And that was the desired output, and that's exactly what we've gotten here. Now output only the continents from the stuff list. You can loop through the list stuff and then use the variable continents to check if an element of the list stuff also appears in continents. And that's a little more tricky, but we can do that, and we have done it already. So what we have done the basics of that already. So what we need to do here first is go through the list of stuff. So we can check for element in stuff. Go ahead and check if the element is in continents. And if that is the case, then just print the element on the console. And that's it. So it's a very short code, but it compares the two lists together. So it compares the stuff list to the continents list, and it gives us the elements that are within each other. So in this case, it should be Asia and Antarctica. So let's execute the code, and I'm getting a little error here. So let's see what the problem is. And it says stuff is not defined. And that's something that you might come up with yourself, or that's an error that you might also get. And that's because stuff is not defined, and we need to execute stuff before we execute this line of code. And as you can see, we get Asia and Antarctica. How many continents are included in the list stuff? Write a loop to count the number of continents in the stuff list and then output this value. Well, there might be different solutions to this. I'm going to show you one of mine, and that's creating a variable that we're going to set to the value of 0. We're going to call it count. And then we go through the stuff with a for loop. So for I in stuff, if I in continents, then please add 1 to count. Count plus 1, like that. And then finally, when this whole thing is done, when this for loop is done, just print out the count and tell us how much it is. And as you know, it's Asia and Antarctica, so it should be 2, as the desired output tells us as well. So we just modified the code from here a little bit. We just said, okay, we have a discount variable or counter variable, and then we just go through the stuff. We check if one of the elements within stuff is also within continents, and if that's the case, then we just add 1 to count. Okay, so let's execute that, and there we are. We get the desired result of 2. And then there is an alternative path how you could have done it. You could have used the following approach. Let me show you real quick. You could have done something like contes. I'm just going to call it contes is equal to a list, and also just go through the list as we did before. But now, instead of just adding 1 to count, just say contes.append I, and now finally just print the length of this contes list, like that. So that's another approach that would have been fine as well. All right, so of course there are multiple different versions, but that's 2 that I would come up with here. All right, so the second task, a discount campaign. So now let's go back to the mathematician, and if you haven't done the exercises before, you might not know the mathematician. She wants to start a discount campaign in her shop to boost her business. Of course, she has something to program for you again. You should simplify the calculation of the reduced prices with an if, ELIF, else structure. Note the following: items costing 0 and 20 thalers, which is the currency that mathematicians use, inclusive, will be reduced by 20%. And items costing between 20, not inclusive, and 50 thalers, inclusive, will be reduced by 40%. All other items, i.e., or for example, items costing more than 50 thalers, will be reduced by 60%. So that's quite a good discount. So output the new discounted price for the price variable. So we have this price variable 50, and now you have to be careful. How do you do that? Well, let's check it out. Here comes your if, ELIF, else structure. So let's build that. So first of all, we want to check if the price is lower equal 20. Why that? Because we say 0 to 20 inclusive. So 20 is included. That's why we need this equal sign here. If that's the case, then just say price is equal to price multiplied with 0.8. Why 0.8? Well, because if you want to reduce 20%, it's the same like saying multiplied with 80%. So that's what we're doing with this 0.8. We multiply it with 80%. Okay. Then the next one is an ELIF. So if the price was not less than or equal 20, the price could be between 21 and 50 inclusive. So we can just say something like price less equal 50, and in that case we had to reduce the price by 40%. So how do we do that? Well, we just say price multiplied with 0.6 or 0.6 to be precise. Why do I only need less equal 50? Why don't I need to add the function or the statement that it's between 20 and 50? Well, that's because within this if statement or within this if ELIF structure, the situation will always be that if this statement is not true, then that will never be executed. So whenever this is executed, the price is already higher than 20. So which means that it's at least 21. That's why this line of code is totally sufficient. And now we have finally the else statement saying that everything higher than 50 thalers should be reduced by 60%. All right, so let's just say price is equal to price multiplied with 0.4, which means now the price will only be 40%, which is equivalent to the price being reduced by 60%. So now let's execute the code, and as you can see, our price of 50 inclusive will be reduced to just 30 because it was multiplied with 0.6. And the desired output was 30, so we're good to go. All right, now B, calculate for each of the old prices from the prices list the appropriate reduced price and save them in the new prices list. Finally, output this list. Okay, so we have this list prices saying 2, 50, 70, and 30. And now we have this other list, new prices. And now we need to fill it with the new prices and print the new prices on the screen. And as you can see here are the desired outputs that we should get. And as you can see, this 50 and 70 is pretty interesting because the 50 price is reduced to 30 and the 70 price is reduced to 28. So products which were more expensive than 50 euros or dollars or thalers in this case will become even cheaper than the ones which cost 50 up to a certain price. All right, so now let's enter the code in here. So what we need to do is we need to again have a for loop because we need to check through all of the prices. But within the for loop, we're just going to execute the code that we had here. So what I'm going to do is I'm going to create a for loop for price in prices. So go through all the prices, so through the whole list here, and take the price. So in the first case, it will be 2, in the second one will be 50, then the 30, then 70, then 30. And what should you do with it? Well, you should do what we had here. So let's just copy that code here and let's paste it in here. And of course, we have to be careful that everything is indented correctly. Whenever you copy and paste, you have to be super careful that everything is indented in the correct way. Now there's one line missing, of course, because the new prices, they're not added to, well, these new prices, they're still not added to the new prices list. So what we need to do here is we need to say new prices dot append price, because we need to add the new price that we just generated to our new prices list. And what that will do is if we execute it, it will create the new prices and add them to this list. And there we are. It's exactly the desired output. Now you might say, oh damn, we needed to copy code and it's reproducing code, and isn't that something that you shouldn't do in programming? Well, yes, it makes sense to create a function yourself when you have this situation as we do here, but functions is something that we're going to cover in the next chapter. So I hope you are already looking forward to using functions in order to sum things up, so we don't need to copy and paste code, but we can simply write one line of code which will do the same. But that's something for the next chapter. All right, so now let's go to the additional task, which is a difficult one. So now the mathematician presents you with the trembling hands with the list chaos. So there's a list called chaos, as you can see here, in which new and old prices are mixed. In the face of this ill-considered work, you clench your hands in front of your head, but it doesn't help. Only you can restore order here by bringing together everything you have already learned. Scroll through the items in the chaos list. With a new price, simply drag the new value from the string and append it to the order list. With an old price, however, you get the old value. Calculate the new price and add this value to the order list. Finally, output the complete order list, which only contains new prices and only numbers. Here it's important that it's numbers and not text, right? Tip: with the in operator, you can check if old or new appears in a list item. Old in old prices is going to be this one here. It's going to know, okay, this is an actual old price, and decide if you want to make the discount or not. So now we need to add our code and create the order again. And the desired output, as you can see, this is what we have here. And now let's go ahead and write the code. So we start with a for loop again, for I in chaos. So we go through the chaos. Then what do we want to do within the chaos? Well, first of all, we want to split it at the colon, because we know after the colon comes an empty space and then the number that we want to have. Before that comes this old price thing. So let's split that up. Price is going to be the integer which comes after the colon and the empty space. So int I dot split and colon empty space. And then we want to have the entry which is at the second point, which means we need to enter index 1. So if we simply print price now, let's just check out what that is. We can see now we get 40, 21, 29, 50, and 101. So we only get the numbers, and as a fact, we get them as integers, so as whole numbers. That's what this int function did for us. So we already converted them to the right type. Okay, now we need to check if within that particular entry within our chaos list there was the word old. So let's go ahead and do that. Instead of printing the price, I'm going to get rid of this line. I'm going to check if old was in I. And if that's the case, then just execute the code from here. So pretty much just copy the code from here and execute it here. And of course here we have to be careful with the indent again. So we need to indent everything by one tab. And now it will say if old, so the old word was within the I, then please go ahead and do the calculations accordingly. And after that is done, add that to the order. So append to our order the price that you have. So either it is the price that we didn't change, or if old was included, then it is the price that was changed. So now if we print that again, we can see 24.0, 21, 17.4, 30, and 101. So that's the code that we needed to create. And as you can see, there is a lot connected from what you have learned. There are lists in here. Then there is this for loop, which runs through a list. We use this in order to go through a specific list, right? Then we split something up. We use an element of that particular list. So this pretty much creates a list by itself, right? And we take the second entry of that list. And afterwards, we make an integer out of it. Then we use an if statement in order to check if something is in our element of that list. So we're using the in operator, and we use even more if statements in order to do some calculations. And finally, we even append something to an empty list that we had from the start, and we print that list out. So as you can see, very many different features and functionalities of Python that we have covered in the last chapters are all combined in this exercise. And here you can see how things come together in an actual practical case. I mean, this is a very basic example, but that could really be something that someone needs from you because they mixed up their prices or something went wrong and they need your help to get some order again. All right, so I hope you enjoyed that. I hope you managed to get most of that right. And if you didn't, no worries. And in the next chapter, we are going to check out functions, which are a super useful and interesting tool. So see you there. Welcome to the functions chapter. In this chapter, we are going to check out functions which allow us to combine code and make code much more efficient, and especially work together with other people, or in general, allow us to create more complex and greater programs as we've seen before. So let's check out what functions is all about. First of all, we have this question: why do you even need functions? Well, the thing is, there is a little problem with the code that we had so far. So far, we have simply typed down the code and we didn't really reuse code that we had before. We just copied and pasted it if we needed any other code that we had written already. For example, this if statement, which we had in one of the last examples and one of the last challenges. And that's totally fine for small programs. But as soon as you have a little more complex and greater programs on which you work multiple hours or even multiple days, then it becomes very complex. And in the long run, this is really confusing to not have functions or other mechanisms which allow us to make our code more readable, more reusable, more easy to use and understand. And that's where functions come into play. So they are the solution for this problem. So first of all, we are going to use functions, and we're going to use them a lot. This allows us to split the code into logical blocks. So if we want to run a specific functionality, then we can create a little block for that. And then if we ever need to reuse that functionality, we can simply call this function, and it's going to be super easy. And we have used with functions already. For example, we have used this str function, the append function, the int or the int function, and so forth. And that allows us to make our program a lot clearer and a lot cleaner at the same time. It's a lot easier to understand what's going on and what each code block does. Let's go ahead and use functions in this chapter. So see you in the next video. All right, so let's get started with functions. Therefore, first of all, let's have a look at a function that we already have used. And that function is the print function. And this print function is part of Python, and Python knows exactly what to do when we call this print function. So as you can see, we are calling print by entering its name and then having these brackets here. And in there we can hand over our argument. So I'm just gonna say something like hello world. Nothing too fancy, but as you can see, we call this function called print, and we give it an argument called hello world. So this is a string that we give it as an argument, and print expects a string or an integer or something that it actually can print onto the screen. So let's check out how we can create our very own function. So therefore we need to use the def keyword, and afterwards we can give the name of our function. So I'm going to call this multi-print, multi_print, and afterwards I need to have the brackets and a colon. And then in the next line, indentedly, I can go ahead and enter what I want to access whenever this function is called. So in our case, I'm going to say something like hello world, and I'm going to say it twice. So my function is going to be super simple. It's just going to print out hello world twice. So if I execute that code, nothing happens. That's because this is just the definition or the declaration of my function called multi-print. Now, if I want to call this function, I can simply enter underscore or multi_print and then the brackets. And what that does is it calls this function. So let me execute that. And as you can see, it says hello world and hello world. So it says it twice. And that's a cool thing, because now I can go ahead and just call this function and it will do everything that is within its declaration. So I'm just going to do it once again, multi-print. And as you can see, again, it printed out hello world twice. Now that is a very basic and simple example, but let's assume we have a little more code in there and a lot more is going on, something like connecting to the internet. So if we write an application that will connect our application to the internet, or it will download something from a specific site or something like that, and we don't need to write the code every time once again and again, we only need to have this function declared once, and then we can just call this function whenever we need it. And let's go ahead and create another function, this time a function with a parameter, because as you can see, print is called, but there is something within the brackets. And in our case here, there was nothing within the brackets. Why is that? Well, that's because our function multi-print doesn't have parameters, so it doesn't require an argument. So I'm going to explain what a parameter and an argument is in a second. But first of all, let's go ahead and create a multi-print 2. And as you can see, this is a new function. It's called slightly differently, and that's why it is a completely new function. And now within the brackets of the declaration, I'm going to enter a name for my parameter. So my parameter now is called name. And now after the colon, I can go ahead and write the code that should be executed whenever this function is called. So here I'm going to say something like print name, and then print my name is plus name. All right, so now let's call this function. Let's call multi_print, and it's print2. Here we have to be super careful. And now we can enter a string, something like, let's say, Dennis. So let me execute that code, and as you can see, it says Dennis, and then my name is Dennis. Now what happens if I try to do the same thing with my multiprint? So I'm gonna use Dennis in my multiprint, and that was this function here. So let me execute that, and as you can see, I'm getting a type error. So it says in line 5, I'm having this error. Multiprint takes 0 positional arguments, but 1 was given. So multiprint, this one here, doesn't have any parameters, so it doesn't take any arguments. So in the declaration, this thing is called a parameter, but when the function is called, it's called an argument. So Dennis here is an argument, but here it's called a parameter. All right, so it says that multiprint doesn't have any or doesn't take any arguments, but it was given one. So that's why this code doesn't work. So I just wanted to demonstrate that real quick. Now, of course, you can go ahead and write your own code, and I'm gonna write something else with multi_print. I'm gonna say another name, something like Frank, and now let's say Dennis, my name is Dennis, and Frank, my name is Frank. All right, so now you see that you can create a little piece of code which you can easily reuse. And here it's just a function with 2 lines of code, but it could have 50 lines of code or 20 lines of code. Generally speaking, a function is there for one particular task. So the idea behind a function is to do one thing. For example, download a file or connect to the internet or calculate something. So you see the advantage, it saves you time. It's a lot easier to read what's going on, and you can simply give it a very descriptive name, and everyone who checks your code out will understand, all right, this function does print 2 things at the same time, for example. All right, so see you in the next video where we are going to check out the functions part 2, in which we'll go a little deeper. So see you there. Welcome back. In this video, we are going to look at functions with multiple parameters and also at the return statement. So where we return something from a function. So let's go ahead and create a new function, which I'm going to call multiprint once again. And this time it's going to need a name and the count. So this time we're going to take 2 parameters here. And whenever we call this function, we are going to give it 2 arguments. All right, so let's check it out. Let's create a for loop, which will go through a range of 0 to count. So this function in the end should print out the name, the amount of time that we wanted to print it out. It's a very simple example, but let's use this for loop. And what do we want to print? Well, we just want to print the name in there. Nothing too fancy. But now let's go ahead and call this function. Let's call multiprint, and let's say Dennis, and how many times should it print Dennis? Let's say 5 times. And now let's execute it, and as you can see now it executed it 5 times. If you wanted to print my name out 10 times, then we could do it like that. So you can just enter how many times a specific value should be given onto the screen. And that's again a very basic example of what functions can do. And this function, it just takes 2 parameters and it requires them, or it has 2 parameters in the declaration, and it takes 2 arguments when being called. Now let's have a look at another function which will actually call another function. So I'm just going to call it another function, and what it will do is it will call my multiprint function. So I'm just going to call this here and say something like hello 3 times, and then say something like world, and this should be an E, hello world, and 3 times. So let's execute that. Let's call this another function that we've just created. And as you can see, it printed out hello 3 times, and then it printed out world 3 times. So you can use functions within other functions, and that's the idea behind this little piece of example. And now let's check out an example where we return a value. So these are just functions here which execute some code. They can take in some value, so they have an input, but they don't really have an output. So they just execute something. You tell them, hey, come on, here is my input, please run with it. So that's what these functions here do. But then there are functions which also return a value. They give you something back if you give them an input, or sometimes even without input, but we're going to look at one with an input. So let's say we have this function called maximum. And what it should do is it should take 2 values and then it should return the greater of the 2 values. So let's say we have two ages and we want to know which of the ages is the older one and want to have this age. Because here it's easy. We can just enter the values and we know what the values are. But let's assume we get this from a database where we don't have a look at all the data easily, but we just get it in a specific format, and now our program should check out what the oldest age in our group is. And that's what this function could do. It's a very basic example of a function, but that's what this function could do. So let's just say if A is less than B, then return B, and else return A. And now before we do anything else, I have forgotten this colon here, so it's really important to have the colon after the else statement here as well. And now let's just call this maximum function. So I'm just going to call this function and I'm going to enter 2 values, 4 and 5. Now if I execute that, I get an out here, but it's not really a print statement yet. So let me print that onto the screen. And as you can see now, I get this 5 returned. But I cannot just only use it like that. I can actually store the value. So I can store the result of my maximum function. And I can return or print that result on the screen. So let's do that. And as you can see, it says 5. Why does it say 5? Well, because 5 is the greater of the 2 values that we gave it. So let's say we compare 1337 and 2018, and it will return 2018. Okay, so that's generally how you can use a return statement. You can of course use return statements without an if, an else block in here, but that's a great example of what you could do with a function. And that is highly practical, so it's going to be super useful when we go on with our code and when we start building more complex applications. So let's have a look at the next video where we're going to have a quick look at objects, because that's something that we will need later on. So see you in the next video. Welcome back. In this video, I wanted to quickly look at something called objects. So let's go ahead and create a list. We're just going to call this list list1, and it will just have values 1, 2, and 3. Now I want to create this list, so shift enter, and afterwards I want to print that list. So as you can see now, it's just this list with 1, 2, and 3. Now the thing with lists is that lists are a very specific thing in Python, and not just lists but strings as well, and variables in general. So we have seen variables, and variables are treated like objects in Python. And let's have a look at one of these examples. So let's use this list1. So this list1 now is an object, and there is something called a class, so a declaration behind what a list should be able to do and what kind of capabilities it has. And one of the capabilities that a list generally has is to be appended to. So we can extend a list by using the append function. Now, specifically speaking, the append function is actually a method. So when you have a function that is declared within a class, then it's a method. But that's really something that we're going to look at later on. But what is important for now is that you can use functions onto objects. And the functions that you can use onto objects are declared within the declaration of the object itself, so within the class of the object. And we're going to create our own classes and our own object of those classes, and also we're going to declare our own methods within those classes. But that's really just a very quick example of what a function within an object or onto an object can be that we already have used. So we can just append 4 to our list and now print that list again. So as you can see now, the list has these values 1, 2, and 3. Now in Python, there is something pretty cool where you don't actually have to have a variable, but the type itself is already sufficient. So if I have something of a type string, let's say something like hello world, then, and let me say hello comma world, maybe that's better. And now I can even use a function onto that hello world string, which is internally treated like a undefined variable. So we can just go ahead and say something like split that at the comma. And now let's execute it. And as you can see, we get this list which contains 2 values. It contains the hello and the world, each as a separate string. But that's generally what you can do, and that's based on what is declared in the code of Python pretty much. So there are certain functionalities that Python gives you, and one of them is to split a string apart or at a specific character or at a specific string itself. And these are just 2 examples of functions that are declared within Python, and we have seen len, we have seen str, we have seen int, and so forth. These are other ones, and they are all declared within the classes of those specific types. And we will create that later on ourselves. So no worries, we're going to look into object-oriented programming with Python ourselves. And I would just wanted to show you this real quick for you to see that this is what's coming and understand a little better what's going on with these functions, because you might wonder, where the hell are they coming from? Why is there this append function? We never declared it ourselves. Well, it's just part of the list, you know, or part of lists in general. All right, so in the next video, we are going to check out how to open a file. So see you there. Welcome to the introduction to working with files. We are going to check out how to work with files within the next videos. So first of all, we need to understand how to open, then how to read, and later how to write files. But there is a little problem. Up to now, our variables were lost by the program after each restart. So each time we started our application once again, all our variables were gone. And how do we manage to restart the program but still keep the data? Well, there's a simple solution. We read and write a file. So in order to get the data back, we need to read it. In order to create the data or store the data, we need to write it. So first, how do we read a file? Well, there is something called CSV import, and CSV is a file format which you can easily read in a tabular data format, and that's pretty neat and very useful in general. And imagine, for example, recording an attendance list in Excel, and that's what you could do with CSV. If you export them as CSV, we can read them really easily with Python, and that's a pretty cool thing. So let's go ahead and do that in the next video. Welcome back. In this video, we are going to look at opening files. Therefore, I'm going to create a new Jupyter notebook, and I'm gonna call it read files. And it's important that you have a read.txt file if you want to go ahead with the code, that you have a text file with some text, it doesn't matter what the text is, in the same folder as the file of your Jupyter notebook, because we're going to read that particular file, that text file. So I'm gonna call this one 0607 read files. And in order to read a file, I can simply do the following. So I'm going to create a new variable, which I'm going to call file. and that one will store the result of the open function. So there's a function called open, and it takes two arguments. One of the arguments is to the name of the file as a string. So in my case, it's read.txt. As I said, it's really important that it has exactly the name that you are entering there. So if you have used a different name for a text file, then you need to enter a different name here as well. And afterwards, you need to tell it how it should open it. And I'm just entering an R standing for read. So it should open the text file and it should read the text file. So that's what this line of code says. Now in the next line, I want to read every single line of that text file. So for line in lines, or in file actually, in file, I want to go ahead and print that line. So let's just run the code, and as you can see, we have this hello world and we have this I am a new line. And if we check the text file again, you can see that there's hello world 1, 2, 3 and I am a new line. But as you can see, there is no additional line in there. So why is there this additional empty line in my print statement? Because for example, if I just print something like hello, and in the next line I'm gonna add print world. If I just print that, as you can see, there is no additional empty line in between. So it's just the hello and just the world line. So what that exactly is going wrong here? Well, there is something that this print statement automatically does for us, and that is to create a new line. So it just creates a line break. And in order to create a line break manually, we need to do something with a backslash. And there's something called a backslash. So you can use a backslash and then an N. What the backslash does is it escapes the next character. So what this will do, it will create a new line break, but this N and this backslash will never actually be executed or displayed on the screen. So let's have a look at that. As you can see, hello world is printed on the screen now. And that is because we create this line break. And the thing is, we have a line break in our read.txt already. So there is a line break in between here, between the I and the exclamation mark. There is a line break. And as you can see, there is this blue area here. And this print statement creates a line break itself as well. So how do we get rid of this line break? Well, in order to get rid of it, let's first of all look at something. So I can go ahead and print, instead of just printing the line, I can say something like line -1. So what that will do is it will give me the last character of that particular line that we're looking at. And if we look at the text file once again, we can see that there is a exclamation mark here. That's what is printed here. But for some reason, this exclamation mark is not printed here anymore. That is because after this exclamation mark, there's actually another enter or another line break. So that's why we only have this empty area here. So actually here are 3 lines, as you can see. So 1, 2, and 3. And it gives me the last element of my line, and that is actually a line break. So I can even check if it's a line break. I can do something like, is it a line break? And I do it like that. And now you can see the first line of my file, it's true. So the last element of the line is actually a line break. And in the second line, it's not true. So let's check it out again. In this line, it's true because afterwards there is a line break. And in that line, it's not true because there is an exclamation mark following. All right, so in order to get rid of that, we can use something called strip. So we can use line dot strip. So there's this function called strip. Now let's check it out again. And as you can see, we get hello world 1, 2, 3, and then in the next line, I'm a new line. So strip gets rid of these line breaks and keeps everything nice and clean. Why is that relevant? Well, if you read through files, it very often is the case that you need to have it in a specific format, and forcing it into a specific format for example, with a function like strip, is going to be very handy, especially as you want to do something with the text later on or with the file that you get. So for example, you get a bunch of numbers, then you want to run the numbers correctly and not have the problem of having line breaks in between. So it's always good to know how to handle your things. Great. So in the next video, we're going to see how to write a file, because so far we only read one. In the next one, we will check out how to write into one. So see you there. All right, now that you know how to read files, let's go ahead and write files as well. So write files is going to be this chapter or this video. And therefore we are going to create a file object, or in this case, file variable once again. And we're going to use the open function again. This time we need to enter the name for the file. So I'm going to call it write.txt. And afterwards, I need to tell which mode I want to use. And we had this R standing for read and the W standing for write. So now I'm going to write into this file. And now I can go ahead and use this file object in order to use the write function here and write some text into it. So this is going to be just some random text like that. And if I open a file in order to write into it, I also need to close it at one point. So I'm gonna say close here. So this is going to be closing my file afterwards. So now let's just run that code, Shift Enter, and then you can open up your folder in which you have this particular write files file. And then you can open this write text file. And as you can see, I have this text in there. And now if I go ahead and run the code with 2 lines, let's check it out now. So I'm going to go to functions again, open up my write.txt file. And as you can see now, I have the text as 1 line. So why doesn't it create multiple lines in here? Well, that's because I don't have a line break. And in order to create a line break, I can use \n. Let me execute that code once again. And let's check out the write file. Actually, let me open it up again. There you are. It's in 2 different lines now. So that's what we can do. That's how easy it is with Python to actually write files. Now that seems a little simple, right? To just write some text, a string into a file. But the cool thing is you can also do that with lists. So let's say we have a list of students, and I want to have my good old Max in there. Monica is in it as well. Eric is part of the list. And finally we have Francisca. And now I want to write that list into my file. So I want to store a big list of people that I have. I want to store it into a file, and I can do that with my for loop. So for student in students, go ahead and write the student in a new line. So I'm going to say something like \n here as well. So this is going to write Max in the first line, Monica in the second, Eric in the third, and Francisca in the 4th line. So that's how simple it is. Let's just execute that and open up our text file once again. And there we are. We have Max, Monica, Eric, and Francisca in there. So that's how easy it is to write a list into your file. Now you might say, what the heck, I'm writing a completely new file each time, or the text completely new. So I'm deleting everything that I had before. Well, that's because this W stands for write, and it doesn't care about whether there was something before or not. It just deletes everything else and just writes the text that you want to write afterwards. If you want to add text to the existing file, you can just use the A, which stands for append. So let me execute that once again, and once again, and once again. And now let's open up this write.txt file. And as you see, we have them multiple times in here. So in this case, it didn't delete all the text that was there before, but it wrote the text accordingly. So it just appended the text after the already existing text. Welcome back. In this video, we are going to check out the with construct. So far, if I wanted to open a file, I just used this open function and I just said something like read.txt, and as a format or as a type working with it, I just said R. So if I do that, I'm opening a file, and that lets our file open. So it's never being closed. So let me add some more code. Let's just say for line in file, print the line. That's nothing new. We have seen that already. We have this hello world and I'm a new line. Now, if I want to close the file, it's very simple. I just call this file.close function. So file.close. And let me execute that. Now the file is closed, and that is totally valid. If you use that, that's a great approach. You always need to close it up. But then there is a little problem that can come up if you have any errors in your code after opening the file. So let's say I have a method call here or a function call where I just call the world function. Now my file is open, and then my code stops working at that point because world is not defined. So this file.close line, this line 7, is never actually executed. Now I'm having a real issue, because if I have like 100 or 1,000 files open, then this can really bring down my performance, and that's generally not a great approach of how to handle things. So always be careful. Of course, you can try to avoid errors, but sometimes they just happen. For example, you're trying to access a parameter or a document or a number within that document that doesn't exist because somebody changed the format or something like that. Or you're trying to access a website which doesn't exist anymore, or trying to access a aspect of that website, but the website has been completely redone or something like that. Then you will run into errors, and that's not uncommon. So you have to be careful when opening files. But then there is something cool in Python which is called with, and that will help us in those situations. So let's check that out. So instead of saying file equals open, we use with open as file. So now I'm creating this code which says with, so I have this keyword with, and then I'm using the keyword as after the open function call. So I'm calling the open function and I'm saying open it as a file and then do something with it. And then of course I need to indent the for loop if I want to run that for loop within my open file. Now what that will do is it will close the file once it's done with its code block, which means that once this for loop in our case is done, this file will be closed. So let's execute that code real quick, and as you can see, it still works. We still get all the text. But now if I try to access the file from here, so let me just use this for loop here. I'm going to copy the for loop. So if I use this for loop here at the bottom and I'm trying to access that, as you can see, IO operation on closed file. So I'm trying to use an input-output operation onto a closed file. That means that the file is already closed at that point, and that is done by this with as approach, with as file. So with open as file really makes sure that we don't run into these kind of problems that I've just explained earlier on. So whenever you want to use files and open them, that's a good way to go. That's not just the easiest way, but it's also the cleanest way. And it's also the secure way, because now if something goes wrong, our file will be already closed and we can still work with other files and our program doesn't use up too much resources. All right, so see you in the next video where we're going to check out how to open CSV files. Welcome back. In this video, we are going to check out how to open CSV files, and CSV stands for comma separated value. And in this case, it's separated by semicolon and also by line breaks. So we have 3 cities in here, and it's Munich with 1.8 million inhabitants, and then the shortcut of the airport, MUC. Then you have Berlin with 3 million inhabitants. Well, it should be more now, but that's just the value that I gave it. And then Budapest with roughly 2 million, and then the short version of the name is BUD, or that's how the airport is called. So that's generally how you could create a CSV file, or how a CSV file could look like. But then the cool thing is about the CSV file, if you open it up in, for example, Numbers or in Excel, then you get this format here, which is a tabular format. So you have Munich, then you have Berlin, then you have Budapest, and all the data is presented in a very nice way. And that's also pretty useful when you generally want to read files and want to display them in a correct manner. And you get CSV files a lot. Once you work in programming and you get data in a specific format, most of the time you get it as a CSV. So your job will often be to bring it in a specific format that your customer needs it or whatever. So let's have a look at that, because let's say we're not really interested in the name of the airport. We just want to know the city name and also the amount of inhabitants. So let's go ahead and create a new file where we're going to work with that. And let's close the old file, close and hold. So this one will be 0610 read CSV. And now the cool thing is we can use this with approach again, with open, and it's called file.csv as file. So that will just open the file, and I'm just going to use the same approach with this for loop that we had before. For a line in file, just print the line for now. So let's execute that, and as you can see, Munich, Berlin, and Budapest. So it's good if you do that. Now you know that you have the data. Now if you want to strip it, you can always strip that by using the strip function. And as you can see, now we've gotten rid of the unrequired line breaks. And now the cool thing is we can even go ahead and bring it into a different format. We can bring it into a format which is of type list. So we can create 3 lists out of it. And how do we do that? Well, we simply use the split function. So we have used the split function already, and this time we're just saying, okay, split it at the semicolon. So let's print that, and as you can see, now we have this list: Munich, Berlin, and Budapest. Now what if you only want to have Munich and the values here, Berlin and the value of the inhabitants? Well, then we can go ahead and store that as data, for example. Of course, we don't need this additional bracket here. And now let me just print data for now. So as you can see, same as we had before, but now we store it as data. So with this for loop, we go through the data one by one, through line by line, and we create lists out of it. Now the cool thing is we can now use the list as a list. So we can just say, okay, just give me data 0 plus, let's say, a colon, empty space, plus data at the position 1. So if I execute that, you see I only get Munich 18 or 1.8 million. So let me just execute that, and there we are. So now I'm presenting the data in a much easier or nicer way. You could also, of course, go ahead and add something like airport shortcut. Not sure what the right term for that would be. Empty space plus data at position 2. So plus airport shortcut MUC, airport shortcut BER, and here you could even add something like has so and so many inhabitants. Dot. Munich has 1.8 million inhabitants, and I didn't write that correctly, but the general idea gets clear, I think. So there we are. Now you know how to read a CSV file, how to present the data in a specific way. Of course, the CSV files you will usually get are a lot more filled up with loads of data, but that's a cool thing that you can really represent or present it in a very nice way with Numbers or Excel or maybe even Google Drive, and you can use it in Python in a very easy way. Welcome back. In this video, we are going to check out how to skip data and really only display the data that really interests us. And that might be the case for you if you want to filter something, if you want to create a filter on the data. And in our case, it's super little amounts of data. But if you have thousands and thousands of entries, then it's a very different story. and then filtering it might be super useful. So let's say you want to filter everything or every city that has less than 2 million inhabitants or something like that, then you could easily filter that with Python. But first of all, let's check something out. We could of course do it like that. We can say if data 2 is equal to Berlin, BER, or data 2, which means data at the index of 2 is equal to BUD. So if that's the case, then go ahead and print data 2. So data at the index of 2, which will be the shortcut for the airport, right? So let's do that, and as you can see, you get Berlin and Budapest, but you don't get the other cities. So print data in here, you don't get the other cities. And that's what you of course can do, but there are other ways. For example, if we want to go ahead and only display those cities with more than 2 million inhabitants. So I'm gonna add 2 million in here, and then I'm gonna print the data only of those cities. If I try to execute that, then I'm getting an error. It says not supported between instances of str and int. So greater equal only works for integers, so it doesn't work for strings, as you can see. So what I would need to do, of course, is to bring it into the right format. So let's say I have something like 2000 or 2,000,001, and I have this comparison of 2 million here. That will give me an error, same error. So what I need to do is I need to make an integer out of this string. So if I do that, then I get true as a return. So that's a great thing. So that's exactly what we also need to do here. So we need to make an integer out of this data, because the data in our array is still going to be strings, right? So if we do that, now we can go ahead and only display the cities with at least 2 million inhabitants, and Munich is not in it. Now that's one way of using an if statement, but there is an even cooler way. So let's say I want to print data, but I want to print it again of all the cities who have more than 2 million inhabitants. Then I could of course use this way as well, where I say all the cities that are less than 2 million in terms of inhabitants should just be continued, which means it should just skip those. So if we do that, we still get the same data, but we have a slightly different type of code here. So what happens here is that this print data is only executed if the value is below 2 million, if the value is higher than 2 million. Because if it is below 2 million, then this print data is just skipped, because we simply continue, which means we go to the next iteration of our for loop, which in this case just means we go to the next line of data in our file. Now you could of course go ahead and even extend that. So let's say we want to have another if statement where we check, okay, I don't want to have cities which are called BUD, or which airports are called BUD, and I'm going to continue here as well. So if I execute that, as you can see, only Berlin is left, because only Berlin has more than 2 million inhabitants and is not called BUD in our list of cities. So now you have seen how you can very easily create your own filters and how you can filter your data. In our case, really the data is very limited, but if you had thousands of entries here, that would make a lot of sense. And we are going to use these kind of approaches later on as well, so make sure that you try to figure things out and understand that. You can even extend the list, or you can just download a different CSV file and try to filter it yourself just to get a little bit of practice. All right, so in the next video, we are going to check out how to draw graphics. So see you there. Welcome back. In this video, I would like to show you how to draw graphics in Python. And cool thing is you can simply import modules that were developed by somebody else, and then you just can go ahead and use those functionalities. And in our case, we are going to use the one to draw graphics, as you can see on this little cell here. And I'm going to talk to you about the different things you need to consider and look into in order to understand what's going on, because we are going to use that in order to show birth statistics in the next example. So we're going to combine drawing graphics with reading stuff from a CSV file. So that's going to be pretty extensive, but it's actually not that difficult. So what we need for that is to first of all embed and configure matplotlib module. And as you can see here, first of all, I need to use this %mat.lib inline. What that line does, it allows us to draw or see the drawing straight within Jupyter Notebooks in the next line without having to open up a new file or without having to open up a new screen for that or tab. So that's the cool thing about this line. So that's what allows us to use this at the bottom here. And then what allows us to even use this plot and this show function or method is this module here. And this module is called matplotlib or mathematical plot library. That's how you could write it out. .py, so Python plot. And we rename that as a PLT or as PLT, so we don't need to write the whole name when using its functionality. So we can just say PLT dot and then use its functionality. And we have used other modules already. We have used a random module where we just created a random number. And that is a very similar thing. So we're just using functionality that was developed by somebody else so that we can just use it without having to develop all the lines of code ourselves. And then step 2 is to draw your graphic. And in this case, I have my x's and my y's. So my x coordinates and my y coordinates. And they are connected to each other. So this xs is my xs0 is my first x coordinate. The ys0 is my first y coordinate. So as you can see here, 1, 4 is the coordinate of this dot here, of this starting point, and that's at x1 and y4. Then the next one is 2 and 7, which means the x coordinate is 2 and the y coordinate is 7. And the third one is 5, 5. So we have the x coordinate of 5 and the y coordinate of 5 as well. Now you can of course play around with those values. If I would say something like y as 1, let's check that out. And as you can see, I'm getting this error. PLT is not defined, so we need to execute this line before that. So let me execute that, and now I can execute it. And as you can see, it's drawing it straight away. And now it looks a little different because it only displays the area that is required. So it starts at 1 and doesn't start at 0 as you would usually expect in a graph. But that's how we can generally graph or use graphs and display stuff in a graph. And we're going to use that in order to, well, check out birth statistics. So see you in the next video. Welcome back. In this video, we are going to do something pretty cool because we're going to draw graphics based on birth statistics. And therefore I have this file names.csv, which is 155 megabytes large. And I'm not going to open it up because it's a big file. There are plenty of information in there about the names, the year, the state, and their gender, and how often that name was given in a specific state. And by state, I mean the states in the US. So this contains the first names, all the first names pretty much of American citizens, and we get plenty of data in there. So if you want to check it out, you can open it up and you'll find the data in there. And we are going to use that data in order to display it in a specific format. And therefore we will create a little file. So let's go ahead and create a new Jupyter notebook, which will take care of displaying things correctly. And with the knowledge that you have so far, or have acquired so far, you can already do that, and that's a pretty cool thing. So let's go ahead and call this 15 birth statistics graphic. So the first thing we need to do is to open this file. So in order to open it, we use this with keyword, then open, or the open function. And here we need to give it the directory of that file. And I have this specific file that I want to check, this names.csv, in my data folder. So currently at this point, this file here is within my course material. So the root folder is pretty much the course material. So if I want to access a folder within the course material, as you can see here, there's this data. If I want to access this folder, and there in this file, I need to do the following. I need to use .. / then the name of the folder / and then the name of the file. And in my case, the file is called names.csv. And then I need to tell which type of opening I want to do. I want to read something as file. Now I'm going to use a counter for now because I don't want to read the whole file all the time. I'm just going to keep it simple. I'm going to use a counter, and I'm going to go through the whole file, or through the file up to the point where the counter has a specific value. So I'm just going to say counter is equal counter plus 1, and then go ahead and print the line for me. But please only do so for, let's say, the first 4 lines. So as long as counter is greater equal 4, we want to break. So if I execute that, you see I get an ID, the name, year, gender, state, and count. And the count is the amount of people who were called Mary 1910 who were female in the state of Alaska. So you can see the ID is just a unique identifier. This is the first name, this is the year, the gender, the state, and the amount of people who were named that way in that particular year and in that particular state. So plenty of data. And that's just the beginning. So that's generally the structure that we have here. And if we would like to have a different structure, we can do that. You know how to do it, right? You know how to display it correctly. We need to split and those kind of things. And as you see, they are all separated by comma. So what we simply need to do is here strip the line. So strip it first so that we don't have empty spots in there, and then split it at the comma. And that's what I'm gonna do here. So now let me do that again. As you can see now, I'm getting this list type of thing. And with this list, that's how I can work with it. So I can just say, okay, list at the first spot is the ID, or the index 0 is ID, index 1 is name, index year is, or index 2 is year, and so forth. So let's assume I want to check for a specific name, and I want to know how often a specific name was given in a specific year or in a specific state. So let's go ahead and create some variables here. Let's say I want to have the name Anna. I want the gender to be F, standing for female. And I want the state to be California. So let's say I'm interested in California, and I want to know how many Annas were named in that state, or how many people were named Anna in that state. Then I can do the following. So what I'm gonna do is I'm gonna split the lines accordingly. So let me take this line here and create a variable for it. I'm gonna call it line split. Is going to be this one here. And now I can check something. So I'm going to create an if statement in here where I will check if line split at the position 1. What is position 1? I hope you know, it's the name. So if it's the name, and by name I mean our variable name. So if it's Anna, and on top line underscore split at position 3 is the gender that we have prepared. So female and line underscore split at the position 4, or is it 5? No, it's actually 4, is going to be the state. And what is the state? Well, the state is our state that we have created here, so California. So if I now print the line split on the console and then break out of it, I should be good to go. Then I will not need this line of code anymore, or this counter here. So let's just run it, and as you can see, there is an Anna at the position 356,049, so that's her ID. In 1910, she was female in California, and there were 51 people called Anna in that year in California. So that's how I can generally get the data. So now I have this kind of data, and I would like to have the data displayed for every year, not just for 1 year, but for every year, because here we are breaking currently, and we could go ahead and display all the Annas for all the years. So we can go through all the years. In this case, we have 1910, but we could go all the way up to, I'm not sure, 2000 something. Not sure how much data we have in there. And we could display that correctly in a graph. So you might remember from the last video how we used graphs, and it's the same thing that we're going to do in here. So let's go ahead and prepare the code in order to display the graph accordingly. Therefore, we need X values and Y values. So X's, which will be a list, and Y's, which will also be a list. And I'm going to keep them empty for now. And within my while and for loop, within my for loop, I would like to fill them up. And how do I fill those two up? Well, I'm simply taking the values. So I'm going to append values to my list, and it's going to be line split, and which position is interesting, which could be the X position that is interesting for us. And I'd say it's the year. So the X should be the year. So 0, 1, 2. So the index 2 is interesting for us in terms of the X value. And what would be interesting on the Y scale? Well, that would be the amount of people. So let's say Y's, append a line underscore split. And what is this value here? And actually I had this character incorrectly. So this is index 5. 0, 1, 2, 3, 4, and 5. So this is what we want to have, the number 5. Now let's display them. Let's just print all the X's, print X's, and print Y's. And if we execute that, we only get one entry, right? We only get this 1910 and 51. And that is because currently we are only breaking straight away. We want to only have one value. Now we can say, all right, we don't want to break out after one value. We would like to have all the values. So let's execute that. And as you can see, these are the values that we're getting. So I'm getting all the Annas, all the years for Annas in California up to the year 2014. And here, these are the values that are of interest for us. So here are the years, 1910 to 1914. And here are the actual values. And now we can go ahead and display them in a graph. So we don't need to print this thing here anymore. And actually we don't need to print it at all. But what we would like to have is actually to display them in a graph. And you might recall from the last video what we had. So we needed to import matplotlib inline and import matplotlib pyplot as plt. So I'm going to do that. And then on top of that, I'm going to use these lines of codes here. So I'm just gonna use plt.plot with the x's and y's and plt.show in order to display it. So now let's run the code. Now, if we execute that, we get this ugly graph that doesn't seem to be quite right. And we have also these very weird statements here. So what is important here is that we append currently the line split 2, which always is a string, and the same goes for line split 5. If you remember how the data was, it was always a string connected. And you can see that here as well, it's a string, which is indicated by the apostrophe. So we need to make an integer out of it, and that counts for both of them. So let's make ints out of them and execute that line again, or that cell, and afterwards execute this cell as well. So once we have all the data, as you can see, this is what we get. So we have the values from 1910 to 2014, and that's the distribution of Annas, or the name Anna, given in the year of, or in those years in the state of California. And now let's see how many people were called Frank. So the gender will not be female, now it will be male. Let's run that code and wait until it's displayed. And there we are, and once it's displayed, let's run the code here, and as you can see, that's how often Frank was given. So in the 1960s there were many Franks, and then by now it's a lot less. So you see the numbers went from, let's say, roughly 50 up to 1,200, and then it went all the way down. Now you can also check out Jose. Let's see how many people were called Jose. And now you can generally play around with the values, and you have your own little tool where you can see this is how often Jose was called. Hey man, in the 90s there were so many Joses in California, but then it went all the way down to a value of 1,000 roughly. So as you can see, in the 1910s and 20s there weren't many Joses in California, but then in the 70s they really picked up. All right, so once again, great job. You've gotten so far, and you've already seen quite some stuff that you already can build with just as little time invested, and just imagine what else you will learn throughout the course. All right, so I hope you liked this video, and in the next one we're gonna go and check some more examples on birth statistics, or you get a little exercise on birth statistics. So see you there. Welcome back. Now that you've seen how you can create great graphs based on loads of data, there is a little exercise for you. Find out how often the name Max was given as a male first name in California between 1950 and 2000, both inclusive. So 1950 and 2000 should be included. Use the provided CSV file, data or /data/names CSV. And before you go ahead and go into this exercise, there is something that I would like to talk to you about, which should help you to be successful in this exercise, because there are quite some little details which can really be tough to get around if you are not really proficient with Python. And the first problem or error that you could run into is the following. So let's say you get the value of the year. So you want to, for example, check 1975. And now if you want to print something like n lower 1990. So let's just see if this year, 1975, was before 1990. And if I run that, you see not supported between instances of str and int. So you have to be super careful here that you make an integer out of this n. And in this case, it's just called n, but in your case, it would be an entry, or the name that you give the list element of your whole list, right? And here, that's gonna work. So this approach works. So if you get the data, and you don't forget it, you get the data as a string, so you need to convert it accordingly. But just converting it is not gonna be enough, because let's have a look at the years. So let's say we have the years and we store them somehow. Now the thing is, you get them as strings, but the first entry you get is year, or even with a capital Y. So you get the year, then you get, let's say 1990, then 1992, and so forth. All right. So if you try to run something like this for loop here, for year in years, and the first one print year, that would be easy, right? So if you run that, all is good. But if you do something like giving the year as an actual integer, so int year, then you get an error, because as you can see, invalid literal for int with base 10 year. So we're trying to make a word into an integer, and that doesn't work. So year cannot be translated into an integer. That's why when running through this for loop, there is something that you can do, and you can simply check if year is equal the literal word year, and if that's the case, then just continue. So please skip that and go to the next step in the list. So if we run that, now we're good to go. So now we see the numbers printed correctly. All right, so these were just some little hints, and I wish you all the best trying to figure this out. So go ahead and find out how many maxes were there in this period of time. And if it takes you way too long, so if you sit there for an hour or longer, then you might want to skip that and just check out how the answer is, but at least give it some time and try to figure it out, because while running exercises, while trying to solve exercises and get right into programming, that's when you learn. That's when you really learn, because just watching videos is not going to be enough. Some of it sticks, but the rest you will have forgotten just after you finish the video. So always try to build stuff yourself. Just try to run through the exercises all on your own without any additional help. All right, so in the next quiz, you'll see a little check for your solution. So see you there. All right, welcome back. I hope you managed to solve this exercise. And if you didn't, no worries, then you can simply watch this video. Otherwise, you can of course skip it. If you feel like you already managed to do it and you don't need any additional advice, then just skip this video. All right, so first of all, let's go ahead and open the file. So we need with open in order to open the file. And as you know, // and then the directory. So I'm going to use data names.csv. And then I need to read them, so I'm going to use R as the second argument. And this is going to be a file, so as file. And now I can go ahead and read through all the lines. And I'm going to say line in file. And now I'm going to have them as split version. So I know splitted is probably not correct English, but that's a good name for it. Splitted is line.strip. So we are taking this line and we're stripping it, so getting rid of all the line breaks and stuff like that. And then we split it at which point? Well, at the comma. Because if you remember, the data was displayed like this. So we had the name, or actually the ID, then comma, then we had the name, comma, then I think it was the year or something like that. So this was the structure, and there was even no empty space afterwards. So it was just a comma. So it was given like that. The data was roughly given like that. So that's why we split it at the comma. So now this here is a list, which contains the entry of a particular line that we're currently looking at. And then we check if that list split it at point 2 is year, because we are looking at the year, then just continue, because I don't want to do anything in that case. I want to continue. And why is that? Well, because we can't handle year. We cannot convert that into an actual number. That's why we split it. And that's back to the example that I've given you in the hints for this challenge. All right, so I'm just splitting, and then I'm jumping over the year itself. And afterwards, I can store the year in a variable. And what will be that? Will that be? That will be splitted 2 as an integer. So 2 is our year in our data, and now we are splitting it, and we're actually getting it in as an integer and storing it in that particular variable. All right, so now let's actually print splitted first and then break, because I don't want this to be happening 1,000 times. Okay, so now you see it again. So this is the structure. We have a string, then another string, another string, another string, another string. So this is how we currently have the data, and now we split it up and we want to have the year. So we get the year, so the year is this value here, and now we need to run an if statement. So now we need to check if split it at the position 1 is equal to max, because that was the name that we were looking at, right? And the year is greater equal 1950, and the year is less than equal 2000. And also the person is male. So as you probably remember, the challenge was that the person has to be male. So we say is M. As you can see, this is a female here, and 0, 1, 2, and 3. So the index is 3. That's why we split it at the index of 3. Should be male. And then finally, the person has to be in California. So I copied the exercise in here again. So find out how often the name Max was given as a male first name in California between 1950 and 2000, both inclusive. So we have this guy Max, who was born between 1950 and 2000, and he's male, and then finally he lives in California. So we have and split it at position 4 is going to be CA, standing for California. And what shall happen if we have this situation where this guy is actually found? So we have found one guy who is called Max. Well, for now, we can simply add that as an occurrence. So we want to have some kind of a counter, because this is gonna be true each time that all of these conditions are true, right? So whatever we add afterwards will be printed in here, or will be executed in here in line 9. So I'm going to create a new variable called occurrences. I'm gonna call it 0. Or I'm gonna assign it with 0. So now in here I can say occurrences plus equal 1. And finally, after all is done, after this whole loop and stuff is done, I can print the occurrences. And if I do that, it takes a little while, it goes through the whole file, and once it's done, it should print the occurrences on the screen. And there we are. In my case, it says 51. Now, what is this 51? Well, you could argue, okay, this is the amount of maxes, but that's not true. That's just the amount of years, because in every single year we had a max. That's what this 51 pretty much says, because if we look at it, we have names, or with years from 1950 to 2000, which is 51 years, and that's why we get this 51 here. But in fact, we don't just need the occurrences, but we need to have the old occurrences, which we have with this plus equal. So we could also say something like occurrences is equal to occurrences plus int split it at the 5th spot. And the 5th is the amount of maxes that we had. All right, so let's run it again. And it will take a little while, and then we'll see how many maxes were in California between 1950 and 2000, or were named Max, how many people. And there we are, 6,385 is the amount of people named Max in that period of time in California. And by naming, I mean they were named after being born, and not how many Maxes lived there during that time. All right, I hope you figured this out and you could solve this exercise by yourself. And now you can of course go ahead and search for whoever you want, and in whichever state you want, in whichever gender you want, and so forth. And you already know how to do that. So you know how to filter by year, filter by name, and so forth. Welcome back. I hope you read through the exercise, and in this video I would like to give you some solution tips. And first of all, I will create a list for that, and it's going to contain my good old friends Max, Lisa. Well, this time it's Lisa, it's not the Monica girl, and it's Eva. All right, so we have this list of students, and what if you decide to change one of the entries? So let's say I don't want to have Lisa in here, I want to have Lisa 2, for example. All right, so how do you do that? You can of course go ahead and say students at the index of 1 is going to be Lisa 2. And now let's print out this students list, print students. As you can see now, Lisa was changed. So it's Lisa 2 now. So we have a new Lisa in our list. Now, what you cannot do is the following. So you cannot create a for loop saying student in students, where you simply check if student is equal Lisa, then change that student to Lisa 2. So let's say I do that. Now let's print it, and as you can see, it was not changed. Why is that? Well, that's because the student here is actually just a copy of the entries in our students list. So we're not actually changing the list itself, we are just changing the student copy here of the list. So if you want to make sure that you actually change the Lisa itself, then you need to use a different approach. And it's a little more complex, but it's not too complex. So let's have a look at that. What we need therefore is the length of our students. So let's just print len students onto the console, and as you can see, there are 4 students within our students list. Now we need to know at which point we are for the for loop, which student we are currently looking at, in order to actually change the Lisa. So how do we do that? Well, let's go through a loop now, which is just going to be I int in range 0, and here I'm going to take len students. So this is just going to go through a for loop, which is still going to just have 4 iterations, right? So it's not different because it's just as long, it's just going to repeat as often as this len students is, and as you have seen earlier, it's 4. Now in here I can check students at the position I, is that student called Lisa? Because if that's the case, then please go ahead and say something like students I is now going to be Lisa 2. And if we execute the code now, as you can see, Lisa was changed to Lisa 2. So this time it worked out. And why is that? Well, because this time we are actually manipulating the list itself and not just the copy of the entry in the list. And what's important here we're using double equal, which is a comparison operator. And here we are using a single equal, which sets a value. So this is really important. Double equal compares, one equal sets a value. All right, and I hope this will help you to solve the challenge. And good luck with the challenge, and see you in the next video. Welcome back to the solution of the final exercise about functions, and I hope you ran through the exercises and could solve it yourself. And if not, then just follow along in this video. I'm going to explain every step along the way. So first of all, the math magician wants to convert her online shop to functions. So there's a lot of work waiting for you. And complete the function list sum, to which a list with the prices is passed as an argument. The function should then output the sum of the numbers from the list. So here we have this list card prices, and these are just prices within a card. And now we want to know the whole value. So how much does the person have to pay once leaving the shop, or once wanting to leave the shop? And here we need to add our own code. So we have this list sum L, and what we need to have is a total. So we need to know what the total is. So let's say we start a total with 0. And then we don't need that either. Then we need to increase whatever is in the list. So we have for I in L, and L standing for list. And what is it that we want to do here? Total is equal to total plus I. And then we simply print the total. So if you do that, then you have this function list sum, which will take a list and it will have a total value of 0. So it starts with a total value of 0, and then it uses this for loop to go through the whole list. So for every single value in the list, it adds that value to the total, and the total is the old total plus the new value. So in the first iteration of this for loop, it's going to be 0 plus 20. Then it's going to be 20 plus 3.5. Then 23.5 plus 6.49, and so forth, until it's totally done, and then it just prints it on the console. So here, let's sum card, or this list sum function is called, and it's given a list, the list card prices, and the card price should be 63.95. And now let's run it, and as you can see, we get this result. So we added up all the different values within our card. All right, so then the next exercise, write a function that creates a price table for an item. Now the math magician wants a function to which she can pass an item name and the sales price. From this, the function has to print a list of sum of 1, 2, 3, up to 10 unit prices. Each element in the list should look like this: number, X, article, price. You're just wondering about the math magician's demands for a short time, and then you solve the problem very quickly. All right, so let's just do that. Let's check out answer B. And for that, we need to return something. As you can see, this price list or prices list function takes a name and a price, and it returns a list of prices. So let's just check that out. This is where your code goes. Replace the next line with your code. All right, let's just do that. So first we need to create a list, and I'm just going to call it L, and it's going to be empty. And then we go through the range. And what is the range? Well, it's just 1 to 11, or it could be 0 to 10, depending on what you want. So, which means we are going to do this 10 times. And what is it that we want to do 10 times? Well, we want to append something to that list. And we want to append the value itself, I. And by the way, if you would use 0, you would run through it 10 times, but then you have another issue here. Because I would be 0, 1, 2, 3, and so forth. And what we want is 1, 2, 3, and so forth without the 0. So that's why we start at 1 and not at 0. So here we just say I plus the X, which is the multiplier. So number, amount of values, number, multiplied articles price. So the price of the article. So we have the X, then we have the name, and then with a colon, empty space, we have the price multiplied with I. Now there is a problem with I, because I is a value, a number, the price is a number, and what we want to have is strings. So we need to make a string out of this price multiplied with I, and the same goes for the I itself, because otherwise we get an error here. So if we do that, now we want to return the list itself. So what we did with this function, we simply went ahead and created this big list of cookies in this example, and we gave their values in terms of how much the amounts would cost. So one cookie or one set of cookies costs 79 pence, then 2 sets of cookies costs 158, and so forth. So if we now run that code, I'm still getting an error, and that is because I forgot a plus here. So now let's run that again. And now we're good to go. So now this is a string plus another string plus the name, which is also a string. As you can see, cookie is a string plus a string plus another string. So now we're good to go. And here you can see the prices. So one cookie is 79 pence. Let's look at 5 cookies. They are 3.95, and 8 cookies are 6.32, and so forth. All right, so now let's go to the next point. Write a function that fills the list with the articles. From now on, a function should also put the goods on the virtual shelves. For example, put them in the first still open or still empty position in the shelves list. This article should be passed to the function addShelf as argument. The function then updates the shelf list and the new article was passed in the first empty shelf. So there we are. We have this shelf and there's a magic mirror, then it's empty, then it's cookie, then it's a book with magic tricks, and then it's empty. So here comes your code. You can access the variable shelf directly from within the function. This does not have to be passed as a parameter because it exists outside of a function. So it must not be passed as an argument. If you want to be super careful here, or super precise, outside of the function already. So let's go ahead and check it out. So what do we need to do? First of all, I would like to go through the whole shelf. So I want to create a little for loop which goes through the shelf. And how I'm gonna do it is the following way, and that's why we had this video in the beforegoing video where I explained to you that you cannot simply change the shelf without a specific approach, and that's the specific approach that I'm going to use. For I in range, and here I start at 0 and then I take the length of the shelf because I want to go through the whole shelf, and that's how I do it. So with this for loop I go through the whole shelf and I always know at which position, at which index in the shelf I currently am, because I is going to be 0 for the first one, then 1 for the second, 2 for the third, and so forth. So this for loop, in there I want to check if the shelf at that current position that we're looking at, which is I, is empty. Because I want to set stuff or position stuff at the point where it's empty. So then I need to put my article at that point. So I'm just gonna say shelf I is going to be the article that was given. And then I break out of it, because I don't need to go any further in the for loop, because otherwise I, let's say, add an article here like the Rubik's Cube, and it would go here and there at the same time. But now it's just going to go at the very first entry, which is empty, and that will be the first part of the shelf where it's empty. Okay, so we don't need to print that here anymore, but now we can go ahead and execute the code. And as you can see, we have magic mirror, Rubik's Cube, cookie, book with magic tricks, and empty. Now you could of course say, all right, let's add something else in the shelf. So let's add something else in the shelf, like a skateboard, because she's a really good skater as well, this little lady, math magician. So now let's run that. And as you can see, magic mirror, Rubik's Cube, cookie, book with magic tricks, and skateboard. All right. So I hope you could figure this out and manage to solve all the problems that we have here. And in the next chapter, we are going to look at lists in more detail, because so far we have used lists, but there is a lot more to know about lists. So see you in the next chapter. Welcome to the lists chapter. In this chapter, we are going to talk about lists, but also dictionaries and tuples. But first of all, let's have a look at what we are still lacking with lists. So the problem is we already know lists, at least that's what you could say, because we have worked with lists quite a bit. But for example, how do we get the first 10 participants, 10 entries of a list, or the last 10? Or how do we get the first character of each element in the list, or whatever you can think of according lists? So we have done some things, but there is still plenty to learn, and we are going to use something called slicing, list slicing. And this is a functionality that will allow us to do these kind of things, so to slice a list into multiple pieces. And I'd say let's get started and look into this. All right, so let's check out some more functionalities of lists that we haven't touched yet. And therefore I need to create a list, and I'm gonna create the students list that we were using quite a bit already. And it contains Max, then Monica, and we had Eric in there, and finally Francisca. So until that point, nothing new. But then Let's say we want to get rid of the last student. Well, we can just do that with the pop function. And you have seen the pop function or pop method already. So we can do something like students.pop. That will get rid of Francisca in this case, but at the same time, it will return Francisca to this variable called last student. And now let's just print last student. And let's print our students list, and you will see Francisca now is within last student, but she's not within the list anymore. So that's something that we have seen already. I just wanted to quickly show you that again. Now there's another thing that we can do is, in order to add an element to our list, we could use append, as you have seen before, but we also can add lists to each other. So I could just say, all right, add Frank, or add the list containing one element called Frank to the list. And now let's just print students once again. And as you can see, Max, Monica, Eric, Francisca, and Frank are within the list now. Now, in order to delete a student, we saw how we can use pop in order to get rid of the last element in the list. But now, what if we want to get rid of a specific element in the list based on its index? Then we can use the del keyword, del, in order to delete an element. And then we just need to write the name of the list and then the index that we want to get rid of. Let's say we want to get rid of index 3. And now let's print students once again. And as you can see, Francisca, who was at index 3, is not in the list anymore. So that's how easy it is to get rid of an element. But then, what if we want to get rid of an element based on its entry, based on the name, for example? So let's say we want to get rid of Monica. Well, then we can use the remove method. So students.remove, and here we're just gonna say Monica. And now if we print students once again, we will see Monica is not in the list anymore. So we simply gotten rid of Monica with the remove method. All right, so that was it for now. And in the next video, we are going to look at slicing. So practice around with this a little bit, delete some elements, add some new elements, create an additional list, and add the list to another list, and so forth, just to get a little feeling for that. And otherwise, see you in the next video. Welcome back. In this video, we are going to look at slicing, and specifically at list slicing, and later on at string slicing as well. That's something that we haven't touched yet, which is a super cool feature, and it allows us to do pretty cool stuff. So let's go ahead and start with slicing the students list. Before we do that, there is one thing that I would like to show you though. I have this list that we have seen multiple times, and I'm just gonna print students as is now. So as you can see, Max, Monica, Eric, and Francisca. And now what you can do is you can also, of course, access one of the entries. So you can just say, okay, 1, and 1 will be Monica. But what if you want to access the last element? So let's say Francisca. Well, if you want to access the last element, instead of calculating what the index would be, so 0, 1, 2, 3, so you could of course enter 3, but you can also enter -1. So instead of entering 3, I'm going to use -1, and what that will do is it will give me the last element of the list. So let's see if that's true. If I change the list element and I'm going to add ABC, as you can see now it gives me ABC, so it doesn't give me Francisca anymore. So if you want to have the last element, you can simply use -1. If you want to have the second last element, well, probably you guessed it, you can enter -2. So now, as you can see, now I'm getting Francisca. So now you simply calculate from the back, but you don't start at 0, but you start at -1. So -1, -2, -3, -4 for Monica, and so forth. So that is something that is important for the next point, which is a list slicing. So let's say we look at list slicing. I'm going to create a new markdown here, list slicing. And I'm going to use code here, of course. Now, let's print students again, but this time let's use list slicing. And what is that? Well, you can slice a list and create a different list for a short period of time. For example, like here, I'm just creating it for this particular line of code where I would, for example, only print out the elements from the second or from index 2 to index 4. So let me just do that. So as you can see, I only get Eric and Franziska. That means I'm getting the index 2 entry and index 3 entry. 4 is not included. So the second value here after the colon is not included. So if I'd say, give me 2 up to 3, it will only give me Eric because 3 is exclusive. That's why Franziska would not be part of it anymore. So now I have this little list, and I could of course create another list from it. Less underscore students could be my students from 1 to 3, for example. And now let's print less students, print less underscore students. And as you can see, this would be Monica and Eric. So it starts at index 1 and it gives me index 2 as well, because 3 exclusive means 2 is still in there. Okay, so that's called list slicing. Now you can do what you have done here, or what we have done here. You can do that with list slicing as well. So let's say I want to have students from 0 to -1. What will that give me? Well, it'll give me everything except for the last element in the list. So you can easily slice a list by, well, slice away the last piece of a list by using this approach here. Okay, or if you want to have everything in the list but the last 3, then you could go ahead and say, all right, -3. So it will only give me in this case, the first 2 elements, and the last 3 will not be printed out or not be executed or returned pretty much. All right, and if you are using 0 here, you can also just skip the 0. So you can just use empty, then colon, -3, or whatever the second value is. So if I do that, it's the same result, as you can see. All right, so that's what you can do with slicing. Now, a pretty cool thing that you also can do with slicing is use this approach with strings. So I'm gonna call that slicing works with strings, and let's check it out. So let's write something like hello world. So let's just print hello world on the console. But now I'm going to use slicing. So I'm gonna use these square brackets, and I'm gonna say give me 0 to 5. So give me the first 5 characters. So this will just give me the first 5 characters, and it just prints out hello. Now if I only want to have the last 4 characters, or maybe last 5 characters, I can just enter -5 colon, and that will give me world. So as you can see, start at -5 and go towards the end. So go towards the end of the string, because if I add something else in here, as you can see, I get the last 5 characters, and then it just ends, right? Because if I get the last 5, then there is no additional ending, right? Okay, so that's what we can do with list slicing and with string slicing. Now you can of course also use the same approach where you just say, okay, from 1 to 3, and that will give me L. And that will be the L from here. The H is skipped because we enter 1, so we start at index 1, and then we end at index 3. So this second L is not included anymore. All right, so that was list slicing. In the next lecture, there will be a little quiz, and afterwards, of course, the solution for the quiz as well. So see you there. Welcome to the solution for the quiz lists. So let's start with the first question. Which letter outputs the following program? And as you can see, print hello world, and then slicing -2, or in square brackets -2. What -2 does is it says I would like to only take the second last letter. So if there was -1, we would get D. If there is -2, we get L. So the correct answer here is B. So the right solution, B. If you use the square brackets and then a number in here, then you tell the string here that you only want to have a particular character, because we're not using colon here. There's no colon, so we're not slicing it in parts. We're just getting one particular character here. And the one that we get is minus 2. So we just have to look at the string from the back or from the end. So D is -1 and L is -2, R would be -3, and so forth. Then question number 2. What does the following program output? Print John Doe -3 colon nothing. So this -3 means that it starts at -3, and -3 is the third last character. So if we look at the string John Doe, then it starts as this D, and after the colon there's nothing else left. So this means that we will get the rest of the string. So we start at -3 and we get the rest of the string. So what we get is Doe. So the correct answer here will be D, as we get Doe from John Doe. So solution is D. Now let's look at question number 3. What does the following program output? Now we have it the other way around. So before the colon, there's nothing. So we start at 0, which means we start at the beginning. And then it says up to the point of -3 not included. So the -3 is not included, so we don't get the third last character in there, which means Doe is not going to be, or D is not going to be part. So we only get John. So the answer is C here. All right, so correct solution is going to be C. Now let's have a look at question number 4. What does the following program output? We have hello world starting at the 6th character and going until the last, but not including. So colon -1 means take the last one, but then exclude that. So it would give us, why do I say world here? Well, the answer is world, which is B. And that is because if we look at the 6th or 6, we mean the 6th index, which means the 6th character, and starting to count at 0. So 0, 1, 2, 3, 4. The empty space is 5 and W is 6. So we start at W. And then we go all the way to -1 excluded. And -1 is this exclamation mark here. So the exclamation mark is excluded, which means we have the whole world word that we're taking. So the answer is B, world. All right. So I hope you could follow along, and I hope you understand the concept of slicing and also of playing around with strings. And in the next video, we're going to check out list comprehension. So see you there. Welcome back. In this video, we are going to check out list comprehensions, and you will learn generally what list comprehensions are, how it makes it easier to convert lists into a new list, and we'll use list comprehension to make it easier to draw a graphic. And let's get started by creating a very basic list. So I'm going to add a cell in here with some values: 1, 2, 3, 4, 5, 6, 7, and 8. That's it, simple list. Now, what if I would like to have y values, which simply multiply the x values with themselves? So let's say the first y value should be 1 times 1, the second y value should be 2 times 2, 3 times 3, 4 times 4, and so forth. So how would I do that? Well, you can of course go ahead and use the following approach, which we had already used in the past. For x in x's, so I'm just saying, okay, for every x value in my x's list, in this list, do the following. Append to my ys list and multiply x with x. And then let's just print both out. Let's print x's and y's. So print y's. So let's do that, and as you can see, that worked totally fine. So we have 1, 2, 3, 4, and so forth, and then we have the values multiplied with themselves here in the y's. So that by itself is totally fine, but as this is a approach that is used often, not just multiplying with itself, but using something where you want to manipulate a list and use a different list which has the same values or slightly different values or adjusted values based on the other list. then you can use something called list comprehension. So let's just comment those lines out here, because we are going to use a different approach to do that. So I'm gonna say ys is equal to x multiplied with x for x in xs. And that will give me the same result. So if I execute the code, as you can see, it gives me the same result. So what I'm doing here is using a list comprehension. And that means that I'm just saying that do something with some values for the other list. So for every single element in another list. So you could also say, or let's present it in a different manner, where we have element, it will be multiplied with elements. So every single element of that list, or every single item of that list, will be multiplied with itself. And then for every single item in the XS list. So within this list, do this, please. So that's how you could otherwise display it. But it's pretty much the same thing, right? It's going to do the exact same thing. It doesn't need to be called X. It could be called anything you want. But as you can see, you can simply make this 3-liner into a 1-liner. All right, so now let's assume we have a list which is not containing numbers, but strings. So we have our good old Max again, our Monica, then we have Eric, and we have Francisca. So our good old students. And then we go through the list, and we would like to have the length of every single element in that list. So of course we can go ahead and do it like that. For student in students, go ahead and add to this length list, or append to this length list, len student, and then just print it. So let's just print lengths, print lengths, and I have a typo here, and as you can see, I'm straight away getting an error. 3649. So Max is 3 the characters, Monica is 6 characters, Eric 4, and Francisca has a long name, 9 characters in her name. So that's generally, of course, what you can do. And now for you as a little challenge, you can of course try to use this approach and pause the video. All right, I hope you paused it if you would like or wanted to use this approach. So I'm gonna comment that out again, and I'm gonna use the approach that we've seen at the top, which is this list comprehension approach. So I'm gonna say something like lengths is equal to, and now again in brackets, so I'm creating a list, I'm saying len student for student in students. So for every single student in my students list, I would like to go ahead and get the length of it and position that into the list. So if we execute that again, as you can see, we're getting the same result. But that's not it. There is something that makes even more sense, or where it makes even more sense to use list comprehension, and that's when we are using graphs. So we have used graphs in the past, so let's go ahead and see why that makes sense. So in order to draw, I need the percentage sign, then matplotlib inline. That will allow me to draw inline, so draw within this page. And then I need to import the module, import matplotlib.pyplot as plt. And you don't need to memorize this line of code. You can simply always check it up if you ever need it. All right, so now we need a bunch of x's and a bunch of y's in order to print them. So as you can remember, we had this plt plot method where we needed to enter the x's and y's. Currently we have x's and y's, so we can even go ahead and do that already. So plt.show, and let's execute that, and as you can see, this is how the function looks. But what you also can see is that it's not precise. So if we scroll in, let me zoom in a little bit. As you can see here, it's not a perfect looking graph, I'd say. There are these imperfections. So if I go back to my standard zoom, so let's assume I would like to store all values from point 1 or 0.0 up to 9.9 in a list. So it's 100 values in total. Then I could of course go ahead and do something like creating a list, and then for x in range 0 to 100, go ahead and append x divided by 10. So what that will do is it will go through from 0 to 100, and it will add 0.0, 0.1, 0.2, 0.3, and so forth to this list. So if we use this approach, and I'm gonna comment those two out for now. I'm gonna execute a print statement in here, print x's. As you can see, that's what I'm getting. All right, so now let's say we would like to use list comprehension in order to do that. Well, then we can just say x divided by 10 for x in range 0 to 100. And that will give me the exact same result. So I can simply get rid of that and run it. And as you can see, I'm getting the same numbers. Now, as the y values, I would like to use the approach that we had here. So x times x for x in x's. So I'm just gonna copy and paste the code, because now I'm just saying, okay, multiply the value with itself and position it at the same spot. So meaning 0 times 0 will be at the index 0. 0.1 is at index 1 for the x list, and in the y list it should also be at index 1, but it should now be 0.1 multiplied with 0.1 and so forth. So now if we use that and we print it onto our console, as you can see, now we get this very smooth line here. All right, so let's say you would like to have this kind of graph and you would like to have it from 0 to 10, but then you don't use this approach of dividing by 10 and going all the way to 100. So let's run that, and then you see it again. It's not this perfect line that we just had. It doesn't look as great. So if we zoom in again, we see it's not this perfect line that we would like to have. And that's because we are not having the right amount of values. Well, we're just having 10 values. But if we really just want to go from 0 to 10, what shall we do? Well, we can have 10 times the values, but divide the value itself by 10. And that's what we're doing here. And then we get this smooth line. All right. So that's generally how you can improve your graphs. And that's generally how you can make your code a lot shorter using list comprehension. Welcome back. In this video, I will introduce tuples and dictionaries, and they are new types that we haven't touched yet. So we have seen lists, and dictionaries and tuples, they are similar to lists. So they are also collections, but they work differently and they behave differently. So let's assume we have this problem. We just want to quickly group two values together. So we want to group the first name and last name of a person. And we don't want to do a specific variable for that in terms of a string variable. So we don't want to store it in a string, but we really want to have the capability to have access to them separately. So have access to those values separately. Now, the solution to that problem is we use tuples. So we need to use tuples if we want a function to return multiple values. And imagine you have a function getStudent, which should return both the first name and the last name. And this is not possible without a tuple, or at least it's not possible in a clean way. You could, of course, use lists where you have one list with the first names and one list with the last names, but that would not be a great way of doing it. And you would always have to be super careful that you, whenever you fill up a list with a new first name, you always have to fill up the other list with last names or with the correct amount of last names and so forth. So that's pretty tricky and it's not a good practice. And then there is another thing called dictionaries, and they have quite an advantage as well, because for example, we have this problem. We would also like to be able to save an assignment. So for example, assign the phone number to the family. So we have the family name, let's say Masterman, and we want to assign the telephone number, for example, 1, 2, 3, 4, 5, 6, 7, whatever, to that family name. And we want to store multiple families with their telephone number in a specific kind of list. Of course, we could have two lists here, one list with the family name and one list with the telephone number, and they are always connected through their index. But then again, if you want to delete one family, then you also have to delete the same list element for the telephone number. And that's really not that great. So that's where dictionaries come into play. And we can answer the following question efficiently with that. What telephone number does the mastermind family have? And we are going to go ahead and use dictionaries and tuples in the next videos, where all of what I've just said makes a lot more sense, because it really makes sense as soon as you get into practice and as soon as you see things in real life. So see you in the next video. Welcome back. In this video, we're going to look at dictionaries in Python. And in this lesson, I will introduce you to dictionaries. Why do you need these? Well, you can save value assignments, e.g. phone book. A last name has a phone number, so you could create a phone book with a dictionary. You can change, remove, or add elements later, so it's mutable. You really are going to need dictionaries again and again, generally when programming with Python. And we'll also look at a few examples later on in this course. So let's get into it. Let's create a dictionary first. So in order to create a dictionary, you have to use the curly brackets. And then you have a key and a value. So this is generally how you have the values within a dictionary. And then you separate them via comma. So you have key 1 with another value. Then key 2 with another value. Now those keys, they have to be unique. So it's important that they are unique, but then they also have to be of a immutable data type, such as a string, a number, or a tuple. So you can have only strings, numbers, or tuples as the key. Okay, so for example, I can have something like Dennis, and then the value would be the telephone number. So something like 1, 2, 3, 4, whatever. So this could be my telephone number, which is assigned to Dennis. Now there can only be one Dennis within this dictionary. All right. Then after the comma, I would have the next entry within the dictionary. So that would be something like Frank, and Frank would have a different telephone number, and so forth. All right. So this is how you can create a dictionary. So let's say we want to have a dictionary which contains the city name and the name of the associated airport. So let's say something like Berlin has BER associated to it. By the way, the value doesn't have to be unique, right? The value doesn't have to be unique, and it can be mutable. So that's pretty cool. Then the next city would be something like Helsinki, and there the name is Hell, not with double L. Then maybe Saigon would have SAGN, something like that, and so forth. So you could fill up your dictionary with a lot of values. So now let's check it out. Let's print the dictionary. And D doesn't exist. It has to be a low caps D once again, and there we are. So you can see the dictionary can easily be printed with the print function. And let's say we want to print one of those values out. So if I want to have the value Hell from Helsinki, well, then I need to print D, and then in square brackets I need to enter the name of the key. So Helsinki is the key name for that entry here. So for this entry. So if I print that, as you can see, I get Hell here. If you want to add a new value to your dictionary, then you can simply use the following. You can use the name of the dictionary, then in square brackets you enter the key name, for example Budapest, and you assign its value, which is bud or bud. And if we now print D once again, so let's paste it down there. As you can see, now my dictionary has Budapest at that point as well. All right, so how do you remove an element from the list? Well, you can simply use the del keyword and then tell which key you would like to use. So which key value pair you would like to delete. And that would be Budapest, for example. If I now print D once again, as you can see, Budapest is not in it anymore. So how to query, is there an element in the dictionary? So let's say you want to check if there is a specific city name in the dictionary, and then just print something like if Budapest is in D. So we are just using the in operator again, or the in keyword, and then we want to print Budapest is included in the dictionary, something like that. And as you can see, if I execute that, it doesn't work, so nothing happens pretty much. That's because Budapest is not part of our list, or of our dictionary here, to be precise. So if I, for example, check for Saigon in D and print Saigon is included in the dictionary, and now I execute the code, as you can see, Saigon is included in the dictionaries, print that out. So as you can see, you can easily query through dictionaries. So they're super useful and powerful. So you always have this key value pair, and there are very many situations where it really makes sense. I mean, the word dictionary is already very explanative of what this is. You have one value, for example, the word in one language, and then you have the other value, which is the word in another language. So let's say Berlin, well, that's a bad example, but let's create a D2 which has values such as car, and in German it's called Auto. Then you have bike, and in German it's called Fahrrad, and so forth, you know. So that's how you could use it. Of course, dictionaries, as I said, you only assign one value to another, and the key is unique. So that's how you are limited. All right, so how do we access elements? Well, it's pretty simple. Print D, and then we simply say which key we are looking at. And if I look at the Saigon, then I can get SGN here. Another way to access an element is print d.get Saigon. As you can see, I get SGN here as well. Now, if I try to access an element that does not exist, let's say I try to access Hong Kong. So D Hong Kong, then I get this error here saying key error Hong Kong. So you have to be super careful that the key that you're trying to access is actually within the dictionary that you're looking at. But if you use the other approach, so let me copy this code here, this d.get function or method, there I can use something like Hong Kong. Well, that will simply return, if there is no value, it will simply return none. So that's the cleaner way, let's say. So you don't run into an error if the element doesn't exist. You simply get none as a return. All right, so that was a little introduction to dictionaries. And as I said, we're going to use dictionaries a lot. So check out this video once again if you feel like you need to see stuff once again, or just play around with the values and create your own dictionaries and play around with them. All right, so see you in the next video. All right, so let's check out the answers for the last quiz. If you easily managed to get them right, then you can simply skip this video. All right, so question 1, which code defines a dictionary? So there we are with 4 different versions, and the first one uses square brackets, then the second one uses the round brackets, then we have curly brackets, and finally we have curly brackets once again. The difference between C and D is though that here the comma is separated in order to, well, they're all comma separated pretty much, so this is already incorrect, but D is the correct answer. Why is that? Well, we're using curly brackets. That's generally how you define a dictionary, but then you also connected the key value pair with the colon, and as well as having a comma to separate different entries in here. So this is entry 1, this is entry 2, where Trump is associated with USA and Merkel with Germany. So the correct answer is D. Then question number 2, we have defined a dictionary as follows. D is equal to Trump, USA, or Trump is associated with USA, so the key is Trump, the value is USA, the key is Merkel, the value is Germany. So question 2 already pretty much answers question A, but you saw them in a different order, right? Or you could only see question 2 after having finished question 1. So how do we access this first entry, Trump or USA, or this key value pair, Trump USA? So one of them is print D and in square brackets Trump, then print D USA, print D 0, and print D 1. The correct answer here is Trump. So we need to access this A version, print D, with the key name. So here the key is Trump. That's why we need to enter Trump as the value that we would like to access. So that's the index, you could say. So it seems like the index, but it's actually the value. Because in dictionaries, that's something that I haven't touched on, the values are not in order. So it's not like this value is at position 0, this value is at position 1, and so forth. No, they are not. So they are really scrambled in there. Then let's check out question number 3. We have defined a dictionary as follows. Trump is connected to USA and Merkel to Deutschland or Germany, as you please. Deutschland is the German version for Germany. And how do you check if the entry Trump USA is contained in the dictionary? You can say, you could ask 0 in D, that's incorrect. Then we have Trump USA in D, or you could just look for Trump in D or USA in D. And the correct one of those is C, where you search for the key again, and the key is Trump in D. So the correct answer is C. So if you want to search for something in a dictionary, you have to enter the key. And in this case, we're looking at strings. That's why we need to enter the string in D. Welcome back. In this video, we are going to check out tuples. And tuples are something like a list, but are used for other purposes. So they are similar yet different. They differ from a list in some points, and we'll see how to use them in Python. So let's go ahead and declare a tuple. And you can give it a name, and after the equal sign, you can assign the value. And lists, for lists, we used square brackets. For dictionaries, we used curly brackets, and now for tuples, we use round brackets. And here we can just say 1, 2, 3, and those will be the values of my tuple. So I can have multiple different values within my tuple. Now let's just print that tuple out, and as you can see, it's just 1, 2, and 3. Now we can look at lists. So let's say we have list 1, and it has the values 1, 2, 3, and now we append something to that list. So let's append the value 5 to the list, just because we can. Now let's print that list out as well. Print list 1. Now let's execute it, and as you can see, 1, 2, 3, 5. Now with tuples, on the other hand, if we want to do that, let's add something. Well, actually, let's add it in here. Let's say we want to extend the tuple and we want to append to it. So dot append, and we say 4, for example, and I run this code, and as you can see, tuple object has no attribute append. Well, okay, maybe it's add then. Let's try add. Tuple has no object called add. Then let's say we want to add it at the 3rd position and add the value 4. Okay, it doesn't support item assignment. So as you can see, tuples don't have all those things because tuples are immutable. So they are not changeable. So as soon as I have declared it once, it will always stay the same. So this tuple will always only contain the values 1, 2, and 3. So I cannot change it. So why is that useful? Well, let's have a look at an example, because then it becomes clearer. So let's have a little look at what mutable and immutable really means. Because yeah, of course you cannot change it, that's cool and all, but how do you use that? How do you profit from that? Well, let's have a look. Let's create a person. So I'm gonna call this person Max Müller, and I'm gonna make a list with it. Max Müller, and his age is 55. So this guy has a name and an age. So first name, last name as a string, and then the age. So it's a very simple list so far. As you can see, we can create lists with two different types of values, so strings and numbers. And then let's create a function here. So let's call it do something. It's a very generic one. It's just gonna take one parameter, and we want to have a list type as the parameter. Okay, so I'm gonna say at the first position, replace Max Müller with Max Mustermann. So just a different name. Now, if we print that person afterwards, so let's do that. As you can see, it's still Max Müller. But now let's call this method. Let's call do something, or this function, and give it person as its argument. As you can see now, this person suddenly is called Max Mustermann. Why is that? Well, our function here that we created, do something, it doesn't change the value or doesn't reproduce the value, it doesn't copy the value of the list that it is given, but it's actually changing the list itself. So it's really changing the person here. So at the position 0, it's changing the name to Max Mustermann. So this person, or whatever list we give to this function here, will be changed by the function. Okay, and that's something that you very often don't want. So you have your list and you don't want anyone to interchange it or change any values in there. And that's where it makes sense to use a tuple. So here you could just say, okay, I have this person called Max Müller, and now it's a tuple, so now it's immutable, so I cannot change it. So if I try to change this person now, well, obviously it won't work. So as you can see, tuple object does not support item assignment. So just keep in mind, whenever you want a list type of behavior where you want to make sure that this list is never going to be changed, then use a tuple. If you want to be able to change it anytime, then use a list. And then always check. So I will always test. As you can see, it's super important that we test and we see that we have this error here. Tuple object does not support item assignment, and then we see, okay, so we're trying to change something that is a tuple, and yeah, then it said something about tuples not being changeable or them being immutable. So just keep that in mind, and then you're good to go. Welcome back. In this video, we are going to work with tuples. So in the last video, you saw what tuples are, and now we're going to see how to use them efficiently. And we'll use tuples to model multiple return values of a function. That's a pretty neat little feature. And we're going to unpack tuples. So let's create a tuple for that first. Let's create a student tuple, and let's call this guy John Doe. He's 22 years old and he studies informatics. So that's the subject that he has. Now, in order to get the name from the person, we could go ahead and do something like name is student 0. Then age is student 1. And then subject is student 2. So let's assume we want to have those values from that tuple, and we would like to use them later on. So now we can of course go ahead and say something like print name, print age, and print subject. Now let's print that, and as you can see, we get John Doe, 22, informatics. That's all cool, but that's highly inefficient because there is another way of doing it. What we can do instead of doing this, as you can see here, this approach is something that where we do all of that in one line. So we can unpack this tuple. And how do we unpack it? Well, we say the names that we would like to have as a variable for the different values of that tuple. So let's say I want to have the name, the age, and the subject, and that from student. Now Python will understand what's going on here, because it says, all right, there is this student and we have the student tuple here. Okay, I understand that. Now let's go ahead and assign the name to the first entry of the student, and that's going to be John Doe. Initialize the age with the second value of the student and the subject with the third one. So if we execute that code, and we can see that we still get the same result. So we still get those values printed onto our screen. So that's how you can unpack your tuples. That's pretty cool. And as you can see, it's super efficient. Just one line of code, not additional work here. And that's awesome. Now the cool thing is we can also use tuples as a return for, or return type for our function. So let's create a function get student underscore student, and that function will simply return something. It will return John Doe, and I'm just gonna copy this what this code here. So it's just going to return this tuple. That's what I'm saying here, all right? So whenever I call this function here, it will return those people, or it will return this tuple. And let's just do that, get student here, and let's print it. And as you can see, I get this tuple returned. Now the cool thing is you can do the same thing as we did here with this tuple. So we can also go ahead and say name, age, subject is equal to get underscore student. And if we print them, let's do that here, you can see we get those values as well. So that works perfectly fine as well. There's one thing that you have to be careful though, is if the tuple doesn't fit the amount of variables that I have here, then it doesn't work. So let's say I have another information here about where the person comes from. So let's say this person comes from the US or USA, and if I print or run that, too many values to unpack. Expected are 3 values, but actually there are 4 values within that tuple. So that's what the problem here is. So you would have to go ahead and say something like country, and then it suddenly would work again. Okay, so that's how you can generally unpack tuples, and you have to be super careful that you have, of course, the right amount of variables assigned. All right. So the message here is that you can not just return simple values, you can also return tuples. So a function can return tuples. That's pretty much the message of this cell here. Now let's have a look at another cell. So let's say we don't want to have one student, because one student is cool and all, and we have all of these values, and that's great. But I would like to store all of my students. How would I do that? Can I use a tuple for that? No. Can I use a list for that? Yes. Do I need tuples within the list? Yes. So you can use tuples, but not as a only element of that type of collection, pretty much. So let's go ahead and create a student list, but this time it's going to contain multiple tuples in there. So you can have tuples within lists. So you can go ahead and say something like Max Miller, and this guy is 22 years old. Then you have Monica, and she's also a tuple. Monica, and what's her name? Monica Fisher, and she is also, well, she's a little older, she's 27. So you can do that, right? So you can create a beautiful little list containing multiple tuples. And here, for example, it would make sense to make it a little bigger so that you have a better overview of things, right? So let's add another one. Let's add someone called Frank Johnson to our list, and this guy is 23 years old. So now I have this list of tuples called students, and if I want to access the name and the age, I can use a for loop again. But now, instead of just saying name in students, I say name, comma, age in students. And now I can go through that and, for example, print the name and then also print the age. So let's run that. As you can see, Max Miller, Monica Fisher, and Frank Johnson are all printed on the screen. So that's a pretty cool thing. As you can see, you can use tuples in many different ways, and tuples have different kinds of functions, and we're going to use different kinds of functions of tuples, and we're going to play around with them, and they will be super useful going forward. So in the next video we are going to check out dictionaries real quick once again, and then you'll have a little challenge. So see you there.
Alright, so now you have been around for hours and I hope you enjoyed this course. So now I would really recommend you to check out the link in the description to get the full masterclass, which is a 30-hour course. So it's pretty much what you see here plus another 20+ hours. So it's really worth its money, and it's really going to be an amazing investment into your future in becoming a great Python developer to do whatever you want with it. You can use it for machine learning, you can use it for data science, you can use it even to create games or backends or crawlers or basic PC applications, whatever you can think of. All right, so check it out. I hope to see you there.
In this lesson, you will learn how to go through a dictionary entry by entry and why you need to unpack tuples for it. All right, so if you want to go through every single item within your dictionary, and by item I mean a pair, so this is a pair which is an item, Munich and MUC as example, you can go ahead and of course say for key in D print the key. So this way we get the key, as you can see, Munich, Budapest and Helsinki. But then if you want to have the value, well, you can simply say value is equal to D, and here it's key. So D and the entry for the key. So it goes through every single entry and it gets the key, and then it just uses the key in order to find out the value. And then we can of course go ahead and print the value as well. So let's do that. As you can see, Munich, MUC, Budapest, BUD, and so forth. That is a totally valid approach. But then you can do something pretty cool, because you can use them as tuples. So this can be a tuple, that can be a tuple. So every single item can be used as a tuple. So if we do as following, for key comma value in d.items, and by d.items, let's check it out, print d.items, and I'm actually missing a closing bracket. As you can see, dict items, so you can get all the dictionary items in there, and as you can see, it's actually stored as a tuple. So Munich and MUC is stored as a tuple. How do I know that? Well, you see that it's in those brackets and it's separated by a comma, and then that is generally how we create tuples, or how tuples are represented, right? So for key value in d.items, and d.items is a set of tuples, so it goes through all the tuples and stores the key and value accordingly, and now we can just go ahead and print that. So print key plus the colon, empty space, plus value. So now we have this beautiful way of presenting the data accordingly. And it was super dense, as you can see. It's just really those 2 lines of code. And that's pretty much what we're using here. So this is the unpacking of tuples, and we're just using this for loop to go through all the tuples which are within the dictionary. So every single item in the dictionary is a tuple. So that's really what you should take away from this video. In the next video, you'll see a little challenge, so see you there. Welcome back. Now in this video, I would like to give you some hints for the next exercise, and that is to read the data/name CSV file and calculate which name was assigned most often in the whole USA, or the whole country of the USA. So pretty much which name is the one that was given most of the time. And first read the data into a dictionary and count how often each first name occurs. Then analyze the dictionary and find out the most common first name, and note that if you want to add 2 numbers, you may have to convert a string to a number. Write all your code into one cell. So the one cell thing, why would you do that? Well, if we check this out here, we open a file like that, and we have done that in the past where we say data/names.csv, and the type of opening is going to be read. And now in here, for a line in file, I could print the line and then break. So if I do that, and actually I'm having an error because file is not known. So after I execute that, now I can execute it. And as you can see, now I get ID, name, year, and so forth. Now I execute it again. I get the first entry, I get the second entry, the third entry, and so forth. So as you can see, this is not really what we would like to have. So use the same cell. That will really help you. So instead of doing it in two different cells, do it in one cell. And by cell, I mean like these blocks here that we have. Okay. Then of course you can use with open here, and that will be the cleaner version, because then your file will be closed as soon as it's not required anymore, or as soon as its work is done. And here we need to enter as file, and then we run the code. And the code that we would like to run would be, for example, this for loop here. And always be careful with the indents, the indentation, that it's always correct. Now if you run that, and you can use it differently. Okay, and then about this number thing that I was talking about, where you should add two numbers together, be careful because you get them as strings. So something like yeah, let's have a look here, 15 plus 13. If you look at it, you see it's 1513, and that's just the string, right? It's just concatenated to each other. So be careful with that. Convert them into the right type, which is number or string, and then you can work with it. All right, so these were just some tips. Now please go ahead and use this approach, and of course you need to use dictionaries, right? Because otherwise, yeah, it might become difficult to find out the real answer to the question. So good luck with that, and see you in the next video, where I'm gonna give you some more advice on how to get it done. So here's generally the task, then some tips, and in the next video you'll get even more tips if you feel like you need any. All right, in this video I would like to give you some additional preparation advice on how to solve the challenge, the exercise that you have gotten from the last video. So your task is to use dictionaries in order to find out which name is the one that was given most in the US. And therefore you need to check something. And I will show you something with this list one, where we have hello, hello, world, hello, and Mars in there. And now I would like to know how often hello is in there. And I also would like to know which word it is that often. So the word hello is 3 times. The word world is only once in there, and the word Mars is once in there as well. So if we create a dictionary, let's go ahead and do that. Let's create an empty dictionary. And now I would like to go through my list one. And if the element that I'm looking at, so with this for loop will go through every single element within my list, every single item pretty much in the list. And if the element in my dictionary, which at the beginning is empty, is existent, so which means that this word is already in my dictionary, then please go ahead and add at the element position the value that it had before plus 1. So we always have a dictionary, as you know, it consists of a key and a value, key, value. So we're going through the list, and then we're going through, or we're checking it, comparing it pretty much with the dictionary. So if it already exists, so hello already exists in the dictionary, and as you know, a key can only be unique within a dictionary. So hello will only be in there once, so it will not be in there twice or something like that. World will only be in there once, and that's the same for the name. So Frank will only be there once, and Michael will only be there once, and so forth. So we check is this name already in the list? Yes, if it is, okay, then please go ahead and add the name, add its position, add the value that it had before, and add 1. So now this name will be there an additional time. And else, just say that element is there once. Because if it was not in the dictionary before, as it is at the beginning, then we just add, or we just assign the value 1. Now let's print D after this for loop, and you will see what I mean. So we have this dictionary, the dictionary, which at the key hello has the value 3, at world it has 1, and at Mars it has 1 as well. And that's because the value hello, or the text hello, is there 3 times in this list. So that's how you can simply use a dictionary and for loop in order to figure out how many occurrences a specific name has, right? But that's not enough, because you don't only want to know how many occurrences a specific name has. You want to know which name is the one with the maximum occurrences, so the one that has most namings. Max occurrences is going to be 0. And now we need to use tuple unpacking. So we say key, comma value in d.items. So now we go through all the items in our dictionary D, and we check if max occurrences is greater than the value of our specific entry of our item within the dictionary. And if that's the case, then let's say max occurrences is going to be the value. And then let's print the max occurrences just to see what they are. And as you can see, we get the value 3. So now we will know which is the highest value in terms of namings. And of course, you can also just print out the key in order to find out what the name is with the maximum occurrences. So this is just a hint, right? I'm not giving you the full answer already. But generally speaking, that's how you can approach this whole challenge. So this for loop is really just there to figure out what is the highest number, and also to figure out what the name is. This one here is to accumulate all the namings in order to create a list of all the names with their values. So with how many people were named with this name in the US. All right, so good luck and see you in the next video. Now I would like to show you that you can nest lists. So in Python, it is allowed to nest lists. This allows us to model a matrix, for example. In this lesson, you will learn how to nest lists and then access the elements accordingly. So let's create a list. And let's say we have a list, and in there, I would like to have a list of cities. And I would like to have a list of cities from the US, another list of cities from Hungary or stuff like that. So let's say I start off with New York, then I have Chicago, and then I have Los Angeles, and so forth. So I can go ahead and create a list with lists. So this one contains a list of 2 list elements, so New York, blah, blah, blah. So these 3 are elements within list. At the index 0 of my list 1, and now at index 1, I have another list, which says Budapest, then Pécs, and Sopron. So now if I would like to access a list element, I can just say list 1 and at 0. And let's see, we have New York, Chicago, Los Angeles. But what if I want to specifically access Chicago? Well, then I can simply say 0, 1. So now I'm accessing Chicago. So within the list, at which position is Chicago? Well, it's at the index position 1. So New York is at index position 0 and Chicago is at index position 1. And where is this list in total? Well, it's at the index position 0 of my list 1. So that's how you can access it. Now, we can also use lists in dictionaries. So let's go ahead and create a dictionary called students. And now in there, I can store loads of information. So for example, I can go ahead and say something like informatics is connected to all the students who study this subject. So I'm going to have a list where I have Max and Monica. Now, as you can see, there is another topic which should be history, for example, and there I have the students Eric and Paula. All right, so that's what you generally also can do. So you can use lists as the value of a dictionary, but you cannot use it as the key of a dictionary. So the key of a dictionary has to be an immutable type. All right, so let's print those out. Let's print the students who study informatics. And here I have to be careful that I write it correctly, informatics, because otherwise I get an error, as you know. And here Max and Monica. And now I'm gonna print the students who study history, and let's run it, and we see Eric and Paula. So that's just something that I also wanted to show you when it comes to nesting lists. Welcome back. In this video, I will show you the sample solution for the exercise dictionaries. So you needed to read the data.name CSV file and calculate which name was assigned most often in the whole USA. So let's go ahead and start off by opening up the file. And I'm gonna open it with data/names/CSV, and here I have to add another slash. So /data/names.csv. And the way of opening it up is going to be R. So I'm reading the file. Now I need to have a dictionary which contains the names first. So I'm going to start off by using an empty names dictionary. And now I will go through every single one of them and, well, we'll add it up to this names dictionary. So I need a for loop which goes through the whole file. So for line in file, I want to split it up first. So I'm going to call it split it again, even though I know this word doesn't exist, but split it in the terms of it is split, or it has been split in the past. Okay, then line dot strip. So now I need to strip it first because I don't want to have any empty spaces or any line breaks or stuff like that. And then I need to split it, and I'm going to split it at a comma. And now that I have split the line, I can go ahead and check if at the position 1, so split it position 0 actually, so in the first position, if there is ID, because if there is, then just skip that, continue. Because as you know, we have this headline of our file and it's ID, then it is the name and so forth. So these entries, if they, so pretty much we just say, okay, we want to split the very first line of our file. And if we do that, well, we just skip it and we go to the next iteration. So what else would I like to do in there? Well, I would like to assign this split it at position 1 to my name. And then I'm going to create a count variable as well, which is going to be the split it at position 5. Now, that itself is a string, so I need to convert that into an integer. All right, and now I need to check if name in names, so the name that I'm currently looking at, because as you see, so we have this line, and split it is just the line in a split way. Then I'm checking the name and I'm getting the count, and the count, as you know, is a string as well, so I need to make an integer out of it. And now I can check if the name is already in names, because if it is already in names, in our dictionary, then please go ahead and add that to names, name plus count. So the amount of entries that we have this name in our list already. And otherwise, go ahead and assign count there. Why is count important and not just +1? Well, it's important because we store a specific value in here. So as you can recall, we had this line where we have the ID, the name, then there are values about the gender, in which state the person is born and or was born, and then also the amount of times this name was given. And that's the count that we're looking at. So we need to have this count in order to add that to the total. So now we're just saying with this for loop, check through all the names and get us the total for that name. And this is our for loop for this task. Now let's add another cell where we're just going to check the occurrences in order to compare which name is the one that has most occurrences in total. So we create another variable here, max occurrences, and we set it to 0 first. Now I need to have this name variable because I would like to show it on the screen, because I want to know which name was in the end given most times, right? And then I can go ahead and use my tuple approach here. So key value in names dot items. So names is our dictionary, as you might recall from here. This is a dictionary. So we go through all the items in our dictionary and we create a tuple out of it, and we check if max underscore occurrences, and I have typed it incorrectly here, so I'm just gonna copy and paste it now, is less than the value. And if that's the case, then please go ahead and say max occurrences is going to be value and name is going to be the key. And now finally we can go ahead and print the name. So why does this for function work? Well, it goes through all the items. It checks each time is the one that I'm currently looking at. So the name that I'm currently looking at is the value that is there. So the amount of times this name was given, is it higher than our max occurrences? And if that's the case, well, then we have a new winner. So then we have a new name that was given most of the times. That's why we just say, okay, now that's the amount of max occurrences. And then we can print the name, because the key of that specific item that we're looking at is the one that is our winner, right? So that's the record holder pretty much. And now we can go ahead and display the name. Now the max occurrences, we can then display those as well. Max underscore occurrences. And why do we do that? Why do we have these variables outside? Well, we need them in order to assign the values accordingly and to keep them out of this for loop, in the sense of they will always be pretty much the viewers from the outside, and they will only be changed if it's really necessary. And once they are done, we can go ahead and print the name. So once this for loop is done, only then we want to print. Of course, we could have printed within the for loop, but then it would print us all the time the new record holder. And of course we could try that, but let's first try to run the code like that. And I have the problem with names, and that's because I didn't execute that code. So let's execute cell number 1 and then execute cell number 2. And as you see, it takes a little while because the file is pretty big. And there we are. We see James was given 4,957 times, or 57,166 times. So James is a very loved name. People love to call their children James, as it seems. All right, so this name was given 5 million times in the last century. Pretty impressive. Now we can of course print something here where we just say, okay, print value and print key. And now it gives me Mary, who is 3.74 million. Then we have John, almost 5 million, and James also almost 5 million, but a little more. All right, so I hope you managed to get this done. If you didn't, no worries, but now you have another example of what you already can do with your skills. So it's pretty cool. You can now try to play around with it. Of course, you could figure out how to show the best 100 or the highest 100 numbers or stuff like that. So yeah, feel free to do so. And in the next video, we are going to quickly check out how to nest data structures. So see you there. Welcome to the chapter on object-oriented programming. And there is such a concept which is called OOP, and that's a shortcut for object-oriented programming. And now let's have a look what the idea behind that is. First of all, let's look at this problem. So far, we can already create functions and variables, but as soon as we have many loose functions, variables, and stuff like that, the whole code can become confusing. Because in our example, we have very short code so far, only 50, 100 lines of code, something like that. But as soon as you get to a point where you have multiple hundreds or multiple thousands lines of code, then the code becomes really, really difficult to read. And also it becomes really difficult to work with, especially when you work with a group of people. And let's have a look at an example. So here, an example of a student. A student has a first name, he has a last name, an age, then a subject or multiple subjects. And then let's say he has a function which is called getFullName. And that getFullName, well, gives us the first and the last name, just as an example. And there could be plenty of more examples what a student could do. Something like apply for a job, or apply for a new subject, or have an exam, or stuff like that. And all of those things, they can of course be in one whole big file where we do all of that and all of our other code as well. But then there is a very great solution for this problem where we can go ahead and use object orientation. This allows us to bundle all such functions, and our code will become much cleaner and clearer. So it makes a lot more sense what's going on. So the student could become a class, and we can make objects out of that class. So the class will be a blueprint for our student. So we can pretty much say what are the properties of that student and what are the skills or functionalities or functions of that student. And this really allows us to work very well in a group. This allows us to share our code much better. And in general, this is also the concept which allows us to use modules. So modules are pretty much also classes that people created for us to use. For example, we have used lists, and there is somewhere a class which handles what lists can do, such as giving us the len function, which tells us how many entries are in that list. And that's something that we can develop ourselves by using object-oriented programming, and we will check out how to create our first class and how to use objects or create objects based on that blueprint class in our code. So I'd say let's get right into it, because it's great to see all or hear all the theory behind it, but it's a lot better to really dive into it and do some practice. So see you in the next video. Welcome back. In this video, we are going to check out the first steps in object orientation for you, and you will learn how to use object orientation in Python, how to create a class, and what methods are. So let's go ahead and check out an object type that we have already used, and that is a list. So we can just say something like Max and Monica are within our list. So the students variable here is an object of type list. And we have already worked with objects such as the Python list object, to which we have applied methods such as the append method. So now what I can do is I can go ahead and use the append method onto my student's object, and I can just add someone like Eric into it and print that whole list onto my console. So there we are, Max, Monica, and Eric. So this students is already an object of the type list. And that's something that is pretty cool. This is a functionality that is super powerful, and we have used that without even understanding the concept of object, without understanding the concept of classes and so forth. And that's exactly what we are going to look at. So we're going to create our own classes, which are pretty much blueprints of objects. So this student is this students is an object of this blueprint list where all of the functionality is included. So somebody wrote this, so pretty much Python knows this or has this particular class which takes care of all the functionality and behaviors of the list type. And there is something called append, so this method called append, which can simply append something to our list object. And now we can create our very own code which does these kind of things as well, where we can define everything we want in it. And if somebody uses this class and creates objects from it, then he will pretty much have to follow our lead. So now let's go ahead and look at that. So let's go ahead and create our first class, and I'm going to use the class student. And that's pretty much how you define a class. So you use the class keyword, and then you use a noun. That's the best approach. Use a noun, and it's important to start with a capital letter, then the brackets and colon. And by that you already say, okay, this is a class. And now within the indented code, so within the body of this class, you can define all of its properties, all of its functionalities, methods, and stuff like that. But for now, I'm just going to pass. I'm just not going to add anything else. But the cool thing is we can already create objects of that student class. So let's say I have Eric, who is a student. Now I can go ahead and give Eric a last name, or let's start with the first name, and that will be Eric. Then Eric can have a last name, and that will be something like Miller. And now I can go ahead and even print those. So I can print Eric.firstname, and I can print Eric.lastname. So if I execute that, as you can see, Eric and Miller are printed. And now the cool thing is I can create a different object of that class student. So this student is a blueprint, and I can simply go ahead and create multiple objects off of that, such as Monica, who is also a student. And Monica has a very different first name, which is Monica. And Monica has a different last name, which could be something like Fisher. And now let's print that onto the screen as well with Monica. So I'm gonna run that, and as you can see, we get Monica and Fisher. While that is totally fine, we can of course create a function which takes care of that. So let's go ahead and create a function which is gonna easily write that, and we won't need to go ahead and print it all like that, but it's done with just calling this function. So let's go ahead and create this get name function, which will need a student object. And what will it do? Well, it will simply print the student.firstname plus an empty space plus the student.lastname. So now what we can do is, of course, go ahead and say something like get_name and Eric, hand over Eric. So let's run that. And currently I'm getting an error, invalid syntax. That's because I'm missing the colon here. So now let's run it again. And as you can see, I'm getting this Eric Miller here. So the first name, empty space, last name, because I just called this function. So you can hand over your own objects to a function. And that is super powerful because as you can see now, I just need to call this function and it will do all of the code for me. So I don't need this print statement here anymore. The same for Monica. So I can go ahead and say something like get name. And here it's important to be very precise with the code. And here I just hand over Monica. So let me run that. And as you can see, I'm getting Monica Fisher. So even though this class student doesn't have anything in its body except for pass, which does nothing, we can go ahead and create objects off of it already. And we can add properties to that object. So Eric has the property first name, which is Eric, and the property last name, which is Miller. And Monica has them accordingly. Now, this getName function is cool and all, and it does good things, but there is a little problem with it. So let's say we have another class. Let's create another class, and I'm going to create it in another cell. This class is going to be called company. Company, and it's just going to pass as well. Now I'm going to define a getName function here as well, which will take in a company. And what shall it do? Well, it should print the company.legal_name plus an empty space plus the company.legal_type. So this is the business entity, something like limited and so forth. Okay. So this company, well, it can have those. So now let's create a company, and I'm just going to call this company C. Company. And C has a legal name, which I'm gonna set to Max Miller, because Max Miller is the one who founded the company. He called the company just as his name is. And then the legal type of that company is going to be something like LTD, limited. And before I run it, of course, I need to have a plus in here. And a company, whenever you create an object of a class, you have to be very careful that it has the exact same name. So company is written with a capital C here, so I need to use capital C in here. Then you might wonder, why don't I need to use a capital C in here? Well, in here, I'm not actually using the class. I'm just saying, okay, this variable that is handed over, so this parameter is just called company, with a lower cap C. So it doesn't have to be a company in fact. But in this case, we are using company stuff such as legal name and legal type. That's why it makes sense to only hand over companies in here. And you will see why that is important. So let's go ahead and get the name of C. Let's run that. And as you can see, we get the Max Miller Ltd. But now what if we want to get the name of Eric, because we had this Eric object earlier on, and we want to get his name now. Let's run the code, and as you can see, we get an error. It says student object has no attribute legal name. So our student from here, our Eric, doesn't have a legal name. He has a first name and a last name. So this code here doesn't work. And that's exactly where object-oriented programming has its power and its use, because what we can do now is we can go ahead and declare those functions within the company, for example, so within the actual class. So let me do that. Instead of passing, I want to go ahead and now execute or have this code in there. What that means is that the company class now has a method called getName, which is not gonna take a company in because it's just gonna take itself in. Why is that? Well, if somebody calls this getName method, it will be a company object. And then we just say, okay, the object that is calling the self should be the one that I'm looking at. So instead of writing company.legalName, I'm just gonna say self.legalName, and here as well, self.legalType. So what does that in particular mean? Well, now we can go ahead and say c.get_name and execute that. And we still get this error with the Eric type, with the Eric thing. So I'm just gonna get rid of that. And as you can see here, Max Miller Ltd is printed. Why is that? Well, that is because we are now using a method of the class company, which is called getName. And we don't even need to add an argument in here. That's because itself is the argument. So this C, which is an object of company, which has the legal name Max Miller and the legal type of Ltd, now is going to be self. And we get from itself, we get the legal name and the legal type. Now the cool thing is we can do the same with the student. So instead of having this getName function, which is just loosely flying around, which needs a student to get a first name and last name, well, we can just say, okay, you should be part of this student class. And whenever somebody calls getName onto a student object, we want to have his first name and his last name. Now, of course, it's not going to require a student anymore when it's called, but it's just going to require itself. So whoever calls it, that's the one that I'm going to look at. So in this case, Eric is the one having a first name and the last name, and Eric is also the one that I want to call this getName method on. So let me do the same with Monica, or actually let me comment that out for now. Let's execute that, and as you can see, I'm getting Eric Miller still, and that is because this getName method is called onto Eric. So Eric is the self, whose first name is Eric and whose last name is Miller. Now we can do the same with Monica. So we just say Monica.get_name, and that's it. As you can see, we get Monica Fisher. So generally you can go ahead now and create your very own blueprints and multiple different methods in here. And if you call them, well, you can simply call them on the object that is from that type of class. So in this case, we have the student class. And in our case here, somewhere in the list class, so there is somewhere a list class in the Python code, which has this append method, which goes ahead and appends something or does something. And that's the same what we do with our own method here that we called getName. Now let's have a look at something that is pretty cool as well. So let's just create a quick function here, which is gonna be name 5x. And it's gonna take in something, v. I'm just gonna call it v. You could have called it o. O is maybe a good name as well. And o is an object. And I'm just gonna say o get_name should be called in here. And it should be called multiple times. So let's say I want to print it out 5 times. Okay, or call the getName method 5 times. And now the cool thing is I can just go ahead and say something like name_5x, and I hand over Eric in here. And then I do the same with the C, with the company. And as you can see now, Eric Miller is called 5 times and Max Miller is, or printed 5 times, and Max Miller is printed 5 times. And even though we have two very different, very different objects. So this company is super different to the student, because as you look at it, we see that we have the first name, last name, which are different attributes than our legal name and legal type, but we can still call them. There are still these getName methods, and they can simply execute whatever we want. So we simply want to print something on the screen. All right, let's do that. And they exist. And this O, it doesn't care. This O here, it doesn't care if it's a student or if it's a company. The only thing that it does care is that there is a method called getName, which doesn't take any arguments. So which doesn't have any parameters defined in here. And even though it does say self in here, well, self is not particularly a parameter that we need to hand over as an argument, because self is the object itself. So we don't need to add anything in here. So we don't need to say O in here or something like that. While those are some capabilities of object-oriented programming, we will have to look into much more. So you will see how to create constructors, how to create private properties, how to use encapsulation, and so forth. So we'll look into all of those topics in this chapter, and then you will see a lot more use of using classes and objects. So see you there. Welcome back. In this video, we are going to look at constructors and how to change properties. And so far we used this very loose approach, which is really not best practice, especially when it comes to assigning properties here. So we assigned this property first name and last name, and we didn't ever actually say that is required in our students class. So we have this little problem here. If somebody for whatever reason forgets to enter the first name to Eric and we run the code, as you can see, we get this error. Student object has no attribute first name. So our object called Eric doesn't have a first name. That's why this method cannot be called correctly, which we do here. So we call it, and well, self first name is empty, so this whole code doesn't run. So how do we make sure that every single object of student has a first name and a last name? Well, in order to do so, we need to use something called a constructor. And a constructor is pretty much there to construct the object when it's created. So to define certain properties when the object is created. And we can define all of that within our class. So in here, we can define that there should always be certain properties given whenever somebody creates an object of this class student. And instead of then saying Eric.first name is equal to Eric and Eric.last name is equal to Miller, we would like to use it that way. We would like to say something like Eric, comma, Miller. So very similar to what we have done with the call of a method or a function, which we have seen in the past. We would like to do the same thing when creating an object of a specific class. So how do we get around that? How do we actually change the class code in order to allow this so that we don't need those two lines anymore? So then we can get rid of those two lines, for example, and our code would still work. And that here is the creation of the instance Eric of the class student. So let's go ahead and create that. In order to do so, we need to use the init function here. So something called init, and that will be our constructor. So this thing here defines our constructor, and we can now say something like init underscore underscore. And in here, we need to define self. So we say that whenever a student is created, himself should be the one that we apply this constructor to. And what shall we have? Well, we should have a first name and a last name. So whenever somebody creates an instance of my class student, well, he needs to have a first name and a last name. So that's what I'm defining here. And then I can go ahead and say self first name is going to be the first name that was given, and self last name is going to be the last name that was given. So this self, which means the object that we are looking at, should have a first name and the last name. And where do we get those from? Well, we get them from the creation of the object. So in here, this first name that I'm getting here is going to be Eric. So this first name is going to be that first name, but I'm saying, okay, the Eric's object, so this Eric object should have the first name that we just gave him. So here we assign the property first name to this object student with whatever we have given here. And in this case, it's Eric. And the same goes for the last name, so it's going to be Miller. So if we run that, and let's do the same thing with Monica. So let's say Monica and Fisher should also be there, so we won't need that anymore. Now let's execute the code, and as you can see, we get Eric Miller and Monica Fisher. So this approach is very clean, and now we can't have this problem where somebody doesn't have the required values anymore. So of course, yeah, we could now make the mistake and not enter anything in here, and as you can see, well, missing one required positional argument, last name. So now he thinks Miller is the first name, but of course it's actually Eric. So let me run that again, and the error disappears. So now the cool thing is we can now easily extend how a student should look like. So we can change our prototype of a student or our blueprint of a student as we please. And we do that within the class definition. So in here, I'm saying something like self.term is going to be 1. So this student is in its first semester or in his first semester. So whenever we create a new student, this guy is going to be in his first semester. So now we can even write something like plus, or here plus semester is plus str self.term. All right, so let's execute that. And as we can see, Eric Miller is in his first semester and Monica Fisher is in her first semester. So what if we want to change the term of the student now? So let's say Eric is in the term 100. So he's not in the first semester anymore, and we execute that code. Then you see semester is 100. Okay, but that might be a very insecure code, because what we want to do is each time that a semester ends or a term ends, we want to increase term by 1. And how would we do that? Well, there is a very clean way, and that would be to create a method for that. So each time that a student finishes his semester, we will add, or we will call this method, and it will increase his term. So we could call this one increase underscore term self, and that's because we want to increase the self or the term of self by 1. Self.term plus 1. All right, so now we can go ahead and say something like, instead of setting term to 100, because we just wanted to say, okay, the student now is in his second semester, but unfortunately we entered 100, so now we screwed the whole system up or something like that. Now we can go ahead and say something like increase underscore term. And now if we execute that, we can see Eric Miller, well, we created the student, but now he already was in the second semester. So he studied somewhere else for 1 semester, and now he's in the second semester. Of course, you could have said, okay, I want to have this term to be defined or to be given each time that we create an object of the student. So we could have, of course, said term is going to be in here, and whenever somebody creates a student, he needs to enter in which semester this person is. So let's say Eric is in his second semester, and let's say Monica is in her third semester. So now if I increase, or actually let's say she's in the 5th semester. So now if I run this code, you will see that Eric is in his 3rd and Monica is in her 5th. And that is because we increased his term, or Eric's term, before we have gotten the information. But now, of course, the getName function or method in here should be renamed, because now it's not precise anymore. It would be something like getInfo or getStudentInfo or something like that, okay? Because it's not just telling us the name, it's actually giving us some information about his semester. Maybe we even want to add something about what he studies, so about his subject and so forth. So now another point why this is pretty cool is increase term is the function or the method, because we created it within our class student. This method is pretty cool because now we can go ahead and add functionality in here which checks, okay, is the student in his 10th semester or something like that? Because if he is, then we want to kick him from the university because he has been in it for way too long. He took too long to get his bachelor's degree or whatever, and now he needs to get kicked from the uni. So you could add this functionality in this method in here. So you could just check, okay, in which term is he? If he's higher than term 10, then inform the system about this student being on the uni way too long or something like that, and exmatriculate him from the university. Okay, so that's how you can create a constructor, and you have seen what the advantages of creating constructors are. And yeah, you can now go ahead and create pretty much objects of whatever you want and add functionality to those objects as you like. So that's very powerful, and yeah, see you in the next video where we're gonna check out something else. So see you there. Welcome to Visibility of Methods and Variables. There is something called visibility in programming, and that is how a variable or a method is visible from a specific point of view. And we are going to look at it from a practical example where we look at a supermarket in order to understand that concept and why it is important. So let's have a look at this example. Imagine we want to model a supermarket. All that is important to us is that we can shop and in the supermarket. So we as a customer, for example. So we need to have the following method, shopping, right? So we do shopping. We can go ahead and buy stuff. But there is a lot within the shopping. So we want to pay and all of those kind of things, right? So for the supermarket to work, we have to have many different things which are working and which are required in that supermarket. For example, you need to have cashiers. They must be employed, they must be paid, and they must be found. So employees should be sourced, and you want to have good employees, so they need to be schooled as well or educated and stuff like that. Then you must have electricity and it must be paid for. Your new products must be ordered if something is out of stock or something like that. Then, as a customer, I'm not supposed to notice any of this. I'm just supposed to be able to shop. So I don't care about all of those things in the background. For me, the only thing that is important is that the stuff is there. I can take it, I can go to the cashier and I can pay. And I can take the stuff home. That's pretty much it, right? And it would be best if things were hidden from me as a customer. So I don't need to know all of them, as I said. And as a customer, I can only shop. As a customer, I cannot go to the supermarket and order more apples than there are available. Only the store manager decides whether or not to order more apples. So for example, I cannot go there and say, okay, this supermarket needs 1,000 new apples. That's something that the store manager does, right? Then as a result, as a customer, I only have access to certain functionalities. I'm not allowed or not even able to access the rest. So I'm not allowed to source employees. I'm not allowed to hire employees. I'm not allowed to pay them, although they, of course, would be super happy to get an additional payment. And this is what an example from real life would look like. So this was just a little example. But if we transfer that to Python, let's say we have a tool that downloads a web page. How exactly the data packets are sent over the internet is none of our business as a user. So we don't really care. For us, it's only important that the web page is displayed accordingly or correctly in our browser. The only thing, well, really that it's downloaded, and we don't care about those background processes or procedures. Where did the data come from? Where, what is the structure? How did they think about it in the background? All of those kind of things. They're not really interesting for us. So there is a little solution to this, and it's called visibility of methods and variables. We can hide methods and variables for other parts of our source code. So only some parts of the source code can access those methods and those variables. And we do that by making them private and so forth. So we will check out how to create visibility for methods and variables so that our program does exactly what we want. And somebody who should not have access to stuff that he's not supposed to have will not have it, because we make things invisible for him so he can never really access them. And that is important to make your whole software secure. Not just in order to make it invisible for other people, but also to make it invisible for other pieces of your software, which pretty much means that a specific object, for example, cannot access stuff from another object. Otherwise, it would create a huge problem, right? There can be plenty of errors that can come up with this. So we are going to check it out in detail in the next video. So see you there. Welcome back. Welcome to another aspect of object orientation, and that is private properties and methods. So you will learn what private characteristics are, what private methods are, and where or for what you should use them. And we have this little example of a student class again, as we had last time. And we have the constructor where we simply say the name or first name and last name are set, and the self dot term is set to 1. So the student is in his first semester. And then there is this method with which you can increase the term, but you are limited to 9. So a student cannot go to the 10th term or 10th semester. He maximum has to go to the 9th. So as you can see, self-term is self-term plus 1. So we increase it each time that this method is called. And with the name method, we simply print out the name. So now let's have a look at our student Eric Johnson, and we can increase his term. So let's execute that, and as you can see, now he's in the 2nd semester. Now let's just print it out multiple times just to see whether this guy can actually go to another semester than 9. But as you can see, maximum 9, even though I increased the term 11 times. Okay, so as you can see, this code here is working well. Now we have this capability of increasing the term with this method. But of course, somebody could go ahead and say something like Eric term is equal to 100. And if we execute that, as you can see, semester is set to 100. So somebody did something that was not intended, because the intention is that nobody can be in a higher semester than 9. So that would really corrupt our system. So if somebody looks up in the database and suddenly sees that somebody's in the 100th semester, then the alarm is going to go off. Somebody's going to get kicked out from the university. So that's the general problem that we are running in. And how can we solve that problem? Well, there is one thing that we can do, and that is to make term, or to add a underscore to term. By this, we tell the programmer, whenever you would like to use term, you have to be careful. Please don't set term. So in here, Eric dot underscore term. And if I execute the code, now I'm getting a little error here. So it says, well, that's because I didn't set the term here. So let me run that again. And here. So if you change it once, you have to change it everywhere. That's of course the case. So let me execute it now again. And as you can see, we can still set the semester to 100. But this is just a convention that if a variable or property has an underscore before its name, then you should not change it. So you should not access it straight away or change it straight away in a direct manner, as you can see. So you should use the available methods in order to do so. And the available method that we have is increase term. So now the next thing is you can make methods completely invisible and not approachable if you use a double underscore. So let's say I have double underscore term, and let me do that for all of our terms just to make it a little easier. If I now try to access this term to 100 or set it to 100, this code does nothing. As you can see, the semester is still 2. So this code is simply ignored. Well, if I use a double underscore here, let's see again, as you can see, it's still ignored. So it doesn't know this underscore term. It ignores it. It doesn't know what this variable is because it's private. Now it's actually private. So this underscore underscore term variable is super private. So this property, okay, this private property. So we cannot access it or change it from outside. Now, if we try to access this Eric underscore underscore term now, you might say, oh, it's actually working. Well, if we get rid of this line of code, now we suddenly get an error. So here we set this property, and now we set it pretty much from outside. So we created more or less a new property called underscore underscore term, and then we printed it out. So we print out pretty much this one here and not the actual term from there. But if we now try to access it, as you can see, student object has no attribute underscore underscore term. So now it's actually private and we cannot access it anymore. And as you saw as well, even though that code does work, the actual term is still set to 2. So we print out 100, but we actually print out this one here and not the actual term of that student. So that's what I wanted to show you real quick here. Okay. Now, as you can see, this term is private because we don't want anyone to play around with it and change it from the outside. So now let's assume we would still like for people to have access to the variable, but only viewing access. So they can only see the value of a variable, but they cannot change it. So as you saw, we cannot change the underscore term anymore, but we can still allow to see what the value is. So for example, we could go ahead and say def get underscore term, and we hand over self, and we say something like return self dot get underscore, or actually here self dot underscore term. So we could go ahead and do that. So let's try it. Let's print Eric dot get underscore term, and as you can see, we get Eric's term here. So we get number 2 here, which is Eric's term, and that is 2, because here it starts with 1, but then with this line here in line 21 we increase it by 1, and that's why it's not hidden to us, at least. So you cannot change it because it's private, but we have created something around it in order to display it. Okay, now you saw how to do it with properties or variables, and now let's have a look at how this works for methods, because we can do the same thing with methods as well. So let's say we have this method called do something, do underscore something, and it's just going to display self, or we just enter self in here and we print do something in here. So let's just call do something. So Eric dot do underscore something, and if we execute that, you see do something is displayed. So this is a very basic method and it doesn't do much. But if we add an underscore here and we add it here as well and we execute it, you see it's still working. But this underscore at the beginning of the method tells us as developers, dude, if you can, please don't use it if it's not really necessary. So please just don't use this method on my object. Okay, it's an internal method that should only be used internally. So let's say within my student class, but not from the outside. And if you really want to make sure that nobody really can access it, you can of course use the double underscore. So let's just do that, double underscore, and let me execute it. And as you can see, student object has no attribute do something. So now it actually is private. So this method cannot be used from the outside. So if we want to call this method, we can only call it from inside. So we can only, let's say, call it when somebody's trying to get the term. I'm just going to say something like self underscore do underscore something. Now if I execute the code, as you can see, do something is displayed. That is because this method here is private, which means it can only be accessed from the class where it's created itself and not from the outside. And I'm still getting an error because I'm trying to access the attribute here, which is this line here. So let me get rid of this line, and as you can see now, everything is fine. Okay, so that was the whole concept of private properties and private methods. So you can go ahead and create code that is secure now, that cannot be changed from other classes or other objects or from the outside, but only from the inside. So that's a good thing, and you will see plenty of examples where we will use that and where that makes sense. So see you in the next video. Welcome back. In the last video, you saw how to make a property private, a variable private, and also how to make a method private. And the whole concept of doing that is called encapsulation. So you encapsulate certain aspects of an object or a whole object. And we can go ahead and use that approach in order to create a clear layout, which is the prerequisite for building larger applications. And that's why it's super important to use encapsulation and encapsulating data with object orientation. So this whole object orientation concept is not only there to create a clearer code, but also to allow to work in a group of people. So let's go ahead and create a class called phone book. So this class is going to be simply a phone book, and it will have a constructor which will be something like init_self. And what do I want in here? Well, I want to have entries. So I want to create entries inside of this phone book, and those entries will be stored within a dictionary. And as I hope you still remember, a dictionary worked like that. So you had the key and the value. Okay. Now the key would be, for example, the name, and the value would be the phone number. So let's say we have this method in here, which allows us to add a new entry to our phone book. Okay, so I'm gonna say name and phone number are going to be the values that you need to give me if you want to add something to the phone book. So a new entry to the phone book. And what am I gonna write here? Well, entries is gonna be at the position of name, should be the phone number. So if somebody is calling this add method, he needs to give me a name and he needs to give me a phone number. And what I'm gonna do, or what this add method will do, is it will simply store it within the entries here at the key name with the value number. Now let's go ahead and create an object of our phone book. And what that object now can do, well, of course, it can go ahead and use this add method. So we can call this add method from the phone book, and we say something like Miller's phone number will be something like 123, whatever, just a random number. Okay, now that's going to be the phone number. Let's add another person in here. So let's say we have Fisher as well in there, and her phone number, or their phone number, is a different number. Okay, so this is generally how you can go ahead and create a phone book, but that's not the whole point of this video. So I can just go ahead and now say book.entries. So just give me the entries of the book. And as you can see, now I can see Miller, Fisher, and so forth. So this is very insecure. That's one thing. I can access it super easily, and I could even destroy the whole entries aspect, or this whole entries variable, or in this case, it's a property. I could do whatever I want with it because it's not secured. It's just openly available for me. And by me, I mean the person being on the outside of this class. So let's say somebody else is the provider of this class. And now I can play around with it. I can do whatever I want with it. And that's maybe not what he was intending to be done with this class, or this object, or the objects of this class. So somebody created this code, and well, he didn't create clear code or clean code. So I can now go ahead and play around with it and destroy everything. So that's pretty much it, the whole point that I'm making here. And you need to prevent that. So if you were the one developing this phone book, you need to prevent that. And how do you do that? Well, you can make, first of all, those entries pretty much private, so nobody else can access it. Okay, and that's what this self.__entries does. So if I run the code once again, as you can see, I'm getting an error here. Phone book object has no attribute entries. Now, of course, I need to also change entries here in my add method. But now if I have this approach, of course, I also need to get a way to access some of it, right? I can create a clean and secure way to still access stuff. So I don't want them to have actually access to this whole entries dictionary, but for the simple purpose of getting the telephone number, if giving a name, that's what I want to offer the user of this class. Okay, so if somebody uses this class, then he should be able to get the phone number, of course. So what I'm gonna say is, if the name is within self.__entries, then I'm gonna return the self.__entries name, or at the name position. What that will do is it will simply return a phone number. But otherwise, I don't want to return anything. So I'm just gonna return none. Now somebody can go ahead and say, okay, just give me the phone number of the family Miller. If I execute that code, as you can see, I'm getting the phone number, but I cannot change the entries. So I cannot go ahead and say book dot underscore underscore entries is gonna be an empty array now. So, or not an array, but an empty dictionary now. As you can see, the phone number still exists, so this code didn't do anything. Okay. Now, the other point about doing this is not only the security, but also the fact that now if we decide that we don't want to store the entries within a dictionary, but we want to store them in a database, then we don't need to change everything. We don't need to change the whole code, neither that one at the bottom. So we provided someone with this class, and now they can go ahead and use the class, but they can only use it as openly as we provided. So for example, they can only use the add and the get method, and they can do nothing else with it currently. But they don't care about whether they are storing the data within a dictionary or whether it's stored within a database or something like that. They don't care about that. The only thing that they care about is that they write some code that is still gonna work tomorrow even if we change it. So this add method, it's still gonna take only a name and a phone number. It's not gonna take something else in. So as long as I don't change this part here, nor that part there, or this part here, they will be happy because they can still go ahead and use the code normally. But what the body says, so the code here and there and this code, this can be changed to whatever we like. Of course, if somebody uses the get method, they expect to get the phone number. So if I change the code in here, I could say, okay, if name in my database, then return the telephone number. That's totally fine. That's still relevant for them. That's still exactly what they were searching for, but they don't care if it's entries in a dictionary or if it's entries in a database or if it's entries in a file or whatever. They really don't care. So that's the cool thing about using encapsulation, because now this is a clear layout that we can adjust, and somebody else who's using our code, let's say we're using it in a team or somebody's downloading it from GitHub and wants to use it, they will be still happy because the code still does exactly what they were expecting. In Python, there are a few special methods that our class can implement, and those methods are str, then they are wrapper and or repr, and the len method, and we can use them as follows. So let's go ahead and use the str method first. In order to implement that, we need to use underscore underscore. So as you can see, it's not, well, it's private, it's not changeable from the outside. So we can say str underscore underscore. So what this method does, it pretty much creates a string representation of our object. So that's the idea behind this method. And it's the string method, so-called, and you can find this method in other programming languages. It's the toString method, for example, in C#. And what it does, it simply makes a string out of an object of our phone book. So that's at least that's the idea behind it. So what we could return here is something like phone book, and it is containing the string of self dot underscore underscore entries. So that's simply what I could use it for. So let's say I want to, if I print the book, I want to print out the phone book. So I simply implement this method. And as you can see, I didn't call it anywhere, at least not explicitly, but implicitly when printing the book, now I simply use this str method, which, well, simply goes ahead and says, okay, make a string out of it. Well, at least that's what we did here. So we said, okay, I want to print phone book plus str self underscore underscore entries. So make a string out of my entries, because the entries themselves are a dictionary. And what I want to do out of it is pretty much a string so that I can display it in this manner. So that's what I'm doing in this line of code. While other programming languages only have one method that creates a string out of an object, and that is the toString method, for example, in C#, Python is highly advanced, so it has two different versions of it. So let's have a look at book in a different way. So let's just print that, and as you can see, if I just write book here, which is our phone book object, as you can see with the print statement, I got this text that I created here. So whatever I have entered here, and that's what I'm getting. But if I just use book, then I get it printed in a different order. I get an output of a different kind of version. So as you can see, it says, well, underscore underscore main underscore underscore dot phone book at, and that is pretty much a location in the stack. So now what I can do is I can implement another method which will take care of displaying it even on that level. So this is just simply a different level of output. And I can use the depper or the wrapper pretty much method. So repr underscore underscore, and here I'm also gonna say self. And here now I can enter whatever I would like to be displayed if this way of approaching the book or opening the book will be used. So let me execute that. This cell here where I just entered this wrapper method. And now let me execute it here. And as you can see, now the output is of the same type. So it's the same way of showing this output. And that's what this wrapper method is for. So that's what we can create it or use it for. And as you can see, it's a private one as well. And it's a predefined type. It's a very special type of method. We can simply define what it should do, but it's defined already when it is being applied. So we never actually call it. As you can see, it's just called at specific moments. For example, if we try to print the book itself, if we need it in a version of a string, then this method is called. If we use it in a different version, as you can see here at the bottom, where we don't print it, but we just display it, and we get this output, or we call this method pretty much and get that output here. Now, you can pretty much say that this method here, this wrapper, is called whenever there is no str method. So it's most of the time it would be enough to just create this method here. So we won't need this str method if we don't want to. But we can have the two different versions. So we could say something like different level phone book. And if we execute that and then execute this book here at the bottom, as you can see now, different level phone book. Now there is another method which we can override or use, and that is the len method. Because if I want to have the length of my book, I can of course go ahead and try to use the len function, the Python function len, but as you can see it says invalid syntax. Well, that's because of this line, so let me get rid of this line. Let me execute it again, and as you can see, object of type phone book has no len. So there's no len method which I can apply on this phone book. Well, there is something that I can implement, and that is this len method that I can implement myself. And how do I do that? Well, in here, I use self again as the parameter, but then I can define what should be returned. And I can just return len of self dot underscore underscore entries. So I can just say, okay, if somebody tries to, well, get the length of my phone book object, then I'm just gonna return the length of the entries, because it's pretty much representative of the length of the phone book, okay? Because if we look at the phone book, what do we really care about? Well, it's the entries that are in there. And if I want to know how many entries there are, that's exactly what I'm looking for, right? So how many values there are, pretty much, and I want to have the entries. And that's why approaching it this way is the right thing to do. So now if I try to access len book, let's run it again. As you can see, I get 2. Why is that? Well, because I have these 2 values here. I have Doe and Miller. If I would copy that and would add more values, let's just do that real quick. This one will be Smith, and he has a different number, and this one will be Brewer. He likes to brew beer. And now let's run it again. As you can see, now I'm getting the value of 4. So you can override what should happen with certain methods, and they are pretty much very special methods that you can pretty much use in any object that you create. So one more thing, in our case, now we have this different level phone book thing, but if we hadn't that, or wouldn't have that, then we could also just say, instead of calling this phone book thing here or writing this text here, we could simply say return self dot underscore underscore str underscore underscore and the brackets. And that will give us the same kind of result. As you can see, now we have this phone book with all the different guys. All right, cool. So if you ever need to create a string representation of your object, then you can go ahead and use that. And if you need the length, then you can use the len method. Welcome back. In this video, we are going to check out inheritance. And inheritance is a fundamental concept of object-oriented programming with which you can divide and better model data. And we already know the class student, so we create that in one of the last chapters, where we have this student with a first name and a surname, or we could also call it last name. And that guy now is going to be John. So we have the student called John and his last name is Doe. So nothing too fancy yet. But what if we want to have objects of students who also work? So we want to have students, that's all right. But then there are some students who are working in parallel or have an internship while being still students, so while still being at the university. Well, then what we can do is we can go ahead and just copy that code and let's say call this working student. So now a student can be a student, but also a working student. So if he already has a job, then he could be a working student. And how does he differ from a normal student? Well, he only pretty much differs in the fact that he also has a company that he's working for. So we could go ahead and say self.company is equal to company, something like that. Now, we have this student and we have this working student class, and they look pretty similar. And in fact, a working student is also a student. Of course, a student doesn't have to be a working student, but a working student definitely is also a student. And that's when inheritance comes into play. So if you want to have a different class which takes functionality from another class, then you can use inheritance. So now, instead of telling that John Doe is a student, he could be a working student. Let's say he got a job now, he's in his 5th semester or so, in his 5th term, and he has to have an internship in that semester. And now he's gonna work for the ABC company. And well, if we print it now, we get a little error. Let's execute that code, and then that code, then it works again. So I always execute the line of code before that. Actually, let me add that in here. All right. So what I can do now is, of course, say, okay, well, I have this name method here, I have this name method here, and they are all the same. They're exactly the same. So why don't I shorten things up? And another point is, I can go ahead and say, well, if I want to change, make some little changes because I realized that I have an error, or I realized that I don't want it to be in that structure. I want it to be some sign in here or some text in between here. So first name, empty space, last name, and then the actual last name or something like that. Now I would also have to change it for my working student. So I need to copy and paste code and copy and paste code again and again. And if I change it again, then I need to change the working student again. And that is really not a good way of approaching it. There are cleaner ways. And that's really where inheritance has its powers. And in order to use inheritance, you simply need to tell this working student that he is a student, or that he is inheriting from student. So I can just add the class that this working student is inheriting from inside of his brackets. So now he knows, this working student class knows that it is inheriting from the student class. And now in fact, we can even get rid of this name here. So now I can get rid of this whole name method, and I can still execute the code. And as you can see, it's still executing the code. So it's still saying John, last name Doe. It's not running into errors. Even though I created working student as well. The student is a working student object, and I'm calling the name method, and there is no name method in the working student. Well, but there is in the superclass, and the superclass is the student class, and working student is inheriting from it. So now it can use its methods, and that's exactly what we're doing here. But that's not all that we can cut, because we can make our working student even shorter and preciser, because we have this self.firstName is equal to first name and self.lastName equal to last name. And we have the exact same here at the superclass level, at the student level. And if we have that, then we can simply use the following approach. We can instead say, okay, I would like to use the same approach here as we did in the superclass, and only the ones that I add for the working student specifically, that's the ones that I will need to add manually here at the bottom or below that. All right. So how do I do that? Well, instead of having these two lines in here, I will say super brackets dot underscore underscore init underscore underscore, and here I say first name dot last name. And as you can see now, I'm using this method here, this init method, from another class, and that's only possible because we are using inheritance here. So I'm saying use this init method from the superclass, from the student class, because working student is inheriting from student, and just handed over those two arguments, the first name, and actually I should write the full name, first name and last name. Now, if we execute that code, as you can see, it's still working totally fine. In this case, we only saved one line of code. But what if there were 15 more? Or what if we later decide to change it? Well, then we can still easily change it in the student class, and we don't have to change much in the working student class. And why is this useful as well? Well, let's say we decide in a year from now to adjust our code, because we have realized, oh, well, it really makes sense to also have the term here. So we want to know in which semester a student is. And now I added this self.term, and now if I will use it, or will create a working student, he will also have a term assigned to him. That's why it's so important to use this super approach, because whenever you make adjustments in the student class, well, you don't need to go ahead and make the same adjustments in here. So I don't need to say, okay, I'm gonna copy and paste it in there as well. No, it's already handled. So that's really a great thing to do, because now you don't need to check in the working student if everything is fine and so forth, because, well, you just made it or did it in a superclass. And this here, again, it's a super simple example. You have it all on one page, but imagine there are 20 different classes that inherit from student. So you have the working student, you have the foreign student, you have whatever. Maybe you even have different changes for female or male students, or you have the math student or the whatever in IT student and so forth. And they are all slightly different to the student. Now, if you say, okay, everyone should have a specific information, such as we decide to also add their age to this whole construct, well, then we could just say, okay, self.age is equal to, and then wherever we get that from, let's say we get that from a database or something like that, then we don't need to go through all of the different student classes to check them as well, but we really have everything handled by just using the super approach here. So we're pretty much delegating the whole task to our superclass by using this line here. Now, we had this name method earlier in our working student as well. And that is not necessarily a bad thing. So let's say we would like to have it in there, but now we don't want to display the exact same thing as we did in the student class. So we want to override whatever was entered when somebody is accessing the name method. So how do we do that? Well, we simply write our own code in here. So I'm just gonna return something like working student colon empty space plus self.firstName plus equal or empty space plus self dot last name. So if I run that code, as you can see now, the student John Doe is a working student, so suddenly his text here has changed. So suddenly we get different kinds of information. If I, on the other hand, create a normal student, so student 1 is going to be a student, and it will be Monica Fisher. And if I now print her name, so print student1.name, as you can see, I get Monica last name Fisher. So we have overwritten pretty much a specific method, and you can do that with every single method that there is, except you define that method as not being overridable. Then the inheriting class cannot override that method. But what if I would like to use whatever was within a method of the superclass, but I also want to add to it? Well, then you don't need to use this approach, but you can just say something like super brackets dot name. So call the super method name and then just add something to it, something like bracket or opening bracket plus self.company plus closing bracket. So if I run that, as you can see, John last name Doe ABC company. So this guy now has pretty much the same approach as we had in the student, plus there is some additional information given. So that would be a great example of how to use object-oriented programming, especially with inheritance. So you see that Python is smart enough to understand whether it's talking about a student or whether it's talking about a working student. So it always knows straight away what kind of object it's talking about. But then there is one more interesting thing. Let's say I would like to have, well, let me get rid of that. I would like to have a students array again, or list. And in this list, I would like to add multiple entries. So let me use square brackets because it's a list. And I will have working students in there. And that will be, for example, Max, Miller, and this guy is working for the ABC company. Then we have a normal student who's not working, Monica, and her name is Fisher. Then we have another student, and this is Eric, Barrick, and finally another working student. And here I have to be careful, it's actually student, not student. And that will be Francisca, and her middle name is Brewer, and not middle name but the last name, and she's working for the beer company. Okay, so now we have these multiple students in our students list. And it's a working student, another student, and a working student in there. Now what we can do is we can just loop through them. So for student in students, and now we can just say, okay, print me the student name. So just give me the name of that student that we're looking at. And as you can see, this for loop straight away knows, okay, yeah, now in this one case, I'm talking about a working student, then I'm talking about a student, another student, and a working student again. So in this case, we are using a concept called polymorphism. And polymorphism is based on the Greek word poly, which means many, and morphism, which means forms. And we can use that approach as we do it here. So we can just say, okay, we store a student as either a student or a working student. Why can we do that? Well, we can do that because they are in a relationship with each other. So a working student is a student. So it's inheriting from student. And while this might look a little confusing looking at it for the first time and not having touched on those concepts like inheritance, classes, and polymorphism, we're doing it in a rather quick way, but we will have plenty of examples where we will use that and where you will see that it really makes sense. And this is the approach that you need to go if you want to create extended and big software that will be used by multiple people, for example, but also if you want to use functionalities from other classes that you can then just extend with whatever you want to use. So this is really useful and important, and you will have another example of that in a little challenge for you in the next video. And yeah, I'd say let's get right into that. And as I said, if you don't get the whole concept of all of those things, no worries, we're going to use them and it's going to be good. And see you in the next video. Welcome to the inheritance exercise. In this exercise, you have 2 tasks to complete, and one of them is to implement a file reader class so that when calling the lines method, so as you can see, there is this lines method, the file is accessed line by line, and the lines method should then return a list of the lines in the file. So as you can see, when creating an object of the file reader, we are having a string here. So you might already think about what you need to do. So you need to create a constructor, don't forget that. And well, as you can see, it needs a specific information. And this information that we're giving here when creating an object of the file reader is the path to the file. So this file reader class should be extended in a way that it reads through the file.csv file, which is in the same folder as this as this Jupyter Notebook file. And then you have this expected output, which should be something like surname, first name, Doe, John, Miller, Monica, and so forth. All right. Then you have this class with a pass here. So pass just says, okay, do nothing. And of course, as soon as you implement some code in here or add some code in here, you don't need this pass statement. So you can just get rid of it. Then the second task is to create a class called CSV reader so that the file reader is extended to read a CSV file instead. It should return a multi-dimensional list. And it's important to leave the reading of the file to the file reader and extend the lines method in the CSV reader by the functionality which is needed so that the multi-dimensional list is returned. So now after you created the file reader, and everything is working, so you get this result that you have here, then you can go ahead and create a CSV reader class which should inherit from file reader. So it should take over some of the functionality and then extend the lines functionality, which pretty much means that it should override the lines method that we have created. All right, and the result is what you can see here. So it's displayed in a different way. As you can see here, we have this whole information in one line, but here we have it split into specific lists. So we have a list of lists here. So this list, which is this whole list here, contains the list with first name or surname, first name, then a list of Doe and John, a list of Miller and Monica, and so forth. All right, so good luck with this exercise. Please try to get it done completely. And if you're not sure what to do, then just check out the last videos if you need to get a little better understanding of what inheritance does. And afterwards, if you didn't manage it at all, then you can of course check out the sample solution that I'm providing. And yeah, good luck with it and see you in the next video. Welcome back. I hope you managed to get this exercise done. If you did it easily, then you can skip this video. Otherwise, you can of course follow along in this video. All right, so we have this class file reader, and now our goal is to read a specific CSV file and just output the lines. And what I want to do is I want to start with a constructor. So it's always good to start with a constructor if you already know what is required. So self and file name would be 2 good starting points, because we know self is always required when you use the constructor, and file name would be a great name for whatever this is. So as you can see, we hand over some information, and this pretty much looks like the file name. You could of course say it's the directory or the path, but file name is good to go. So now we can say that self.filename is going to be file name. And now we need this lines method. So as you can see, printf lines. So we need to have a method called lines. And in here, I'm also gonna hand over self as, or assign self as the parameter. And then I need to have the lines as a list. So as you can see, we're expecting a list of values. So I'm gonna open the file now with open self.filename, because that's the path that we are using. And then we want to read it as a file. So we are calling it file. And now we can go through every single line in that file. And once that is done, well, what shall we do with every single line? Well, we want to append that to our lines list. So we have this list of lines and we will append every single entry. And how do we do that? Well, we simply say line. But now the line contains some empty spaces, or it contains line breaks. So in order to get rid of those line breaks, I'm going to strip it. So if you didn't strip it, then you saw different results in the end, of course. And now finally, we said that this lines method should return a list of the lines in the file. Okay, so let's return lines. And by this line here, so this lines method should then return a list of the lines in the file. We already know that we need to use the return statement. Then we know that we needed a list, so that's why I created this lines. And we want to get the results of the whole file. That's why we created this code here. So here we open the file. Here we go through every single line in the file, and here we add the line to our lines list, and we return those lines. Now, if we execute that code, let's do that, and then execute this code here, we can see surname, first name, Doe John, Miller, Monica. Okay, so we have all of this information in here, and it's displayed correctly. So in this file, there is really not that much, as you can see here, surname, first name, Doe John, Miller, Monica. So this is pretty much everything that we have in there, and that's why this is all the information that we get. Now, this CSV reader is the extended version. So we said create a CSV reader so that the file reader is extended to read a CSV file. Instead, it should return a multi-dimensional list. All right, so let's create a class here, class CSV reader. And now here I enter file reader. Why is that? Well, because I would like this CSV reader to inherit from the file reader. So that's why I enter the name here. And then I'm gonna create a constructor again, def init, and I have self and file name in here as well. So I need to know which file we're using, right? And then I'm just gonna say super dot underscore init underscore file name. So I'm just gonna take the constructor from the base, which is from the super class, from the file reader class. So it's pretty much gonna execute the same thing that it does here, where it just assigns the file name. Of course, we could have said file name or self.filename is equal to file name, but this way we make our code extensible. So a lot cleaner for further purposes, right? And now we go through all the lines and we create this lines method. So we have this lines method from here, but we would like to override it. So we would like to extend it a little bit. Of course, we also want to go through every single line, but this time we will do it in a slightly different way. So what I'm gonna say is, I want to have all the lines and I want to use the same approach that I did from this lines method. So I'm just gonna extend this lines method pretty much. In order to extend it, I first call it itself. So I called it here, and now I would like to extend it. And I need to return something. So in order to return something, and the expected result is what I see here, I need to go ahead and create a variable here, split lines. For example, there are two approaches. I'm going to show you the long approach first and then the short approach. So for line in lines, I would like to do something. So I would like to go through my split lines, or add to the split lines pretty much. I would like to append every single line, but I want to split them at the comma. So split at comma. And then I would like to return my split lines. So if I execute that code, and then I execute this code here, as you can see, I'm getting here surname, first name. And as you can see, they are one list within a list, another list within the list, and the third list within a list. So that's exactly what I was wanting to get as a result. And you might say, okay, this approach is all good, but I was very smart and I created this one-liner where you can, of course, return it like this as well. So line.split at the comma. So comma for line in lines. So of course you could have used this approach here as well. So I'm just gonna comment that out here. And as you can see, this is of course a lot shorter, and we just have a two-liner method here. But let me execute the code just to see if it's still working, and execute this code here, the cell block as well. And as you can see, it's still working. All right, so that's pretty much it. We have the two classes, the file reader and the CSV reader, which pretty much just reads from in the same way. So it reads the file first, but then it does something else. So it takes the code that it gets, or the, well, in this case, the string that it gets, and it uses it in a different way. So it just splits them up. And well, that's pretty much it. So I hope you could follow along, and you can even go ahead, and if you didn't manage to get any of that done, just close this video and try to rebuild what you've seen here and try to understand what you're doing there. All right. So see you in the next video, where we're gonna have a look at the types of variables and how to check them. Welcome back. In this video, you are going to learn how to check the type of a variable with the type or the isinstance function. And we will again use the well-known student and work student classes for this example. And as you can see, we had the student class and this working student class, and I've created two objects. So this W_student, which is a working student, and a student, which is a student. Now I'm going to add another line of code in here where I just want to know of which type my working student or my W_student is. So I just use the type function here, and then the variable that I'm going to look at. So I'm looking at this variable called WStudent, and if I print that, I currently get an error. That's because I didn't execute the other lines of code. Now I did it again. As you can see, it says it's of type a class main working student. So now it says, okay, it's of type working student. And we can do the same thing with our student as well. So type and student, and let's check that out. As you can see, class main student. So we now know of which type a student is, and we can do something with it. So for example, we can run specific code based on the type of student we have. So if the type of student that we're looking at is a student, then I would like to run some code. So I'm just gonna say this is only for students. I'm just gonna say something like for non-working students. Okay, so if I execute that, as you can see, nothing happens. But if I now check the same with a student object that we created here, or the student variable, and I execute it, you see this is only for non-working students. So I can extend it with ELIF type on W_student is equal to a working student, and execute something like only for the working students. So if I execute that, as you can see, it doesn't display it. That's because this if statement is already true. So we can actually just say if. So there we are. If type W student is working student, print only for the working students, and that's exactly what is printed here. So you can simply check it with this approach, but then there is another one, and that is the isinstance. So I can go ahead and print isinstance, and then in here I need two values. So one is the actual variable that I'm looking at, and the other one is the class name. So in this case, I could say something like W student or W underscore student, then comma, and in here I need to say of which class I want to, or which class I want to compare. So if I do this, as you can see, I get true return. So it returns a Boolean. This is instance. It either returns true or it returns false. And what it does, it checks whether this variable is of this type or of this class. So in our case, the working student was actually a W underscore student. So W underscore student is an instance of working student. On the other hand, student is not an instance of working student. But now we have another situation where we check is instance student comma student. So is the student of type student? That's fine. But what if I check W underscore student? What do you think? Do you think that W underscore student is gonna be of type student? Well, let's see. And as you can see, yeah, it is. It says it's true. And why is that? Well, that's because our working student is actually inheriting from student, as you can see here. So it's inheriting. That's why a W student or our W student is also of type student. So that's the major difference between a type function and the isinstance function. Isinstance function, this one, it also takes inheritance into consideration, while the type function doesn't do that. So if you want to make sure that it really is of a specific class type, or, well, in this case of our own type, which is the working student or whatever, if you want to be super precise, then the type function is the correct one. If inheritance should also be taken into consideration, then you can use the isinstance function. Why would that even matter? Well, if we have, for example, a list of students, and some of them are working students and others are not working students. We had this before, right? This students array with working students and the normal students. And now let's say that we have a for loop which goes through all of them. So for student in students, go ahead and check if type student is equal to working student. And if that's the case, print something like student.name. So let's run that. And as you can see, we have max worker and Paula worker. So those two, they have this name worker and the other ones are smart asses. So as you can see, max worker is working for ABC and Paula worker is working for the XYZ company. And you could simply use that in order to filter them out and only show the ones that you need, or only adjust the ones that you want, and stuff like that. So that's really one of the examples where you could use type, or on the other hand, the isinstance function. Welcome back. In this video, I would like to touch on a point that's very important. In Python, everything is an object. And, well, numbers are objects. Let's apply the type function to a variable in which we have stored numbers. So we have this a, which is 13. And if I just print the type of a, I can see that it is a class that is called int. So you can see, even if you just create a variable of a number, then you just have this int. Now let's do the same thing with another one. Let's say we have b, which is 12.5, and now let's print its type. So print type b. As you can see, this is of type class float. So there's a class called float, and, well, whenever I'm using a floating point number, it internally just says, okay, create an object of class float. Now that is something that is very interesting. Because now what you can do is you can actually say, all right, let me underscore underscore add underscore underscore 5. So we have this a, which is 13, and now let's just add 5. And if I execute that, well, now I get an error. Name a is not defined. Well, let me execute that code here, and let's execute it again. As you can see, now I'm getting 18. That is because 5 plus 13 is 18. Now, internally, whenever I say something like 15 plus 13, internally, this add method is used. So yeah, you can pretty much see that Python does everything in an object-oriented manner, even if it's something simple as adding two values together and getting an output of 28 here. So you shouldn't use this approach, of course. There is this approach which is a lot easier and smoother and, well, more intuitive, right? So you just need to know, or you just should know, that there is this add method which is within our class int, and also one within a float and so forth. So they all have these methods, and if you would ever want to override them, well, you could. And then we can even use some further arithmetic operations such as subtract. So sub, as you can see now I'm getting 8, or something like multiply, so mul 5. As you can see now I'm getting 65 because 13 times 5 is 65, and so forth. You can call something called a true division. So I can say something like 12.5 dot underscore underscore true div underscore underscore 6.25. And as you can see now, it gives me the result of a true division. Now, that doesn't only count for numbers. You can also check out strings. So let's create a string called hello world, and let's check out the type of that string, type S. And as you can see, we get that this is of class str. So there's a class called str, and well, that class handles strings. So now there is something pretty cool. There's this len method which allows us to go through S, and if I run that, as you can see, it checks how many characters are within this S. So this len method pretty much is within this str class. So internally, what Python executes for this is s dot underscore underscore len underscore underscore, and like this. So this is what's done internally. So it's just a different way of displaying it, but pretty much, as you can see, we have this object s, and then we use this method with the dot annotation, which is called underscore underscore len underscore underscore. Now, due to this internal structure, we can implement and thus control functions such as the len function ourselves. So let's say we have this class A, where we just define this len function, where we say, okay, it should take in self, and now return something like 6. Now my instance is going to be an A instance. I'm just creating an instance of this class A, and now I'm going to use this len function and onto my instance. So as you can see, it gives me 6 as a return. And internally, pretty much what I'm doing here is instance dot underscore underscore len underscore underscore. Okay, so this is pretty much what has been done. But if I execute that code, well, there you are. We get this 6. Alrighty. So as you can see, in Python, everything is an object. So whenever you use len method or any type of division, multiplication, and so forth, just remember that in the background, all of it is handled with methods of classes and so forth. Welcome back. In this video, I would like to talk about naming classes and variables, a little style guide. So basically, it doesn't matter how we name a class, variable in Python. Our program will work anyway. So it doesn't matter for the code, except you make real big mistakes. But generally, you can pretty much call them as you like. But for Python, there are some style guides and how we can write nice code. And in this lesson, I would like to go through the most important points, how you should name variables, classes, and functions, especially if the name should consist of several words. So this is pretty much where real problems come in, is when you have names that are consisting of multiple words. And in Python, this is done by convention, either with Pascal case or sneak case. In other programming languages, camel case is used quite a lot as well, but in Python not so much, or not at all. So class names in Pascal case. So here, as you see, you have a little example. This is too long, seriously too long. Well, you should use Pascal case for classes, but you shouldn't have these long names. So instead of having this super long name, it should be maximum like this is 2. In the sense of it should be maximum 3 words on next to each other, and it shouldn't be like 20 different characters or something like that. Okay. And then function names should be written in sneak case. So this means I underscore am underscore a underscore function would be an example for sneak case. But again, it's best if you write something, or if you have a name such as get underscore name. So if you want to have the name of a person and you create a function for that or a method for that, then call it get underscore name or get underscore company underscore name. That would be fine as well. But don't add something like get company name in case whatever color is red. Of course you can call it like that, but that's really difficult to read and it's not a very good name. Of course your name should be descriptive, but don't exaggerate it, okay? And then variable names also in sneak case, but at most 3 words. So we have this several words is a good example, several underscore words, and not more than 3. And as you can see here, this is too long, seriously too long. It's really a very, very bad name. So don't do that. I just wanted to show you what not to do and what to do. So make descriptive names, or use descriptive names, but don't make them too long, and use Pascal case for classes, sneak case for functions and methods, and sneak case for variables. Welcome back. In this video, we are going to check out static variables, and we can bind variables to classes instead of instances. What does that even mean? Well, let's have a look. Let's create a new class, and I'm going to call that class car, and that car is going to have a price, and I'm going to assign expensive to that car. So this car is going to be expensive. Now, if I create an object of my car, I can go ahead and say something like print c.price. As you can see, now I have access to that variable here. So I can directly access it, and I can even change it. I can even say something like c.price is now going to be cheap. And let's print c.price again. As you can see, suddenly it's cheap. So this is not secure. That's one point. And this is true for all cars. So let me create another object of a car, and this is going to be a Bobby car. And now the Bobby car, let me print that again. So Bobby car.price. As you can see, the Bobby car now is cheap as well. So if I change it anywhere, let me print that here at the top. So I'm gonna do it like this. So I execute it here, there, and there. As you can see, if I change the price of any car with the static variable, then all of the objects of that class will have the same value for that variable. And that is pretty much the name of, or the whole concept of a static variable, that it does exist once in the whole, pretty much whole context. So this price is going to be unique for all cars. It's going to be always the same. It's always going to be expensive. So this price is going to be static in terms of it will be the same for all objects. Now, this approach can work. There are cases where it makes sense to use static variables, but usually you should still use our good old approach of saying def underscore underscore init underscore underscore self dot price is equal to something like expensive, for example. And then we can now go ahead and create an object of our car I and now print the price. As you can see, we get expensive. Okay, that is super important to understand, that this is going to be different for different objects. So if I have something like price in here, and now let's say yo is going to be the price, just as an example. I'm not going to set it in here. I'm going to set price in price. As you can see, now it's yo, and then the next car is going to be car I bow, and now let's print the price of D. As you can see, now we get bow. So the price here is unique, but if I would go ahead and create something like color, and it's going to be blue, now print C dot color, and I'm going to do the same for my D car. As you can see, now it's going to be blue for all of them, and this should be D like that. So it's going to be blue for all of them. We cannot define it. We cannot, well, change it with this in constructor because it is a static variable. All right, so that was just a quick look at static variables and what they are. So in the next video, you are going to have a little challenge. So good luck with that, and see you in the sample solution. Welcome back. In this video, we are going to check out the sample solution for the last exercise, and I hope you went through it successfully. So first of all, we had this task to model a cube. So create a class cube to model a cube. The cube class should have the length of the cube side as a property. In addition, the class should have two methods. The method volume calculates the volume and outputs it, and the method surface surfaces or calculates the surface and outputs it. So first of all, we needed, of course, a constructor with the side as a property. So we have the side, and we say self side is equal to side. So whenever we create a cube, we need to give it a side. And as you can see, we gave it the value of 3. Now, in order to calculate the surface of the whole cube, we need to do the following. We need to multiply self side, so the side of our cube, with itself, and then multiply 6 to it, because we have 6 sides in a cube. Now that is one approach to say self side dot multiply with self side, or you could use what you have just seen, double multiplier. So multiply or double star means exponent 2. So that's pretty much what we did with this double star. So then we have the volume, and the volume is pretty much multiply the side with the side with the side, and that will give us the volume. And of course, we could have done it like that, where we printed like this, as I just said, with side multiplied with side multiplied with side. So I'm gonna say like that. So that's one approach, and the other one is to use the exponent, which just says, okay, multiply yourself 3 times with yourself, and that will give us the result. So the volume is going to be, in this case, 3 times 3 times 3, which gives us 27, because 3 times 3 is 9, times 3 is 27. And now this here is 3 times 3 is 9, multiplied with 6 gives us 54. So this is the surface and the volume. All right, so next we had to model a sphere. The ball class should be given the radius as a property. It should also have 2 methods similar to the cube. Surface, to calculate the surface content of the volume, and then of course the volume to calculate the volume. So we have surface to get the surface, and then volume to get the volume, of course. In order to perform these calculations, you need the circle number pi. This is available to you after an import math under math.py. What the import command exactly does, we will look at later in the course. So you will see how to use modules in a later part of the course. You can look up the formulas for the surface content volume of the sphere on the internet. So we needed to get the math class pretty much, or the module math, and then we can use pi. So as you can see, math.pi, and here you also see the precision. So it's only a specific precision here. It's not limitless, but it's a good precision, or good enough precision for our purposes. So we import math, and then we have this class which is called ball, and in there we have, first of all, of course, our constructor, and this one gives us the radius, or we need the radius, and we just assign it here, this property radius. Then we have the surface, and the surface is 4 times pi multiplied with itself, or with the radius of itself, and multiplied with the radius again. So instead of this, you could have, of course, also said multiplied with self dot radius. All right, then the volume, that is, and I'm gonna show it like this, or 4/3 of math.pi multiplied with self.radius exponent 3. So now if we calculate that, you see we get the surface and we get the volume with a ball of radius 4. So these are the values that we get. All right, number 3, model an account. Create the class account with the property credits. This property is initialized with a starting capital. The method display should display the current account balance. So then we have this class account, and we have the initializer, and as you can see, the start here is not what we use here. So we say credits is going to get the value of start. So whatever we enter when we create an account, that's going to be the starting credits, so the balance that the user has or the customer has. And then we want to display that, so we just say def.display or customer.display, and we display self.credits. So we just print the credits onto the console. All right, B, add 2 methods, pay in to deposit, withdraw to the withdraw to the account class, so that you can deposit and withdraw funds, and the account balance will be adjusted accordingly. I just want you to be able to withdraw money while there's money in your account. You cannot or you can't go into debts. In this case, an error message should be issued or appeared, and stating the maximum amount of money that you can access, or that can be accessed. So let's have a look at this class again. So we had this init, that was fine, the display method was fine, and now the pay in method. So you can pay in money, and that will be added to your credit. So that's what this method does here. And then you should be able to withdraw money, but in here we need to check if the money that we are trying to withdraw is not more than we have in credits. And if we have more money than we have as credit, or that then is there as a balance, then we can still go ahead and withdraw money. So this, it will just take away the money from, or subtract the money from the account. But if we don't have enough money, then it will tell us that we can only withdraw the credits amount. So that's what it says here, str self.credits. And here this $sign should be on the other side in American language. Okay, so then we have this customer. We create him with $500. We display how much money he has. Then we add $40 to it. We display once again, as you can see. Then we withdraw $25 and we display it again. And then we try to withdraw $600, and then it says you can only withdraw $515. All right, now let's look at C. The account is still unprotected. We need a PIN. In the class, add the property PIN. As with the initial capital, the account should be initialized with a PIN. From now on, you have to enter not only the amount, but also the PIN when you withdraw money. Only if the PIN matches the PIN of the account, money can be withdrawn. Otherwise, an error message will be displayed. So as you can see, we have this code here that we had before, pay in, and now withdraw. Well, actually here we added the PIN. As you can see, we added it as a property in our constructor as well as here. So whenever we create a new account, we also need to enter a PIN. And then we have this withdraw function or method where we need to check the PIN first. then we check how much money is left. If it's enough money, we can withdraw. If it's not enough money, then we get this information about we can only withdraw that and that amount. And if we entered the incorrect PIN, then this account or this text will be printed. So wrong PIN, account blocked, you're under arrest, put your hands up. So freeze. So it's pretty much what we're saying here. Then customer, well, pretty much the same things that we did before, only that now we have this super secure PIN of 1, 2, 3, and 4. So nobody will know how to withdraw money. And now finally, if we enter 1, 2, 3, 4, 5, then, well, of course, we go to jail. Okay, so now let's model a train. That's exercise number 4. And now you will build train objects. Create these the class train, which is initialized with the properties route and position. Route is a list of the train stations. Position stands for the index of the station from the list from which the train is currently or last departed. Where exactly the train is on the line between two stations is not of interest to us. With the method show station, the name of the station should be output. Okay, so we have this class train, and we have an initializer with the route and the start. So the route is this list. As you can see, Orient Express train with the list. Paris, Budapest, Bucharest, Istanbul. And then the start is the index at which we start. So here it's 0. So we start at Paris. And then show station will tell us where we currently are, so the position, and it will check it within the route. So as you can see, we have this route list, and then we check the position where we currently are. So let's say we are at position 2, which means we would currently be in Bucharest. Okay, so we start off in Paris. Now, so far, a train of the class train is still stuck in its starting station. Now add two methods, move and move back, to move a train on its route to the next or previous station. The train must not leave its route. Okay, so what we need to change here? Well, we need to add this move method. And what does it do? Well, it checks the position, and if it's lower than the maximum, so let's say we have only 4 entries in there, then we don't want to access index 4. We maximum want to access index 3, and that's what we are making sure in this if statement. Okay, because it starts with index 0, and the length, let's say the length is 4, then the highest entry in there will be 3. So that's what we're checking here. We only are checking up to 3 and not higher than that. Okay, and then we just say, okay, if that's possible, so if you still can go further, then just add 1, and otherwise just say something like final destination, leave now. Now, if we want to move back, we do the opposite. So we just check, okay, are we at a higher station than 0 than our starting station? If that's the case, then we can go 1 down. So we can move back to, let's say, from Budapest to Paris, or from Bucharest to Budapest. And then that's what we're doing here. So station, move, so station, move, and so forth. And then we have here move back, where we go back from Istanbul to Bucharest. All right, now see, it should be possible to edit the route later by using a bypass station method, which makes a train leave its route to be on the safe side. The train should then be moved to the start of the route unless it is already there. So a little tip here, remember the methods for lists, okay, the approaches that we had there. All right, so what did change towards the last one? Well, we have this bypass station method, which takes the station that we're currently at, and if the station is in self.route, then we want to remove that station from our route, and we want to go back to position 0. So as you can see, we say here train, and then we bypass a station, so we bypass Budapest, and now we move, which means now we are not in Budapest, but we are in Bucharest. So we skipped Budapest pretty much. Good. So that's it. I hope you could manage to do that. And if you didn't manage all of them, that's totally fine. But just try to figure it out once again. So just stop the video and try it once again. And otherwise, well done. Good job. Even if you just managed some of them. And in the next chapter, we are going to look at modules. So we have used a module in this video even, which was this import math. And we will use other ones as well. So we will use plenty of other modules in the next chapter. So see you there.